And there we go. Hello everyone. Hi Jeremy.
Hello.
How are you?
Great. How are you doing, Stefano?
Fine. Great. So
welcome everybody who's attending today. We have Cassandra Day Singapore. Thank you for taking some time on a Saturday. Hopefully everybody is doing well. I know that we have some pretty crazy circumstances right now with COVID around the world, but we want to give some good training and education about Cassandra, the open source distributed database today. And let's go ahead and get started. Welcome to everybody. And we have some initial slides to just get you familiar with what we're doing today. Today, we're talking about Cassandra with the Apache Cassandra project. This is its logo. And what is this Apache Cassandra? You can see in this eye, there's different nodes in a cluster. Cassandra is a distributed decentralized database. It was first developed in Facebook for messaging, and then they kind of threw it over the wall into the open source community. And now for the last 12, 13 years, it's been a top level Apache Foundation project. I've been around in the community since about 2010, helping with the database. And just to give you some high level idea of what this database can do, it's able, like it looks like in the picture, you can have any one of a number of servers that can be part of a data center and all around the world. So you can have active in any data center, in any cloud, all around the world. It's elastic with its linear scalability. So if you need more capacity or throughput, or you can just add more servers, your entire data centers can go down, or individual servers can go down for maintenance, or for if there's a disaster or hardware failure, or links go down, and the database will continue to run. Like I said, you can geographically distribute this all around the world, and it's very, very high throughput and very, very low latency. So anything that backs a mobile device or a web page, a lot of applications like Instagram, Netflix, Apple's iCloud, run on Cassandra, even Uber and others. And it's vendor independent, which is nice. So it gives you some confidence that you don't have to feel like you're locked into a specific software vendor, and you can still get the performance and capabilities that you need. So let's keep going here. So who uses Apache Cassandra? Netflix, Apple, Alibaba, Tencent, Instagram, Uber, lots and lots of companies around. I am located in Sydney, Australia, and I help out with a lot of companies in the Asia Pacific region. I've helped out with a lot of companies in Southeast Asia. In fact, in Singapore, there's different banks and financial services organizations that are currently running Cassandra today. Lots of different streaming services. We're working with lots of different companies around the area, retail, travel, like Airlines in Singapore also use Cassandra for a variety of purposes. And we'll go into some more details a little bit later. To give you an idea, 98% of the streaming data that for metadata, when you pause and you continue, the account data that you have in Netflix, all of that data is stored in Cassandra on tens of thousands of servers, operated by about 8 or 10 people, which is pretty impressive. Apple, this slide is a little bit out of date. They have about 250,000 instances of Cassandra, storing everything from gift card redemption data to iCloud to store data. So everything that's backed in iCloud is probably going to be stored in Cassandra. Lots of operations per second, lots of data. So if you have a data problem, you have scalability needs, low latency, Cassandra is a really good solution for you. So today's agenda, so kicking this off, we have the welcome, which is what we're in right now. And then we'll go into a workshop that introduces you to the database, gives you a breakdown of what makes it work, so you can have an idea. This isn't magic. This is actual, software development, just in a different way that is refreshing. Then we'll have a break. We'll have a quiz where you can, demonstrate some, how much you've come to understand about the database and win some swag. Then we'll jump into data modeling with Cassandra. And then at 3:30, we'll have an Ask Me Anything session. So everybody involved with this day is going to be part of an Ask Me Anything session. We'll talk about that in a second. And then we'll do some application development with Cassandra, using different APIs and familiarize you with how you can write your app quickly with Cassandra. And then we'll spin down for the conclusion at 5:15. So there will be a quiz at 1 p.m. and that you can get a prize there. There's going to be an Ask Me Anything session. You'll get a prize there, and then everybody will be able to get a certification voucher for getting certified with Apache Cassandra as a database, officially certified to put on your CV or your resume as a developer or as an administrator. So there's a certification process there. Who are we? We are part of DataStax developers, and here we are floating in space. Here's Alex, who's going to be here shortly, and Stefano, just having a good time in space with their toolbox. And we are here to connect every developer in the world with the power to the power of Apache Cassandra. That's pure and simple. I mean, we have things that we do for our jobs to try to help people. That's basically what we do, though, is to help people. I've spent lots of nights trying to help people make sure their clusters run properly, that they develop efficiently, get the most out of the database. And so this isn't really a commercial session. This is more about the community of Apache Cassandra. This is a little brief about what we are, who we are. This is how you can contact us if you need anything, but we're on GitHub and LinkedIn and Twitter. We're all Apache Cassandra experts and educator. Alex is an educator. He's based in Germany. He'll introduce himself in a little bit. And a cloud architect. Stefano is based in Italy, northern Italy, also a developer and architect. And then I'm based in Sydney, Australia right now, and also a developer and architect. So we're all happy to help you in whatever you need in this process. So from a logistic standpoint, if you have anything that you need, there will be the contents of what we're presenting today will be on YouTube, and they will be recorded. But while this is a live session, you can ask questions on YouTube in real time, and we'll try to answer them the best that we can. And then there's a mailing list. So there's a lot of these shortened URLs that you can do. There's a bunch of workshops that are out there on datastax.com/workshops. Discord, if you're familiar with Discord, the kind of the real-time chat. We have a Discord channel for workshops and for Cassandra questions. So if you're kind of in the trenches and you don't know what to do, feel free to ask there. There's somebody going to be there 24 hours a day, pretty much. There's a forum. This is kind of like a Stack Overflow style of asking and answering questions. And then we have free development courses that are at your own pace to prepare you for the certification exams. And then there's the YouTube channel that you're currently on, most likely, viewing this live link. So the Ask Me Anything section. So dtsx.io/CD Cassandra Day Singapore -QA, and you can submit your questions. And so you can ask questions in real time. Don't worry about that. We can answer whatever questions that you want. But if you have a question that you're dying to have answered in depth, about Cassandra, about where it's useful, about like either limitations or capabilities or how it fits into an overall data system, we're happy to answer all of those in our Ask Me Anything roundtable session. And you'll get a prize for the top voted questions or the best questions, but just don't forget to put your name in there so we can give you the prize. And then, like I said, Discord, following this, I mean, obviously there's the YouTube section that you can put in questions in real time, but following this session, the Discord room is a great place to ask those questions afterwards. So, and then, like I said, there's you know, a koala that's winking at you from here in Australia, and he's happy now because the fires are no longer going, and he will send you a prize for the quiz. So if you answer the questions and if you're quick on the responses for a Menti themed quiz, you will get some prizes.
Yeah, Jeremy, if I may say something.
Sure, go ahead.
So hi everyone. Thank you for the introduction. Just want to stress one thing. Cassandra Days are about Cassandra. So our goal is we want you to get to know Cassandra as much as possible and to start using this marvelous database. So this is our mission, but obviously we also want to have some fun while we do that. So today there will be a lot of very deep information, very useful information to get started. But in the middle, we will have a quiz, we will have some fun. So get ready, be fast, and if you're fast, you might win prizes. So yeah.
Thanks, Stefano. Cool. And besides that, if you're interested, there's some exercises that accompany today, so that it's not just the content and you're not just sitting there taking it all in and just having us talk to you or talk at you. There's exercises that you can complete as part of today, and you can get a badge that you can post on on LinkedIn or whatever, or just, you know, your own satisfaction of getting getting involved and hands-on with this database for, like, if it's your personal interest or your job, and you get one of these badges. And then similarly, like I said, you can get a voucher for taking a certification exam, so that if you're interested in getting to know the database in more depth as a developer or as an administrator, there's these free vouchers. And I think those vouchers usually cost about $190 US dollars.
It's $145 to take the exam. But yeah, so for today we sponsor taking the exam for free to all of you. You will still have to go there and learn something which is given for free in the Academy of DataStax. So go ahead, because as Alex likes to say, and he will soon appear on screen as well, if you can put on your resume as Cassandra certification, on average, you will have a higher pay. So you will differentiate your resume and you will be more competitive on the market. Plus, it's a very cool database, so it's cool to learn it.
Yeah, you find out how a lot of these companies are scaling. Personally, it's just really interesting for me, because some of these, like banks and retail organizations, they have literally hundreds and thousands of servers running this software working together, and it does a lot of really cool stuff for you. And in that first session, you'll start to understand a lot of it's kind of some detail about how things get done underneath, but it does most of all of that for you. So I'm excited for you guys to come to understand the database a little bit better. So enjoy the day, have some fun, and I'll turn it over to Alex and Stefano.
Thank you, Jeremy. Thank you. Okay.
Okay, I should have turned on my mic. So hello everyone. Hope
it was
now
good. It was good. Oh no.
It was good for you, but now it's good also for attendees. Yep. Yeah, but now indeed that is good. Always check sound levels. That's Alex Volishnev, developer advocate lead at DataStax, and welcome to Cassandra Day Singapore. And that is the opening. That's the first workshop of the day, and it's a very important point for you to start. Thank you for joining. And I believe we can proceed with that right now. So we start Cassandra fundamentals. So I'm Alex Voloshev, developer advocate lead, and I will run this workshop and also later application development workshop for you. And as Jeremy mentioned, Apache Cassandra is used by the biggest, best known, and very big companies solving their problems with Apache Cassandra in the world. Why that, and what are the main features of Apache Cassandra, what Apple, Netflix, Instagram, and many other companies are not are using that, not some our databases. Well, usually big companies use multiple databases. That's right. But for Netflix, for Apple, Apache Cassandra is one of the biggest and the primary databases, of course. First of all, it's big data ready. It's ready to work with the data of a huge size. For example, Apple uses Cassandra and stores in Cassandra hundreds petabytes of data, and that's their words, not mine. So as you see, data volume can be really huge if you is one of the biggest companies in the world. Second, highest availability. Not just high availability, but highest availability. And that is matter because in the end, reputation is everything. And companies want to be all the time available. And that's definitely one of the primary Cassandra features. Then geographical distribution. With Cassandra, you can easily have multiple databases, multiple data centers within the same cluster across the world. And so you will keep your data close to your clients, even if you have clients in Australia, in Singapore, in Europe, in America, you can have multiple data centers actively communicating with each other. Then read-write performance. It's, of course, very fast database, that is clear. And one very important point, it's open source software, vendor independent. Apache Cassandra, call it Apache, because it belongs and controlled by Apache Software Foundation, well-known open source foundation, non-commercial, non-profit organization, which helps and maintains open source software like many other, maybe know Apache Kafka, for example, Apache Pulsar and our technologies, and Apache Cassandra is one of them as a top-level project, originally developed by Facebook, but then contributed to Apache Software Foundation. So, Cassandra is very fast, very reliable, and so on and so forth. How exactly it works? First things we have to understand is Cassandra is distributed. So the data is spreaded and data stored on multiple servers. Data is replicated into multiple machines. Cassandra can have multiple data centers delivering not just fault tolerance, but disaster tolerance, the true level of highest availability, and it is masterless. So how many master servers does Cassandra cluster need? Answer is there are no master servers. That is masterless database, decentralized. There are different ways to scale your database, and usually databases go with vertical scalability. Vertical scalability means when you need more firepower, when you need your database to be faster or to handle a bigger volume of data, you replace your previous machine with a bigger server, more powerful server. And this scalability type is easier to organize, but it's soon getting very expensive because top-level database servers are extremely expensive. And it's still single point of failure. And Cassandra chooses a different way. Cassandra prefers horizontal scalability. Horizontal scaling requires multiple less expensive commodity hardware. So instead of replacing previous server with a bigger one, you just add next server of the same size next to yours. It's cheaper and it removes single point of failure. It's logistically harder because now your data has to be spread over multiple servers, but don't worry, Cassandra takes care of it. It's not your job. I'm a lazy engineer. I love it when database take cares of things like that, and not me. So Cassandra scales horizontally, but that's not the only thing. Cassandra scales linearly, and that's what really matters. It means if your data model is right, and we will discuss data model a lot with Stefano in his workshop a couple of hours later, then if you want to double the computational power of your server, of your cluster, you just have to double amount of servers in this cluster, and that is really cool. So take a look. There were a great research done by Netflix. Netflix is one of the biggest Cassandra users, and by the way, their Netflix tech blog is amazing. If you are not yet subscribed, then go do it. Because they just like incredible how they share their knowledge in the world of those technologies. So Netflix did a research for Cassandra linear scale up, raising amount of servers from 45, if I'm not mistaken, to almost 300 within a single cluster, and counted the performance of this cluster, and take a look at this incredible, nice, smooth line. What that means? Zero overhead on adding new servers. And trust me, it's a rare feature in the database world. Most of the databases introduce some downscale on this line. It's never so straight as it with Cassandra. So, very primary feature of Cassandra is the distribution of the data. Okay, but why do we need that and how it works? Idea is very simple. With traditional relational databases, which you mostly probably know already, at least some part, full copy of every table is stored on every server. And if this amount of data is too much for this server, you have to go sharding. And sharding on relational databases are very, very complex mechanism, very painful mechanism, I would even say. And it's a very manual mechanism. And every time you do any changes in your database, you have to reshard things. It's a painful process. There are no more joins over shards and so on and so forth. Cassandra works differently. Understanding what Cassandra is big data ready, it means what the amount of data in cluster can be tremendous. As I said, Apple stores hundreds petabytes of data in Cassandra. So this way we spread the data, we spread the tables over cluster. And as here on the previous slide, we have this table, a very simple table, population per city per country. So New York amount of citizens, Los Angeles amount of citizens, and so on. And these table, as all the other tables in Cassandra, are distributed by partitions over the cluster. And that means what, first thing, not a single node stores a whole table. It allows us to have tremendously huge tables and still be able to handle them. And second point, when you add more nodes, data is reshuffled over those servers, so you can have more and more volume capacity of your cluster. And what defines this distribution? Distribution is defined by the partition key. Notice how data is stored here. France, United States, Germany, Canada, and so on. They are grouped by country. Who defines that? The point is, then you are creating a table, you must specify the partition key. And partition key is a column or multiple columns. Those will define partitions. Now, how it works? There is a partitioner which calculates tokens from partition keys. Partition key can be basically any value, string, integer, doesn't matter. But token always will be integer. So it's just a murmur-free hashing mechanism which converts everything, like strings, into integers. Why do we need them? Take a look. Within the cluster, every server is responsible for the range of tokens, known as token ranges. For example, in this case, I have an example of 4 servers, and therefore, if we say what token ranges are from 0 to 100, which is basically not right because the numbers are very, very huge, but just for the simplification, let's say it's from 0 to 100 or from 1 to 100. Then in this case, as I have 4 nodes, first Cassandra node will be responsible for the token ranges from 1 to 25, second from 26 to 50, 51 to 75, 76 to 100. And then we can see what tokens on the right side. We have Sydney, Australia, 59. It goes to this server, right? So this server will store information for Australia. Then Toronto and Montreal, number 12. They will go to this server. And finally, Germany, 45, will go to this server. And third one will be without any data, considering such a small table. Now, that is a very important thing. Cassandra is very smart and very automated. If I add a new node, if I need more computational power or more volume, then Cassandra will recalculate token ranges automatically and reshuffle data over the cluster automatically. And therefore, this one will be responsible for 1 to 20, 21 to 40, 41 to 60, 61 to 80, and 81 to 100. The same way it works if you want to decommission your cluster. For example, many companies don't like to pay too much for their infrastructure. If you want to if you know what will be a quiet period, you don't have too many customers, and you can save on your cloud costs, for example, by just decommissioning server, and Cassandra will reshuffle things back into a smaller cluster with bigger token ranges. And then you know what there is new, like Black Friday or anything is going to happen, and you are a Netflix and you are going to release a new season of the Game of Thrones, you know everyone will be watching that, then you want to have more servers and you can add more servers, and it's all automated, and Cassandra manages this shuffling. If you have this experience like I have with sharding on relational databases, you must know how it feels, how amazing it feels for databases doing that for you. It's indeed just incredible. So, data is distributed, but that is not enough. What happens if part of the data will be lost? What happens if a server is not available? If you are long enough in business, you know what the downtime of a single server is just inevitable. So data is replicated. What does that mean? It means what every piece of data is stored on multiple different machines multiple times. When you create a key space, I will explain later what is the key space, but for now we need to know just what key space is: a group of tables. When I create table, I must specify replication. And for replication, I have to define network topology strategy, I will explain later, and replication factor per data center. In this case, I have, let's say, only one single data center 1, and I set replication factor to 3, which is a recommended value. It can be, for example, 5. It can be basically any reasonable number, but we usually recommend to stick to 3 per data center normally. 3, maybe in some cases 5, but it's a more rare use case. So how that works? As I say, data is not only distributed, but replicated. Replication factor 3 means what every row, or better to say every partition, you will soon learn why it's so important. Every row is stored on 3 different nodes. So in our case, we have here three different servers responsible for our Canada partition. How it works within? As we have three servers responsible for this token range, that means what for data, we will have three replica servers. And then someone, for example, tries to store data, node receiving the request. In this case, we see what it's not responsible for this set of data. Then, but this node is smart. Every node knows schema, the token ranges allocation over the cluster. And this node sees, okay, that's token 59. I'm not responsible for it, but I know those who are, and it will just transfer this data to the proper replica nodes, and they will be happy. Now, funny point, normally that never happens. The trick is not only Cassandra nodes are smart and understand who owns the data, but also Cassandra drivers are smart as well. So normally then the driver never contacts some non-replica node. Usually driver always contacts directly the server, what is responsible for this data. This allows to avoid one network operation, of course. But let's say, but you can ask any node in a Cassandra cluster for any piece of data, despite it's partitioned and distributed. Still, any node able to answer any question. Doesn't matter if it's a read request or write request. Just if you reach the proper node which is responsible for your current token range, then it will be -1 network operation, which is of course better, but you can reach any of the nodes and it will work for both writes and reads. That's why Cassandra scales so great for writes, for example. Many databases are good at scaling for read operations because it's easier, but for writes, there are, let's say, not so many competitors. What happens if one of the replica nodes are not available? There are multiple layers of defense from this situation in your infrastructure, I believe, but still, it always can happen. What happens if one of the replica nodes is not available during some time? It means it doesn't receive updates, inserts, updates, so any kind of mutations what change data, delete, insert, update, everything what change data won't reach it. And as a result, we may have cross-node inconsistency. What does that mean? Take a look. Those two got the update, but this node was on fire, was stolen by aliens or something, I don't know, and it didn't get the update. And there are also many layers of defense from cross-node inconsistency in Cassandra. First layer, call it hinted handoffs. Hinted handoffs is a great mechanism. Hinted handoffs help you to auto-recover and not even help you. They do the self-healing, auto-recovering without you have to do anything. If a failed server recovers within a couple of hours, those hinted handoffs will be delivered to it fully automatically, and you don't have to do anything. It's a self-healing and cluster recovering itself. It is amazing. Well, and there are some more multiple layers of the defense from inconsistency we will discuss later on. So, data distributed everywhere. That means you can have multiple data centers. And those multiple data centers are always active. So there is no idea like with some databases you may have single data center is active and second data center is passive and only receive updates, but you cannot write to this data center. Not like that with Cassandra. As I said, it's decentralized and every node bears the same duties as all the others. So every node can receive updates, inserts, writes, whatever. And then it distributes data to other data centers as well. It allows to global companies like Uber, for example, keep their data close to them customers, giving a very good response time. For example, if you travel from Asia to the United States and you are traveling to airport with Uber, and you get to the airport by Uber, have your flight, then with Uber you get to your hotel, for example. You will work with the same cluster. Your Uber application will work with the same cluster, but with different data centers. The one which is closer to you, which is obviously the best way to work because you don't have to wait too long. Then one more thing. Yeah, and I see Federico Palma says interesting, and yeah, I really like it. It's indeed one of the most powerful databases we have at this moment on the database field. So hybrid cloud and multi-cloud. Cassandra is an Apache project. It's platform agnostic. You can have it running on your own data center. You can have it running on Google Cloud, Microsoft Azure, Amazon Web Services. And fun fact, you can have it simultaneously. So your single cluster can be running on multiple clouds, getting this multi-cloud or hybrid cloud connectivity. For example, let's say this United States one can be Amazon Web Services. This one in Europe may be Google Cloud Platform, just because European GCP may be cheaper, let's say, or we want to have some redundancy over the multiple clouds. And this one can be your own data center on premises, and together they form this cluster, which consists of multiple data centers. And that's a very powerful approach, of course. How it works with multi-data center replication. Considering we have replication factor 3 in each DC. First, we get data to one of the nodes. Node currently processing your query is called coordinator node. And there is always people asking, how is that coordinator node designated? And answer is each node what receives a query will become a coordinator node for this query. So that's not like a master server or something like that. No way. Just the node what got your query will be coordinating it. And every node at some moment of time is the coordinator node as it's received some querying. Drivers have some load balancing mechanisms, so they can ask multiple different servers. Okay, so coordinator node, so the node got the request, it becomes a query coordinator for this query. It will do two things simultaneously. First, it will send the data to all the replica nodes of the current data center, and also it will execute this call to a second data center. That's all executed asynchronously in no blocking way, and that's a very fast mechanism, of course, very important mechanism. As soon as data received by all replica centers on data center west, its job is done. Meanwhile, remote query coordinator start its job and distributes the same way data over data center east. And data is stored, so all of our replicas got the data, all of our servers got the data. Good. So, understanding use cases. Everything what belongs to the scalability field when you are going to have or a lot of data or a lot of output or both. And it may change. In the beginning, you have not too much. In the end, you have a lot. That's perfect scenario as Cassandra scales very well and servers are very performant. Heavy writes, heavy reads. As I said, Cassandra is scaling also very well for write operations, not only on read operations like most of the databases do. And any kind of a scenario when you have a lot of writes, a lot of reads, or you require linear scalability to have more and more and more and more and more, that's a perfect scenario for it. Then availability, everything about mission critical. For example, one health institution in Germany using Apache Cassandra, not because they have so huge data or not because they are globally distributed, it's a German company, but they work like as a health institution, medicine purposes. They want their data to be always available. Whatever happens, database must work. And that's a very good example because it's maybe a question of life and death, literally. So everything what belongs to mission critical availability, having no data loss and having always on database. That's of course very a lot about Cassandra. Distributed. If you need to have global presence or workload mobility, or for example, compliance and GDPR purposes, your data must be located in some specific data center of some specific country. That's also perfectly possible with Cassandra using different key spaces allocations for replica factor for different data centers. If you don't specify a replication factor for, let's say, United States East 1 data center, there will be no data storage for this key space. And cloud native, everything what we mean about the modern servers, modern applications, cloud, Kubernetes, and so on and so forth. Cassandra is a great fit for that because it's natively supports hybrid cloud, multi-cloud, multi-DC. Good. Stefano, are there any good questions we have to answer by voice?
Well, I was about to interrupt you just to remind everyone who is listening and watching us of a few things that came up between the YouTube chat and the Discord. First, yes, somebody asked if this is going to be recorded. Yes, it will. It is, and you will be able to watch this later on this same link. This is one thing, so you can rewatch it at your own leisure, whenever you prefer, and everything. Then there was a nice discussion. Somebody mentioned, yes, data is replicated on multiple machines, multiple nodes. So if your main servers goes down, you're still good. That's correct, but not entirely correct, because there is no such a thing as a main server, which is even better. So as I wrote in the chat, all nodes are created equal. So there is really no main master server at all. So every server is as good as any other. So that's even a well-distributed resilience to failures. So yeah. Other than that,
sorry. Let me add a point here. There are a lot of people with a relational databases experience, and you mostly probably use it to the situation what within your cluster you have master server and secondary servers. And you can write and read to master server, and you can read only from secondary servers. That's a relational database paradigm, which doesn't work with Cassandra because in Cassandra, exactly as Stefano said, all nodes are created equal. There are no master nodes, main nodes. There are no secondary class citizen. Every node is able to answer every request. That's basically peer-to-peer mechanism. And it's a very powerful mechanism. It means when your driver tries to contact some server, and it find out what the server is not available because of network issue, power issue, or whatever, it will just reconnect to a next server or next server and still will be able to store and retrieve some data. Of one of the demo we did in Developer Day in France a couple of years ago when we were able to travel. We did incredible demo by wiping out the whole data center. And what happened to our demo application? Nothing. It simply switched to the next available data center because we had 3 of them within the same cluster. What matters? No main servers. Forget about this concept. Cassandra is a true democracy.
Yeah. So if I may add something, you say the master-slave architecture is the relational database paradigm, and it's true, but it's not only that, because there are also many NoSQL databases that are still based on this pyramid, so bottlenecked architecture. So Cassandra is not like that. And just to conclude, sorry, Alex, this is important. I see not many questions on the chat, but I had a look at the Cassandra Day Singapore question site where we collect questions, and I have to congratulate you because there are a lot of questions coming there, and that's a good place to write them because we will then be able to address them one by one for you all during the Ask Me Anything session. So yeah, good job. I will paste the link again, so feel free to just write more questions. And don't forget that you can also vote on questions that you see already there. So they can bubble up and they will be getting higher priority in getting answered. And the top voted will win a prize. So thank you.
Good. Yep. Don't forget to upvote the good questions. Now, very briefly, over a few questions I see on the YouTube chat. There is a question from Handapani. How Cassandra is different from HBase or Google BigQuery? Take a look. Speaking of Google BigQuery is more of analytical tool, and it's not as performant as Cassandra. Speaking of Google tools, you better think about Bigtable, because Google Bigtable is based on the same principles as Apache Cassandra. They basically use the same white paper as the foundation to be developed. Now, Google Bigtable is a great tool. I'm a certified Google Cloud architect, and I know a lot about this thing. It uses the same principles as Apache Cassandra, and from my point of view, it has one but quite strong disadvantage. It is non-open source. It's a proprietary, available only on demand. If you completely 100% stick to Google infrastructure, then Google Bigtable can be a good choice. But if you want to have no vendor lock, then Apache Cassandra is better for you, because you can migrate easily from GCP to AWS or your own data center with no question. And with Bigtable, it's not possible. Basically, Bigtable belongs to and controlled to only by Google. Then, as for consistency, availability, and partitioning, will Cassandra satisfy all three? That's a very good question with quite a surprising answer. I proceed with that on my next slides to answer that. And Frederico Palma asks, what is the difference between Cassandra and Mongo?
Yeah.
That is a good question.
I just wrote an answer.
Thank you.
I just wrote an answer, and there is also exactly that question in the Ask Me Anything already. So if you just go there and vote them, I'm sure we will address this answer later.
Yes.
But yeah, go ahead, Alex. Sorry.
I just wanted to say, please ask this question at as the link what Stefano pasted already, datastax.io/CD Singapore QA, questions and answers. So this way we will have better answers to your questions with a group of people, group of Cassandra experts. And let's move on, because we have more things to discuss. So, consistency. Some of you already know about CAP theorem, I think. And of course, a lot of you who understand the idea of replication also know problem it brings. Replication is great. Replication is the only thing what allows you to have highest availability, but it also brings a problem. What is the problem? Let's talk CAP. So take a look. There is a thing known as CAP theorem, also Eric Brewer's theorem. It claims the following statement. In the distributed environment, you can have only 2 qualities out of 3 in case of emergency. What are those 3 qualities, and how happen we can have only 2? Take a look. In the normal scenario, when every server is working, no network lags, all the power supply is available, and rainbows and ponies and green grass and everything is great, your database at the same time consistent and available, and everything is great. But if something goes wrong, then you have to decide where you want to stay. And basically, there are 2 places for us to be: availability and partition tolerant, or consistency and partition tolerant. What does that mean? Let's first talk about those qualities. What is availability? Availability means you get the answer. You just ask database, it answers, even in case of emergency. In case of failure, and then some servers are on fire, there is a shark attack in your data center, still you get the answer. What consistency means? It's a little bit more advanced concept. When you have multiple servers storing the same data, and you ask them for the answer, they all give you the same answer. There is no situation when you request some data and you get it, some stalled data, some outdated information which was updated, but the node you asked it didn't know about this update, missed it somehow, then you can have it outdated. Like you don't want your financial data to be inconsistent. And finally, partition tolerance. Partition tolerance is one of the most complex, is the most complex basically feature here on the CAP theorem. So I have to explain that. It's very often misunderstood. Partition tolerance means ability of the system to survive network partitioning or network split. It means what you have, let's say, five servers within your data center, and there is a network issue between them. So there are three servers what can communicate with each other, and there are two servers who can communicate with each other, two groups, A and B. A group can communicate inside, B group can communicate inside, but they cannot reach each other from A to B, from B to A. Network split. Now kind of you have two networks what cannot collaborate. And it's called network partitioning. And it's potentially a very dangerous situation. It may be even more dangerous than just complete server loss or complete data center loss. Why? The point is, if some of your clients will work only with a group A, and some of your clients will work only with the group B, as a result, they get into the inconsistent state because there were different updates to different parts, and then the network split disappears. Everything is fixed. You just cannot merge them back because they have different information, different state, and no one can understand which one is right. Basically, there is no right state. It's called split brain problem, and split brain problem is one of the worst, maybe the worst situation, potential situation with your database. So partition tolerance is the ability of the database system to survive network partitioning without getting into split braining. And you, that's for sure, you want to have your data to be or here consistent and partition tolerance, or here available and partition tolerant. I will explain it now on the more examples. But as very well said by Stefano, there is you can have it fast, cheap, good, chose two. That's exactly about CAP theorem. Is there a way to get into the middle? Let's take a look. So many people say Cassandra is CP. Many people say what Cassandra is AP, available and partition tolerant. But I don't like this definition. I find it a mistake. And now many Cassandra experts may look angry to me like, what do you mean Cassandra is not AP? Cassandra is AP. Yes and no, because Cassandra is configurably consistent. In any moment of the time, for any particular query, you can set consistency level you require to have. And there are consistency level like any 1, 2, 3, quorum, all, and there are some more consistency levels for multi-DC deployments. Local one, local quorum, each quorum. What does that mean? Now, again, there is a very often mistake. People start to think of consistency level as like the amount of servers we are delivering the data, which is of course wrong. It doesn't matter what's your consistency level per query. Data still will be delivered to all servers responsible for this piece of data. So it's not about how many servers will get update. All the servers who need to know that will get the update. But consistency level defined for how many of confirmations your query coordinator will wait before returning information to the client, what, okay, we got it. And with consistency level 1, first, client writes data to some node, which is a query coordinator in this case. Query coordinator sends this data to all 3 replica nodes, and it waits for the answer. But as we define at consistency level 1, it will wait for the fastest answer to arrive and then get back to the client and say, okay, we got your data, you can be sure it's stored in a database. So it's called consistency level 1, and this example demonstrates how it works with replication factor 3. With replication factor, for example, 5, it will work exactly the same way, but the amount of replicas will be higher, of course. And with consistency level quorum, quorum literally means majority. So more than a half. More than a half for the replication factor 3 is 2, because half of a server cannot vote. And Stefano, I'm sorry,
Yes.
keyboard.
Sorry.
No worries, we are good. So there is consistency level quorum. With consistency level quorum, query coordinator will wait for the majority of the servers to confirm what they got the data. And with consistency level all, how do you think what will happen? With replication factor 3 and consistency level all, we will wait for all replica nodes responsible for this piece of data for the partition I'm working with to confirm what they got the data. And now you can think, consistency level all looks good. I will just go and use consistency level all the time because I want my data to be consistent, right? Right, but wrong. TAP theorem states what you cannot be C, A, and P simultaneously. That means what then you go with consistency level all, you basically just transfer your data from available and partition tolerant into consistent and partition tolerant. And as a result, yes, you have full consistency, but you buy the price of the availability. What will happen in case of any of the servers cannot answer? What will happen? Answer will be simple. If a server cannot confirm what data was stored, after some time, this query coordinator will report to the client, okay, sorry, desired consistency level wasn't reached. We cannot store your data. Oops, there is a problem. And that's the point. CEP theorem is here, and you just cannot get it. Or maybe you can. There can be better ways. Let's take a look. There is a thing known as immediate consistency. And immediate consistency may be the practical optimum for us to have the full consistency, but still be able to survive a data loss. The trick is there are multiple ways to reach immediate consistency. And first way, take a look. If you write with consistency level all, then we can read with consistency level 1 and always know what data is up to date. It never will be outdated. Good. But not really great because write happens still on the consistency level all. If one of the database is one of the servers is not available, we want to execute this operation, and that's not nice. Another way to reach immediate consistency is to write with consistency level 1 and then read with consistency level all. This way, we, as long as even one single node has this data stored, we are good. And we will get information the most up to date because we ask all of them and then get the latest value. But again, that's not the best way. Immediate consistency done the right way is that when you write with consistency level quorum, and if you read with consistency level quorum, so you always reach more than a half of the servers, you always have immediate consistency. How it works? How do we get to the middle of this CEP theorem? Take a look. Mathematics. Mathematics is great and it's very helpful in this case. With replication factor 3, quorum will be 2. It means what then this client writes something, we wait for at least 2 confirmations, right? And therefore, there will be 3 replica servers, replication factor 3, and 2 of them, we do know they received the update. And one of them maybe received the update. We don't know if it received it or not. Mostly probably yes, but shit happens. Then we are trying to read this data. Client reads this data, and as it executed also with consistency level quorum, it means what we will receive data from 2 different nodes for sure. And there are 2 possible scenarios. First 2 nodes answered was this one and this one. They were up to date, and therefore query coordinator sees what data matches and returns to client this data, and everything is fine and everyone is happy. But what happens if this node indeed was not updated and it dispatches outdated information? So it was faster, it missed some update, but this time it was faster. And query coordinator sees what we have 2 non-matching pieces of data. There are actually hashes used to save some network time, but that's not about that right now. So query coordinator sees we have 2 different values, but then Cassandra stores data. It always have the timestamp. Then this data was dispatched. And we see what this value is newer than the old one. And that's the last write wins. So always the last piece of data considered as the most up-to-date, of course, because it was stored at the last one. And then Cassandra returns to client this up-to-date value, not the outdated one, but the right one, and initiates a second layer of defense from a cross-node inconsistency known as a repair on this broken read. So the node what didn't have your data updated will be updated their internal Cassandra mechanisms. And guess what? That's also absolutely automated, so you don't have to take care of that. It will be executed by Cassandra automatically. So we can have immediate consistency, but just writing with consistency level quorum and reading with consistency level quorum. This way, we still can afford losing a single server because of whatever power outage or whatever happens with the server, and still be able to deliver answers to these writes or read requests absolutely without losing any data, without losing any queries. But meanwhile, we will have this immediate consistency. Why mathematics? Very easy. If consistency level write plus consistency level read more than replication factor, you do have immediate consistency. Simple as that. As we discussed, consistency level quorum for a ref3, replication factor 3, will be equal to 2 plus 2 more than 3. So we have immediate consistency this way. Consistency trade-offs. So higher the consistency you require, lesser chance you may get stale data. That's quite obvious. You pay for this with possible latency. Now, that is very important to understand. What is the possible latency? Take a look. When we dispatch these queries to 3 replica servers, we wait for 3 answers. And we don't know how quickly those responses will be returned. Maybe for each of them, it will take just 1 millisecond. 1 millisecond, 1 millisecond, 1 millisecond. Answers arrive simultaneously. In this case, doesn't matter which consistency level you would use, response time the same for all of them. So if you would go with one or if you would go with all, response time will be the same. But in the normal life, usually it happens in a little bit different way. And it can be like 1 millisecond, 2 milliseconds, and 5 milliseconds. And now you think, with consistency level 1, I would get my answer within 1 millisecond. With consistency level quorum, I will get my answer with 2 milliseconds. And with consistency level all, I will get my answers within 5 milliseconds. Because third node was busy or something was not perfect on network, doesn't matter. So that's a possible latency, and with good working network, you usually can go with higher consistency with still no delays. It depends on your situational needs, and query can be configured. It can be configured per query, as your application usually works with different pieces of data. For example, for second class data, I don't know, profile picture, no one will worry if your friend updated his profile picture, but you will see it updated in a couple of seconds, not immediately. Um, it's fine, but with some financial data, health monitoring, you need to have the data updated in like a more consistent state. Then you can go with higher consistency levels. But usually, quorum fits most of the use cases. Some systems with write-heavy workloads, and Cassandra is very often a good choice for write-intensive systems, may benefit from consistency level 1 for writes if data isn't required immediately. Data will be spread over cluster to all the data centers, to all the proper nodes over time. If you just store information from IoT sensor network, then you may benefit from consistency level 1 because receiving this confirmation from one single server in most of the cases will be enough. Good. So, Stefano?
Yep.
Are there any good questions on chat?
No, it's pretty quiet. I think most of the questions are piling up in the Ask Me Anything site page, so that's even better. So we will pick them. I see some of them going there, but on the chat it's pretty quiet. I think you can go ahead.
Great.
Yeah.
So, database is all about data. And of course, we work with data a lot. So, how it starts? It's all start from a cell, a normal cell-like intersection of a row and a column, which stores some value for you. Exactly like in relational databases. When we have a row, and this concept must look familiar as well. It's a structured data item in a table. Usually it keeps some values for you. Department, user ID, username, and so on and so forth. Now we get into more interesting place. Oops, what's that? Okay, sorry, wrong slide. So, data structure partition. Take a look. When you work with data on a relational database, you use it to work with it like database, table, row. Database, table, row. In Cassandra, you have one more idea which is very important to understand, partition. Partition is a group of rows having the same partition token. For example, in this case, on this example, if we use department as a partition key, we will have in this small table of 5 rows, 2 different partitions, one for wizardry department and one for dark magic department. And finally, table holds partitions, and table is a group of columns and rows storing partitions. When we create a table in Cassandra query language, by the way, this is an example of Cassandra query language, which looks very familiar to you because it's designed to be very similar to SQL, so you can learn it easier. We create a table. By the way, speaking of structured query language, take a look. SQL is designed to be very simple and very similar to SQL. And that is great because you can learn it very easy. But there is one more problem. Many people who are not like you, who didn't attend our workshop, they see, oh, SQL is so easy. I already know it. I can go and use Cassandra. And no, they are not, because they are not like you. They didn't attend this workshop. And that very often brings to them a lot of problems, to them and to their clients. They just start to use Cassandra as MySQL without joins, and they inevitably run into big problems. So notice SQL looks like SQL, but it's not the same, and Cassandra is not like MySQL without joins. So you will see soon why and what you have to consider to avoid any kind of troubles. So When we're creating tables, we have to define key space, and key space is just a group of tables like a database or schema in Postgres. Then you have to define when you have to define the table name, of course. Then you have to define columns as normal, like name of a column, type of a column. And here we have text, 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 text. Trust me, we have more data types than just text, okay? And then very important thing we will walk through in the next slides, primary key. Primary key is something that identifies an unique row, and it has to have a partition key and clustering columns optional. So regarding the key spaces, we discussed it already. When I create key space, I have to specify key space name, and I have to specify a replication strategy and replication factor. There are more settings can be done, but those are required, so they always have to be specified. What do you need to know about replication factor by data center? You can have multiple data centers, and you must specify replication factor per data center if you want to have data there. That's a very good question on understanding how Cassandra works. How do you think, considering this statement is correct, so there are no mistakes, it will work if you execute it, how many data centers I have in my cluster? Please answer on the YouTube chat. I'm very curious of what do you think? How many data centers I have in my in my cluster? Who will be the first? Okay, Samita thinks 3. Okay.
2, 8.
How many data centers I have in my cluster?
1.
2, 8. 2 data centers. 5. 1. Oh, well, that's quite dispersion. Okay, so
many
first
different
of all,
answers.
Yeah, many different answers. A lot of answers, but none right.
Yeah, well, that was a tricky question, but that's good to warm you up for the quiz.
That's a tricky question, but on the quiz you will have even more advanced questions, so stay focused. Take a look. Don't forget, with Cassandra, I can specify data locality per key space. So there are no answer to this question. Again, there is no answer to the question. The best possible answer we can get is at least 2, because take a look, we have here United States West 1 and Europe Central 1. But I can have Europe Central 2. I just don't specify it here, so it will get no replicas. And in this case, well, a key space won't be replicated to Europe Central 2. Or maybe I have a dozen of data centers in Asia. I can. This statement is still correct. There will be just no data of this key space replicated to these data centers. So the only possible answer is at least 2, considering this statement is correct. Okay, so I hope it was a little bit of surprise for you. I love to make surprises. Then let us proceed. Then we are getting like overall view on the data structure and go from top to the down. First, we have the key space, which has tables. And tables has columns, rows, and rows are organized into the partitions, and partitions are very important. Now, defining primary key is a very important skill, and it may be not so obvious. Many relational databases are using sequential IDs, and then you store something, you just get ID of this record from your database. It's a convenient way, like I used it many times in my life, of course, I like it, but there is a little bit of problem. When you have 1 or 2 hundreds of servers, they will have to communicate with each other to dispatch you a sequential ID, which obviously introduces some delays, whereas your clients hate to have because your clients, your consumers want to get your answer from your application immediately, and if you are too slow, they will just go to your competitor. So we want our database to be fast. That's why we define primary keys not by database, but by our design. So primary key have two duties. First, it must ensure uniqueness. Second, it may optionally define sorting order if required. Let's take a look at this example. Primary key for our table users by city with city, last name, first name, email. Will that work? Yes, it can be quite a good example. But let's take a look at this bad example. City, last name, first name. Why is it bad? What's wrong with this design? Let's think. Please answer on the YouTube chat. You are doing very good job answering my questions, by the way. Thank you. So, primary key of city, last name, first name. Why is it bad? I already see how you are typing your questions. Not unique enough. Hey, Ben, great job and very quick. Yes,
Yeah,
indeed.
not unique.
Not unique, right? Because as I checked, there are like 24 of John Smiths in New York, and every next John Smith will make a very bad surprise to a previous John Smith in your system. So it is not unique. Most of you made the right answer, I see. Very well. Let's move on to the next part. Partition key. Partition key is the very first argument in primary key. And partition key is an identifier for a partition. It must present, you always have to specify the partition key. And it consists of at least one column, but may be of more if needed. If your partition require to have multiple columns, it's also possible. So partition key has one and only one duty. It partitions rows very easy. So take a look. We can have single row partitions like primary key, user ID. User ID will be partition key and primary key at the same time. And we will have as much partitions, as much users we have, and it is perfectly fine. We can have any amount of partitions. It's perfectly fine. Or for example, if we have videos on YouTube and comments for those videos, like you are writing comments right now, right? We can partition them by video ID. And that makes sense. And our primary key will be of video ID and comment ID to have the uniqueness, right? And video ID is a partition key. So this way our comments for per video will be stored together, which makes a lot of sense. Now, there is a bad example, but I have a special slide about it. It's a very nasty example, and I will explain it in higher details a bit later. And finally, clustering columns. Clustering columns have two duties. They are used to ensure uniqueness and sorting order if required. And clustering columns are optional, so it's completely fine to have them or not have them depending on your structure. So in this example, users by city, we have city as a partition name, and last name, first name, and email are clustering columns in this case. We already discussed the first example. City, last name, first name. Without email, it will be not unique. And second duty can be here when we have this video ID and comment ID, they are not sorted. And if they are unique, but not sorted. And if we introduce created at timestamp as a clustering column, you will have this video ID, created at comment ID, primary key, and primary key will be unique enough and sorted because created at clustering columns are also for sorting purposes. By the way, very important point. Stephanie will explain it in more details later. But in this example, city, last name, first name, email, address is not present in primary key, right? Address is just a data column. That means we cannot search or we cannot sort by this data column because only by the parts of a primary key we can search, we can sort, we can use where clause only on the parts of a primary key. That's a very important limitation. Well, you always have a price to pay for such a power. So, to be good in partitioning design, to be good with Cassandra, you have to be good in partitioning design. And I want you to be successful with Cassandra. So now we start very important slides, or most important slides of this presentation. They even have the slide of a year award. I created those slides and I gave them award because I find them extremely important to you. There are only 3 rules you have to follow in order to design good partitions. And that's very important because if your data design is bad, if your data model is bad, Stefano will explain it in more detail soon, then your database cannot be as scalable, as performant as it could be. Cassandra's highest performance is shared responsibility. It gives you all the tools, but you need to know how to use them. So let's start. Rules of a good partition. Rule number 1, store together what you retrieve together. In the perfect scenario, any of your queries, select, insert, update, delete, must reach one and only one partition. Because when you work with a single partition, you work with a single server. But if you work with multiple partitions, you will have to reach multiple servers, and Cassandra will have more work to do. And obviously, it's not the recommended way. So first rule, store together what you retrieve together. Take a look. Open a video on YouTube. We have to show comments of this video in a single query. For example, video ID created at comment ID. That's a good example. They are partitioned by video ID, so we can reach all the latest comments within one single query to one single partition. That perfectly makes sense. Now, if we do not use video ID as a partition key, like if we would go like that, then partition, we will have as much partitions as many comments we have. It's fine to have many partitions. It's not a problem. The problem is when you are trying to retrieve data, if you specify a partition key, Cassandra driver and Cassandra query coordinator knows what's the token and therefore which servers to ask, because it knows which servers are responsible for the token range of this token. But take a look, if you don't specify partition key, what will happen? When you order something, when you order food, when you order pizza, do you give your full address to the delivery service, or do you just give your street name and city? I don't know about you, but I prefer to give the full address, so delivery boy or girl will arrive to my door, to my apartment, to my house, and deliver my pizza hot. Pizza must be hot, right? But in the computer world, specifying no partition key is like hiding your apartment number or your house number. And what will delivery boy do in this case? Will go and ring on every door on your street. Hello, sir. Have you ordered pizza? No? Sorry, I will go to the next door. And again, sorry, sir. Sorry, madam. Have you ordered pizza? No? Okay, I will go to the next door through the wall street. That is as stupid as it sounds, of course. So specify the full address. In case of Cassandra, it means always give the partition key. If you don't give that, it's called a full cluster scan, and it's obviously anti-pattern, and that's very, very, very stupid. So always give the partition key. If your query doesn't use the partition key, Cassandra will try to protect itself and not execute the query and give you an exception. There are mechanisms to make it still execute the query, but we won't discuss it here today. Now, next rule of a good partition. Avoid big partitions. What does that mean? Do you remember why do we do partitioning at all? We do partitioning because we want our data to be available always. Doesn't matter what size is it, and even if it doesn't fit a single server, we still can split it into multiple parts and put it to multiple servers. But then your partitions are too big. Then Cassandra cannot work as fast as it could, and it will work slower. You will have some maintenance problems and so on and so forth. So it's very important to keep the partitions of a reasonable size by giving them the right design of the partition key, of course. What are the hard limits? There is only one hard limit. Partition cannot be more than 2 billion cells per partition. Cell, I remind you, is the intersect of a row and a column. So if you want to calculate the amount of cells per partition, you can just take amount of columns and multiply it by amount of rows within this partition, of course. That's a hard limit. And there are two more recommendations. Usually we recommend to have up to 100,000 rows in a partition. You can have more, but we still tend to have like not too big partitions. And we recommend it to be up to 100 megabytes in a partition. Now, if you exceed those a little bit, there is no big deal. But we have seen partition of 1.2 terabytes, and that is disgusting. Just don't do that, because too big partitions, first you pick a great database and then you prevent it from working in the right way. Don't be like that. Understand your partition sizes. It is very important if you want to have highest best of the market performance with Cassandra. You can have it, but it's a shared responsibility. Why this example is specified as bad here, partitioning country by city. Take a look. I live in Europe. In Europe, we have a lot of small countries, but we can have a lot of them. Partitioning by countries maybe ain't so bad. But if you go, for example, somewhere in China or India, a lot of people living there, you may get into the situation what your partition will occasionally become too big, and it will be hard for your cluster to deal with that. So your task developing partition keys is to make partitions of more or less even size. So they should be more or less the same size, preferably. Some little discrepancies are not so bad. But again, if your partition is like 1 terabyte, that's obviously a very bad idea. Now let's work together on one task. Let's work together on one real life story happened to one of our clients. Imagine we all working together on a huge telecommunication company, like very huge. This company has a lot of infrastructure, a lot of hardware all over the world with dozens of data centers, like really a lot. And we have a very important thing. We have a monitoring over all of our data centers because you cannot control what you can't measure. So there is billions of sensors reporting their state every few seconds. Every sensor reports its ID, so usually universally unique identifier, timestamp, and value. That means, like, for example, at 15:02, we register a temperature of 40 degrees by the sensor ID 123321. Simple reports, value can be a temperature, humidity, whatever, basically there are different sensors. And we designed a table at first like that. Primary key to be partition key, sensor ID, and reported it as a clustering column. Sensor ID makes sense. Store together what you retrieve together. I know what I'm going to show the diagrams of how temperature changes in the server room over time. And it will be the same sensor. So sensor ID makes perfect sense as the partition key. And there are also reported at timestamp. So when this value was registered for uniqueness, for sorting purposes. So that looks like quite a reasonable design. In the beginning, it works. But after some time, we have got really huge problems. Please answer on the YouTube chat what happened and why this design is marked as bad design.
That's an interesting question.
One of my favorites.
Yeah, what happens over time to these partitions?
Hey, don't give them hints. I want them to
come
think.
on. We want to lead
No, you
anybody
see.
to.
Yeah, no, you are right, of course, but sometimes we need people to think alone about what's going on.
We want to, guide the proper thinking. I mean, it's all new stuff for many of them.
Yes.
Yeah, and there we go. See?
That is great. So there are multiple answers already, and I want to walk through them.
Yeah, pretty on mark, I would say.
Okay, good. So first of all, thank you for answering. Well done. I will walk through them. Navi Krishna, every second temperature of sensor can change. That's perfectly fine. So yes, temperature changes. They are never overwritten because time will be different, and I store all the data. That's not the problem. And second answer already was right by Sudhasata Dhar. I hope I pronounced your name right. Partition will grow huge as time passes, and that is the right answer. In the beginning, it will be fine. First few months, it will be perfectly fine. But as we store this data every 10 seconds, over time partitions will become too big. There are Ben Griffin says you could have multiple sensors at the same time. Yes, but it's not the problem because we will have different sensor IDs, and therefore we will be working with different partitions, mostly probably on different servers. And Cassandra is very good in writing data, so it's not a problem. Because it is IoT, it will generate lots of data after time passes. Yes, Chives, I'm sorry, don't know how to read this nick. Then data will be huge, over 2 billion per partition, right? Partition gets too large. Yeah, so most of you made it right. Basically, partitions will grow over time, and at some point, they will become too large.
Yeah, now, so if I may say something on this,
of
Alex,
course.
Yeah, the point is that you start collecting more and more data as time passes, and that would not be a problem for Cassandra in itself. And there is an observation here to be made, because you might see some. It's a sneaky problem in this case, because there would be a slow decrease in performance, slower and slower performance. And you might be tempted to think, oh, yeah, it's a fact of life. My data is becoming bigger and bigger, and I have to deal with decreasing performance with that. That's luckily not the case with Cassandra, because as long as you partition the data in the proper way, and you keep the partition size constant over time, basically, you can still achieve a constant access time, even for large and growing data. As long as you add nodes. So if you have to deal with 10 times as many pieces of data, you might just add nodes, and you will still have the same access time to get the data, as long as your partitioning is good, which is the point of this slide. So there's a subtlety here. Sorry. That was just to...
No need to sorry. Your remark is very important. And now take a look. I see there are some comments. What the data will be too huge. Exactly as Stefano said, if Cassandra scales linearly, and if you have like really a lot of data, just add more servers, and partitions will be reshuffled over those new servers. So you will have it's completely fine to have a lot of partitions. As long as they are not too huge, you add more server and partitions are migrated to a new server and you're good. But if the partitions per se are too big, then that is a problem. And there is one more point, as Dhanadapani asks, can partition be dropped and recreated at any time based on the data growth? So the answer is partition can be dropped, and you can wipe out the whole partition. It's not a problem, but you obviously lost the data. And what I want to say here, take a look. You cannot change primary key after it was created. There are alter table statements like in the relational databases, but you can alter only data columns. You cannot alter partition key or clustering columns. Why? Take a look. Partition key defines data distribution over cluster, and clustering columns define how data is stored on each particular server. An attempt to change any part of the partition key will lead or to moving all the data over the cluster to the new partitions, or restoring data on the same partitions in the new order. When we speak Cassandra, we usually mean a lot of data. That will basically wipe out any performance of your cluster for at least for some weeks in some scenarios. And that's just not allowed. That means if your partition design was bad, now you have to create new tables and migrate data to those new tables, and that's not so easy process. That's why I'm talking those slides, a slide of a year award. You have to learn it in order to decrease the need of later data migrations for your cluster. So it's definitely may help you a lot of time later. Data design is important, data model is important, and especially for partitions. Now, so we got into this bad situation, and that's not just a theory, it indeed happened in real life with one company. I cannot give you the name because they are our clients, but it happened. So there are two possible answers how to solve this situation. First answer is TTL, time to leave. And this TTL will expire the row when it's expired, of course. And if you want to store data only for some months, for some years, for some weeks, it may be a good choice to just let data expire after some time. Makes sense. The problem is it wasn't the situation. This company wanted to store this data for years and years and years. So TTL was not to help. And we introduced a second solution, which was a better fit. It's called bucketing. Do you remember I told you what partition key may include multiple columns? So we introduced a new column, a synthetical column, month year. What is a month year? Month year can be an integer or a string that doesn't matter, which consists of month and year. For example, now it's October. So our month year will be 10 to 0 to 1 because it's October of year 2021. And now there is an interesting point. Take a look. As partition key includes sensor ID and month year, as soon as month year is over, like October will be over one day, I hope, and November starts, what will happen then? Month year will become 11 to 1 to 0 to 1. As a result, the token value will be new because partitioner will generate a new token out of new value. And we will basically create a new partition completely automatically. And now we have bucketing or partitioning, not based on the sensor ID only, but also based on the month of a year. And we have our table design sensor ID, month, year, reported at. That gives us much smaller partitions, and that is great. So our partition never grow larger than over 1 month, and that's a perfect solution. Now, you can ask why we use month here. Why don't we use week? Why don't we use not a week, but day? hour, something like that. Will it be better to just put timestamp into partition key? So remove month year and just move reported at into the partition key. It could work on write time. But what did I tell you? Respect your delivery guy, give your full address. If you make it like sensor ID reported at as a partition, on the write time, it will work. But when you are going to retrieve this data, take a look. Let's say I'm going to show a diagram of the temperature values for the sensor in my server room. And I need to get data for 3 last months. In this case, my select query will be select timestamp value from sensors records table, where sensor ID equals 123321, and month year is 10/2021, 09/2021, 08/2021. So therefore October, September, August. This query is not perfect because it will reach 3 different partitions, not a single one, but it's acceptable. So it may work, it's ain't so bad. And I will get all my data. But if I have smaller bucketing, I will have to specify each week or each day or each hour or basically every part of the partition key always. And with small bucketing, it will be very not convenient on the write time. The problem of a partition key, it doesn't support inequalities. Working with partition key, you always have to explicitly specify the partition key, and you cannot make it like more than, less than, you have to give a full partition key. That's why we prefer to bucket base it on the month and year. But of course, it depends on the amount of data what arrives. So sometimes you will have to switch to weeks if you have much more.
Yeah.
Any questions?
There was a question in the chat that Jeremy has answered about how to alter the schema of an existing table, but that's been answered. Just a way to frame what Alex just said. I second everything he said, and a way to frame it is that since you have to deal with big data, you have to find some compromise, and how you find it depends on the size of the data and the kind of access pattern you need in your application, as Alex said. So if you are happy with accessing data only for small spans of time at once, you might want to have smaller bucketing, so smaller partitions. And this is really the result of how the application needs to retrieve data and how big the partition you estimate will be. And that's maybe one of the underlying narratives also in the data modeling story I will tell you later of.
Yes.
Yeah.
Good.
Yeah. Sorry, Rajiv just wrote a question on that. And yeah, well, the balance for the optimum partitions is mostly depending on how you plan your application to work. You don't get many recommendations from any automated part in Cassandra. It's more a matter of being able to anticipate what your application will do, which is essential for a good data model, and being able to estimate the size your partition will be.
Yep. So we can give some recommendations. For example, there is DataStax field team recommendations on how do you do some checks. But in general, there is not much support can be done in advance by us, but you have to think and try to design your partitions, even thinking in advance.
Yeah, I would say it's not our fault because it depends on what your application will store and use. So
yes,
yeah, there are formulas to estimate the partition size depending on which columns, how many rows, and which type are the columns, like a typical memory size estimate.
Right.
But other than that, it's up to you.
So, right. You know what? I always say it like this. With Cassandra, you as a developer have more work to do than with a relational database. I mean that it's real. As a developer, as an application developer, I have more work to do. But you know what?
Pays
Cassandra
off.
enabled, yes, it pays off. Cassandra enabled developers are more expensive. So as a result, I get more money for that, and I'm completely fine because company pays for this to enjoy all the power and highest availability of Cassandra. So now, next slide, avoid hot partitions. We already discussed the big partitions. With them, it's quite simple. There are just some partitions what keep a small size, a small amount of data, and some partitions what can be too huge. Easy to understand. But what is a hot partition? Hot partition is a partition what accessed more often than others. And in general, it's completely fine to have some partitions what are accessed more often than others. If you have 100 of partitions or 1,000 of partitions and 10 servers, they are distributed evenly across those servers. And if some partition is being accessed too much, and your server is very busy dispatching all the queries, you can just add more servers, right? You have 10 servers, add 10 more, and partitions will be redistributed over cluster, and you will have less partitions per server. As a result, the load on servers will be decreased, and because you will have more workers doing the same amount of work, and everyone is happy. But let's take a look closer on what is a hot partition. This example, video ID created at comment ID. You remember comments per video, for example, on YouTube. We partition our comments by video. First, you can say, hey, there are some videos on YouTube. Those have a lot of comments. Will be those partitions big, maybe? Answer is, well, yes and no. There are indeed some videos on YouTube would have a lot of comments, but it's not so big deal for us because the data size won't be too big. There are comments like what normally comment have: ID, author name because of the normalization. Stephanie will explain you later. Text comment and timestamp. So 5, 6, 7, 8 fields, type text mostly, and they all are small. So those comments, despite there can be a lot of them, they still small per se, and that's not a big deal. That must be fine in most of the cases. But let's take a look at the example. Country user ID. You've seen this example before. We have customers mostly in European countries. There are a lot of countries, but their size from the population point of view usually is not so big. We work in Europe, everything is fine. Our data model, user per country, works perfectly well. But when we go to Asia, for example, let's say we go to China, and we get extremely good outcome there. Like literally everyone in China wants to buy something from us. That's a great job. I mean, our business is thriving. It's great. We are very popular. Everyone is buying something from us. And that sounds great. But now take a look. We have some countries and therefore partitions like Malta, San Marino, Vatican, if Vatican is interested in our Liechtenstein, and so on and so forth. So there are some partitions of a size of 1, 2, 3, 5 persons, let's say. And now we have really a lot of customers in China. So we have one huge partition being accessed all the time. And it's a very hot partition, so server keeping this partition are very busy. And now we may say like, okay, but we are very successful business. If we have had 10 servers, just let's add 10 more servers. Let's add 100 more servers. We are rich. Sounds good, doesn't work. Take a look. If you have this hot partition, you can add as much servers as you want, but you will never have this partition distributed anyhow, because even if you will have as much servers as partitions you have, it still will be one very hot partition of a server. And Cassandra server is very fast, but it also has some limits. So you can add as much servers as you want. It won't help if your partition is overloaded, even so one single partition per server will be too much. So we have to think not only on the size of the partitions, but on the workload distributions on the partitions. With video, as I said, it's completely fine, because yes, video can be heavily accessed, but we have a lot of heavily accessed videos spread over cluster, and that's perfectly fine. And again, usually we access like some very last comments, but not the whole history, so it will be fine for us.
In the worst, maybe that video becomes super popular, but if you anticipate that, you can employ bucketing and create that on the second choice here, and so you can stack solutions to solve your data model. If I may add a very quick thing.
Yeah, sure.
Alex just mentioned the problem of hot partitions. So you might have China, which is a very big country. Everybody in China uses our e-commerce, and our China partition has trouble because if you look at the physical layer, how the data is stored, there will be a directory with some files that are constantly being replaced and rewritten, basically. There is another layer of problem connected to this, which is if you have big partitions, you might have the unluck that two or more heavy partitions end on the same node. So let's say for some reason, a node will host China and India, which is also a very big country, and everybody in India uses our application. So besides having trouble in your file system, basically, you will also might have a network bottleneck. Again, so to distribute evenly traffic means traffic and storage and I/O. So everything has to be properly distributed for best performance. So that's why avoiding hot partitions is very, very crucial.
Right. Yeah. Thank you. Good. So, and we are done with the theoretical part. And you did a great job watching it and asking questions. Now, if you want to get the participation certificate or achievement unlocked badge, you can follow me doing this lab, or you can first watch me doing this lab and then do it after this session, which is also perfectly fine. Stefano, I believe you have a link for us.
I sure do. Thought I can do that if you want. If you have everything ready, then that's okay. Otherwise, I'm ready to. You mean the link to the GitHub, right?
Yeah. If you want to do the practical part, you can do it. Absolutely, yeah.
Yeah. Okay, as you want. I just have to share my screen. So let me first drop. Okay. So the point is that we have 20 minutes, and we have been, or Alex has been talking all the time. You have been listening, and thank you for being so attentive and asking questions.
Yeah.
Now it's time to get your hands dirty. So we will have a very small and quick first exposure. You will have a first exposure to Cassandra. Now, let me first drop a link to a GitHub repository with a README that we will follow later to do a bit of practice. And I will also drop you another important link. And I think in the next slide, Alex, you should also those two links. So now this is the link. So this AstraDev link that I just posted in the chat.
Now it's arrived.
So if you jump to the next slide, I think I added those links as well. But anyway, they are in the chat.
Oh yeah, you are right. Sorry. One word on Astra. Today we speak about open source Apache Cassandra, and we want you to go and type your first SQL queries. But we don't want you to install and run a Cassandra cluster because it may require some power of your laptop, and it may be not easy to do within like 20 minutes we have left. So good news, we have managed Cassandra for you to use for free, and you don't have to install anything because it will be available to you via your browser. It's called a DataStax AstroDB, which is basically Cassandra-based database as a service with all the power of Apache Cassandra within a couple of clicks in a browser, which is really great because as someone who was deploying and running Cassandra clusters, I know that's quite a lot of work to set up your own cluster. So two links you have on YouTube chat, DataStax Devs Workshop Intro to Cassandra, or you can just scan this QR code and create your AstroDB at astra.dev-Cassandra Day Singapore. Astra is free for your usage for educational purposes. You don't pay. We don't ask for your credit card. As long as you have real production workload, we will ask for it, of course, but for this educational purposes, it's completely free.
Yeah, let's say if you have a workload that brings you out of the very generous free tier, congratulations, because that means you're already running a pretty successful application. So.
Okay. So,
Okay.
Stefan, should I switch to your screen?
If you want, yes, because I'm sharing, and if you just tell me that I'm sharing, because you are live. I can't see the live. Okay, great.
Yeah.
Okay, so these are the slides, the links you find in the chat. So let me show you the GitHub repository is this one, and just quickly showing how it is structured. There is a lot of instructions. Why is there so much text? Because it's live that we guide you through. That's because this repository and its instructions are also good for yourself at your own leisure later to go there and just do the exercise if you want. So this is a self-service thing first, and then today we will do it together. Okay, so the other link would bring you to something like this. And this is what Alex said. So this is AstraDB, which is offered by DataStax, and it has this free tier we were discussing. It is basically a managed solution in the cloud that gives you a free to use database as a service, and it is built on Apache Cassandra. So you will interact with it, and you will basically have the chance to play with a Cassandra instance without having to install anything. So the first thing I would suggest you is to register, which is free. Just give name, email, or you can log in with Google, GitHub, whatever, and you will be able to create an account. So this is all detailed here in the README. So please go ahead if you want and register. You will be asked to create your first database here in your account. And let me just scroll through the README. 1 second. Before that, I'll just tell you that you will see a section in this repository called homework here that will tell you what to do to complete the homework, which is more or less just a bit more than what we will see now together. And if you want, there is a way to submit the homework as a GitHub issue. You attach a few screenshots that you completed everything, and we will then grade the homework and give you the badge that you will then be able to, show around and to boast a bit. This is not the same as a full-fledged certification because that will require studying a bit more than what we see today, but still it's a good introduction and to get engaged with Cassandra. Okay, so let's go. So first you have to register, as I mentioned, and you will probably, okay, this is my account. I already registered. Okay, so after registering and logging in, you will be given this screen, which is the one to create a database, because in your account you can have many databases. Let me first create my database, and we suggest you see, okay, maybe Alex, you can paste these names in the chat. We suggest you to stick to the standard database name killer video cluster that we suggest here in the README, in the instructions. And the key space name, you should choose killer video. That's just, you could choose any name you want. But in order to be able to just copy and paste and not modify the commands you see in the README, the sample commands, we suggest you to stick with to those names. So, okay, the database is just a separate database. And in the database, we create a key space. Alex mentioned that. A key space is a group of tables. It's a logical space where you keep your related tables together. Okay? So after giving database name and the key space name, there is an important thing. So maybe I close this chatbot. There is an important thing. Astra is a service that is sitting on multiple cloud providers and multiple regions. So, well, okay, I'm creating this database and I can still choose what will be the backing infrastructure provider. So let me choose AWS.
No. Why? Let's ask our attendees which provider do they prefer. Maybe they prefer Google Cloud. Guys, what do you think? Which provider Stefano should use?
Okay. Alex, you have to tell me because I don't have visibility on the chat. So just tell me what are the answers.
I will tell you. Jeremy Hanna suggests us to use AWS because it has a region in Singapore, which pretty much makes sense, but I still want to know the people's opinion.
Yeah.
Okay, Navi Krishna, Azure, AWS.
Okay. So I would choose AWS out
Azure.
of habit because I know AWS better. I'm certified on that one, but
AWS,
yes.
okay, AWS dominates. That's
okay,
pure
so
AWS dominates.
I appreciate that there is a Singapore region, and that's very good. And probably most of you would stick with that for latency, you know, but I'm based in Italy. And I'll go for the Frankfurt region. That's also because I spent some years living in Frankfurt, and that's a very great city. So I want my database to enjoy the city. So Europe, Middle East, and Africa, and Europe, Frankfurt, and that's it. So database name, key space name, provider and region. So I'm ready to start.
Yeah, and you can start, please. But then you create your database. You can make a decision of your choice and pick the provider you find the best. That's what matters. I see most of the people prefer Amazon Web Services, but there are voices for Google Cloud and for Azure. So when you create your database, go ahead and pick the cloud provider of your choice. That's perfectly fine, and select the region you like the most.
So after you click Create Database, you end up with this main dashboard, and you will see your killer video cluster database being created, which means that for a few minutes, 2 or 3 minutes, it will be in pending state. So what is happening now? Behind the scenes, Astra is spinning up a lot of stuff. It's setting up your database, configuring it all in the cloud through the magic of Kubernetes. And then you will soon have your serverless database ready to use. So in a few minutes, this database will be active like the other. So I have already 3 other databases, but that's because we play with Astra a lot, obviously. You will probably have just this one. Just wait a bit for it to. So please, let's start with this. Please, as you create your database, I'd like you to give me a thumbs up in the chat, even if it's still in pending state. So we see that you reached this point, and then we spend a few minutes discussing a few other things while everyone gets their database active, like mine will probably become in a few minutes. So please, a thumbs up when you go to this screen with a pending database. It's okay. In the meantime, now just this is almost hot off the presses. Because in no more than a few days ago, Astra launched the multi-region feature, which is still accessible only to, say, non-trial accounts. But still, if you're considering using Astra for your applications, because say you have a big enterprise and you want to use Astra, but you are concerned about data replication, multi-region, data regulation, compliance, GDPR, whatever, The good news is that now you can also have multi-region in this database. And I remind you that Astra lifts the burden of administering your database completely from you. Because see, I just went to a website, I registered, and there, my database is now active. Yeah. So
Yeah,
maybe
that's a huge improvement. I
yeah,
mean,
yeah.
yeah, that's a huge improvement.
So
Okay, we have a lot of thumbs up already.
okay, so maybe we wait another 2 minutes just for everyone to get their database active, because the thumbs up was just to having created it. So while we wait, let us start browsing the README. So let's say we created the database name and the key space. So the database is created, and in a little while it will be active. By the way, you see a lot of screenshots and helps throughout the README, so it should be good. Also, if you want to do it by yourself later, you see there is an animation and everything. Okay, now, sorry. Let me assume you will be now having your database in the active state. And I'm sorry because I have to scroll horizontally, but that's to have bigger font size for you to better see. Probably on your screen, it will be easier to navigate. Anyway, I have my killer video cluster here, and I can click on it. Okay, so this is the view of what's happening in my database. I still have 0 requests so far. I can check the health of the database. I can look at a few things, key spaces. So you will maybe want to explore a bit. What are we going to do now? Of the very many ways to connect to your database in the cloud, we will use the SQL console here, because you see. Okay, so if your database is active and you went to this part, you can click on SQL console tab here, and you will see this terminal appear in your browser. Because if you have a Cassandra database, of the many ways to connect to it, there is a console. This is, say, you install your Cassandra in your local machine, you can reach it through a console, and in this console, you can type commands and get answers. That's obviously not the only way, but it's good, to play a bit manually with it and to familiarize. The nice thing of Astra is that it offers the same access. You see, I'm in the browser, but I have a text-based command line console, and this is where I will type my SQL commands. So now I will jump back and forth between the README here and the console here. Alex, please stop me if there are questions or requests in the chat, because I don't see them. But I will just.
There are no questions, but a lot of thumbs ups.
That's very good to hear, and I will go ahead then. Okay, so let's create a table in this database, right? So we went to the SQL console here, which starts with us logged in already, and let's see if there are key spaces. This you do with this command, desc, which stands for describe. Let's say describe key spaces. Every SQL command has to be completed with a semicolon, as I'm doing here. So describe key spaces, enter. You see there are some key spaces. Well, many of them are system ones that I don't have to be concerned about, but our good old killer video is here, and it is the key space I will work on. Now, a good thing is that SQL supports tab completion. So if I just write use, so use is the command that sets my console to work on a specific key space within that. So if I write use ki and I press tab, I get completion. So use killer video. And now, as you see here in the prompt, this console session is set to work within the killer video key space, which is what we want to do. So we described the key space, we used killer video. Okay, now let's start getting serious. We want to create a table. You just saw the command to create a table, if I'm not mistaken, in Alex's presentation, I think. You saw it, and this is what we are going to issue. So we want to run this command, which creates a table called users by city. Let me just take this command, and copy it and pasting it here. So in most browsers and operating system, you might have to right click and hit paste explicitly. Anyway, this is my command. You see, this is something you saw with Alex already. Create table. Okay, if not exist, but create table name. Then there is a bunch of columns. So name of the column, type, name, type, name, type. At the end, there is this important statement, primary key, that specifies how the partitioning is structured for this table. You see, we have a primary key composed of four columns, and in particular, the partitioning is by city. So data in this table, as you can imagine, will be grouped by city in the same partition. Now, you see, I hit enter and I'm back to the console, and I think my table has been created. How to check for it? Yes, you can describe tables. So let's see. Let me type desk tables, semicolon, and there we go. You see, in my key space killer video, there is the table users by city. Nice. Yeah, you could also, actually, you can also do describe table users by city if you want, and you get a very detailed explanation of how is the table structure, which is basically the same command we just ran with a few more default settings for the table. Now we want to create another table. So I'll just go quickly on that because we are creating another pair of tables. Look at the names. This is called comments by user, and this is called comments by video. And that suggests these tables are two different ones, but they will contain, in a sense, the same data. But if you look at the primary key, the data will be organized and partitioned in slightly different ways.
It's called a denormalization, and Stefano will explain it in details in the next workshop.
Exactly. I can imagine relational people in the audience raising their eyebrow.
Ooh.
How come I have a table, two tables with the same data? Come on. Yeah, that's something that you will later see. It's very common in Cassandra. It's a officially approved design pattern. Now, let me just paste these commands, and we should have created more tables now. So let me run again the describe tables command. See, I have three different tables. And as you can imagine, at the moment, the tables are all empty. Yeah. Okay, so let's create some data in them. So again, we are about to insert data, and this is how you do that. So insert into table, then you specify the columns you want to insert, and then a matching list of values for the values. So user ID will be this 1111. Comment ID will be a macro, basically, that is expanded live by SQL with a timestamp, or better, with a timestamp UUID, actually. Video ID will be this value, and comment will be this string. So if you take this command, let me copy and paste it here in the console. Bam, I think we just inserted our first row in the table. So very similar insertions always. So they're all on the table comments by user, comments by user, comments by user, comments by user. Let me paste this other part of the command. We are inserting a bunch of rows in the comment by user table. Okay, so we did the create, so the insertion part of the CRUD operations. Yeah, so okay, there is a remark. We are explicitly giving the UUID. There are use cases where this is realistic. Other times you want to use a random, so a function that expands live with a newly created ID. That's depending on the flow of your application, basically. Okay, so other insertions, this time on the comments by video table. So we are inserting again a few values, a few rows into this new, this other table, the one with the duplicated data mostly. Let me just go there and paste these commands. So what we've been doing so far is we have been inserting rows into different tables. Very nice. Let's read them. So let's see what happens and how do we read data. So many of the insertions have been on the comments by user table. So these tables are examples from an application that is basically a sort of YouTube written with Cassandra. So there are tables to host comments on the videos and video properties and so on. So this is the table that contains comments by users written under a video, basically. Let's run this query. This is a bit of a questionable query. So select splat from comments by user, semicolon. Is it right? Yes. What will you see here? Well, a bunch of rows. Yeah, now I made my font size big, so these are wrapped on 2 lines. Too bad, but anyway, you see not only you see the results, 1 row, 2 rows, 3 and 4, but you also see the header, the captions, and you see that what is red is the partition key, what is cyan and blue is the rest of the primary key, and these purple ones are the data columns. Anyway, you are graphically reminded of the structure of your table, and you see these are exactly the rows we've been inserting. That's all good and nice, but actually this is not the best way to query a table. You see, this is what Alex mentioned as, this is a full table scan. So if you have a billion rows, this select would be terrible in production, because that would have to query many nodes to get data from many partitions. And this is not what you are supposed to do in Cassandra. So let's make something better, which is the right pattern to access data. And this is this kind of query. Select from table where at least the partition key I should always specify, which is what I'm doing here, where user ID equal something. I think the colon is missing, semicolon, and there we go. Now, instead of having, you see, instead of having everything, including this 2 row, this is now only 3 rows, and they are the rows that are in my 1-1 partition. This is a good query. This is not putting strain on the cluster, because it just goes to one node, to one partition, and gets my data. Super. Okay. Again, let's do a bit more reads. So let's read the data from comments by user again, or comments by video, same kind of pattern. These are all, let's say, questionable readings, but still they are there. So I'm reading all rows. In particular, I want to point your attention to, let me make this easier to read. So you can also see what you do to select specific columns. Okay. So you see there are 4 comments by video, 4 comments in the comments by video table, and one of them in particular has a particular video ID, this 1, 2, 3, etc., and it has a particular text. So yeah, that guy Patrick is such a geek. Very good. Now, okay, let's go to the update. Let's say we want to change the data. Let's say we want to edit this comment because the author of the comment went to our application and they decided to edit the comment. So this is how this is how the data was inserted. So insert into blah, 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 and then you see comment and the text, such a geek. Video ID is the one you saw in the SQL console. And you see how the table was created. In particular, there is a video ID and a comment ID in the primary key. And now our goal is we want to change this string here. So to do that, we have to issue an update or another insert statement. Actually, they're almost the same. But to do that, to reach the right row, we have to specify the value for the primary key, because we have to let Cassandra know which is the row, what is the row we want to change. And this is how we do it. You see, update table, set field equal new value. You see, this is a different text, the new edited text. And it's very important that in order to change that field in that row, we have to specify the full primary key in the where condition. So we change this field, this column, where video ID equal that one and comment ID equal that one. Let's do that. So this is the update, and that's been executed, and we can read again the whole table. Yeah, you remember I have very big characters, very big font. So let's do this. And you remember that it was different. It was such a geek, and our update has been successful. So very good, all nice and good. This is just the tour of the main features. So creating data, retrieving data, updating data, and what is missing now is deletion. So the same logic for deleting data. I want to delete that row because the user responsible for this command decided, oh, okay, I want to delete this comment from the video. Okay. In our application, probably we would run in our API or drivers, whatever, we would run a statement similar to this one. Delete from table, where, again, I have to specify the full primary key. Let's run this. So delete from comments by video, where video ID and comment ID. You see, I run this command, and I think that if I run my select again, haha, you see, this row has plain old disappeared. So I think my delete has been successful, and that's it. So this was a very simple and very introductory course, a very introductory hands-on, where you just saw the basics of writing and retrieving and changing and deleting data from Cassandra. Obviously, this is just a tiny door onto a very wide universe of what you can do with Cassandra, and you are strongly encouraged to go forward. Just a note on the homework. You should take a screenshot of something like this, so the results of the query before and after deleting, and use it to submit the homework. Okay, so there is a bit more in the homework because you should also, let me reach the point here. You should also, that's very cool, because besides this practice with your own Astra, your own Cassandra database, there are also very interesting, fully interactive courses here in the form of scenarios, which are a mixture of, theory. And if you click start scenario here, you will be able to interactively run some commands and learn what they do in your browser, but you will work with an actual Cassandra installation running for you in the cloud again. So I think I lost the GitHub here. So to complete the homework, you please go to these two courses and you complete them. They are very short and you will learn a lot. And at the end, there will be a congratulations screen. Take a screenshot of that and attach them when you submit the homework. We will be happy to grade them and to award you your maybe first badge of Cassandra expertise. With that,
please give us some time because we manually verify those homeworks, and we're definitely not going to do it on Sunday. Not earlier than Monday or Tuesday, we will take care of them.
Good point. So give us a few days to grade the homework, but we promise we will go through all of them.
Yes.
Okay, so I think for the practice, this is it. You should. I think I can give you control back to your slide because there is a final slide that reminds you all of the homework and the scenarios, if I'm not mistaken, or maybe I can also do that myself.
I already switched anyway.
Okay, good.
To have more practice, you can go to katacoda.com/datastax courses Cassandra intro. One of them is included into the homework, so you have to complete it as well. It's all in the homework description. And that was it for the first workshop. We are done. Now, few very important points. In the end of this Cassandra Day, we have these vouchers for the certifications. These workshops are really great, but Cassandra is a complex tool, so you have to learn more. And to learn more, we do recommend you to go to the DataStax Academy. Academy.datastax.com is a free online courses to get deeper into the Cassandra and extend your Cassandra knowledge. There are admin, developer path, and the Cassandra developer path. Take the path what suits you the best, and you will be after that ready for the exam, which you can take for free with our voucher, and Academy is free of charge anyway. That can really change your career because Cassandra certification is great and in high demand, and that's amount of data on Earth will only grow, and more people and companies will need Cassandra power. So academy.datastax.com is a great place for you to extend your knowledge, but don't miss next workshop. Next workshop by Stefano about data modeling is a very important workshop to be successful with Apache Cassandra. And then don't forget to ask your questions using the link what Stefano gave you already. We will have Ask Me Anything session within a couple of hours. And most important, now we are going to have a break. And after break, we will play a game where you answer questions and you can win the prizes from DataStax. Stefano, do you think I have to add anything or we are done?
I think that's it. So I hope you've been paying attention because the quiz will mostly be about what we saw so far. So yeah. Yeah, I think that's it more or less. And we will resume at 13 Singapore time, which means in 33 minutes from now. We run a bit later, but that should be enough to grab a quick lunch.
Yes.
For you, and maybe a breakfast for us, a small breakfast, because here it's 6:30 in the morning. So yeah, small coffee, maybe a small breakfast, and we will meet in half an hour or more.
See you in half an hour and get ready for the game.
And get your finger flexing because it will be important to answer fast to win, not only correct. Okay.
So have a good lunch, have a good breakfast, or have a good coffee, Stefano, and see you again in 30 minutes.
Yes. See you. Bye.
hello everyone. Welcome back to Cassandra Day Singapore, and please welcome Niraj, our colleague and friend who will help us to run this quiz and ask you questions. Hi, Niraj.
Hey guys.
Okay, and welcome everyone. Welcome back. We are happy to see you here, and we are going to have a game. Play the game. We ask questions, you answer them, and those who gave the right answers fast enough will win the prizes from DataStax. Today with me, Niraj, our friend and colleague, and he will help me to ask you the questions. Hi, Niraj.
Good. Hey Alex, how you doing? Hey guys. Glad to be
All
here.
good. All good. Looks very nice. And if you can hear us if you can see us, please set the likes and thumbs up in the YouTube chat because we are going to start the game. Here you have the instructions how to get to our playground. Please go to menti.com and enter the code 9450732 or just scan the QR code next to Niraj and we will start. So once again, link, if you prefer link, it's in the chat and code is in the chat and QR code is on your screen. And in the beginning, to make you familiar with Menti, we start with just questions, normal questions with no right and wrong answers, and then game will start in a couple of minutes. So let's get ready. Answer those questions to become familiar with Menti. Question number 1. What's your experience with relational database management systems? Hey, Niraj, I believe you worked a lot with relational database systems before.
Yeah, maybe a little bit. Probably some would say more than others. What about you? Yeah, I'm pretty sure you've worked with a lot in your time.
Yeah, sure. Well,
Yeah.
Last years my heart belongs to Cassandra, but before that, of course, I was using a lot of different relational databases. And of course, most of the people we have here today have experience with relational databases. While I'm asking those questions, people jump in, don't miss your chance to win, please. And
yeah, we've got a few there that are stacking up. We've got a couple for none at all. We've got 6 that's saying a little, 18 that are saying all the time, and 0 saying that black belts enjoying.
Okay, I hope there will be no echo, which is weird. Okay, so next question. What's your experience with no relational databases? A little. Okay, now distribution is different, of course. 0 to little, little to 0. Only one person works a lot with NoSQL databases, but we don't have any NoSQL gurus. And that's quite expected. So welcome to Cassandra Day Singapore. It's a NoSQL event where you get better with NoSQL database knowledge, and Apache Cassandra is one of the best of them. Well, and I believe one of the last questions before we proceed to the game. What's your experience with Apache Cassandra or DataStax Enterprise or Astrum?
Ooh. It's coming up. A few.
Okay, so looks like most of you don't have experience with Apache Cassandra or general understanding. And you know what? That is great. So don't miss the second workshop. Don't miss the second workshop of Stefano. He will explain you the data modeling rules, and that's essential to be successful with Apache Cassandra or DataStax Enterprise or DataStax Astra. And here we go, and here we start the game now. I hope you now understand how to click the buttons. Now take a look. Very good advice. YouTube has a slight delay. So you will, if you want to be fast, you want to see the questions on your phone or on your mobile phone, on your browser, more than YouTube, because YouTube will have a slight delay. With that said, we start. Let the battle commence. And that will be a series of 13 questions, and you have to answer fast to get more points. How many master nodes does Cassandra need? At least 3 per cluster, 3 per data center, not a single one as Cassandra is decentralized, enough to maintain consistency.
Almost up. Time's up for the answers. That's correct. 23 people got it right. That's pretty good.
That is a great result, people. That is a really great result, because you made it very, 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 very right. It's not a single one. Cassandra is decentralized. And I see there are 3 persons answered, at least 3 per cluster. I believe that those are latecomers, because we explain at this moment Cassandra is decentralized, and Cassandra does not need kind of master nodes. They just don't exist in Cassandra terminology. That brings us to a leaderboard. And who was the fastest one? Okay, George was the fastest. Well done, well done.
Good. Snuggles is next. Then we got Thinky, third place.
Yeah, but difference in points are very, very, very minor. So that's only the beginning. So let's go to the next question. And that's question number 2. Answer fast to get more points. How data is being distributed over the cluster? By partitions, all data is replicated to each server with address locators using postmail. Oh, that's not going to be...
7 more seconds. Come on, guys.
And
3.
time is up. Time is up. Okay, how data is being distributed? Right, by partitions. And there are 7 people said all data is replicated to each server. Take a look. There are companies like Apple who store hundreds petabytes in Cassandra. That wouldn't be a smart decision to copy all data to each server. So data is being distributed by partitions. And what do we have on leaderboard? I'm curious if George kept his first place. It was a fast answer, but not fast enough, and George goes down to the 3rd place, which is still good because first 3 places get the prizes. And GST with the fastest answer gets to the 1st place, and that is a great result. Then Denny Risky is on the 2nd place and George on the 3rd, with the Gaura following him very, very close with few points. So let us ask the next question. Question number 3. So answer fast to get more points. How to scale Cassandra cluster? Vertically, upgrading servers, increasing scaling factor, horizontally adding more servers. Don't scale, Cassandra performance is always enough. Oh man, that would be great, isn't it?
That would be.
Yeah.
All right, couple of seconds to go.
Right, so most of you made it. Cassandra scales horizontally by adding more servers. There is no thing like scaling factor. Maybe you meant replication factor, but it's not about scaling. And vertical scaling is not the best way for distributed databases. And there is one person who answered Cassandra performance is always enough. Thank you for trust, but no, in some cases you might need to scale your cluster for real. But we appreciate. Okay, So,
What does the leaderboard look like now?
yeah. So, okay. There are some changes. GST was the
Nice.
fastest again. And George
Very
made
good.
it. George made it to the second place now. That's a great. And Gaurav is on the third. So looks like we lost someone of the former leaders. But there is a lot of things going in here. So let's take a look. What will happen after the next question? So that's a question number 4. Answer fast to get more points. Which replication factor is recommended? 1.5, 3, 15, 42. Hope you get the reference. Out of those options, my favorite, of course, is 1.5. I always configure my cluster like that. No. You should have trusted me, but you didn't get into this trap. Of course, recommended. Of course, recommended replication factor is 3. Replication factor 1.5 is a joke. It cannot exist. Like, it's half bit or half server. It's impossible. And 15 is just going to be too much. So, let's take a look on the leaderboard. Maybe someone of the leaders made a mistake.
Could there be some changes?
Yeah.
So, JST was fast.
He made it again. GST is fastest again. And there are no changes on the top 3. Only some fights in the lower part of the leaderboard, but it's still the same: GST, George, and Gaurav. Hey, and Vibe Half is very close to Gaurav with just like 40 points difference, which is nearly nothing. But we have more questions to come.
I wonder if they can, if Varab is going to change places here in the next question.
Let's see. So that's question number 5, and we start countdown. Answer fast to get more points. Cassandra cluster can be deployed on AWS only, any combination of cloud providers and on-premises, only one cloud provider of your choice, Sega Mega Drive.
I reckon Sega Mega Drive.
Yeah, me too.
That's what I deploy it. Especially on the weekends.
Right. So it was easy. It was too easy. We need to add more advanced questions for you. Any combination of cloud providers and on-premises simultaneously. Cassandra is platform and vendor agnostic. Okay. So leaders made no mistake, but Vibe was faster than Gaurav. Still not enough to get into the top 3. But now the difference is only 5 points. Like, that's really briefing. very close, very close. And GST...
Maybe the next question, Alex.
Yeah, that is cool. So, let's take a look what will happen in the next question. I want to see some changes on leaderboard, otherwise it's just boring. Some people may fall, there are more advanced questions ahead. And that's a question number 6. So answer fast to get more points. Cassandra cluster can have multiple data centers. Wrong. Single cluster can have only single DC. Correct, but not more than 2 DCs. Correct. Some DCs are passive, only read-only. Correct, all DCs are available for read and write. And time is up. And most of you made it. Correct, all DCs are available for read and write. Well done. You made it. There are 2 people answered correct. Some DC are passive. And that is relational database thinking. Please stop it. Not on my sheet. In Cassandra, every node and every DC is active always. And there is also a mistake. Correct, but not more than 2 DC. With Cassandra, you can have as much DC as you want and as your business needs. So,
how it goes. No mistakes by leaders. There are some changes on the bottom of the leaderboard. And Gaurav overtakes George. Okay,
Wow.
George is on the third place.
That's right.
Good. So, the battle goes on. Question number 7. So, answer fast to get more points. CAP theorem claims what in the case of failure, C, A, and P are all guaranteed. Only A is guaranteed. Only 2 of 3 are guaranteed, or CAP theorem claims what we will need a new cap. That's quite a lot of options. But who of you remembered what we said about CAP theorem? Okay, most of you. And take a look. Niraj, looks like we have 6 people from the country of unicorns and rainbows. What in case of failure, C, A, and P are all guaranteed. Guys, please send me the ticket to your wonderful land because I'm going to move. I want to live in the place where C, A, and P are guaranteed in case of a failure scenario. In our world, with not so much unicorns and rainbows, in case of failure, only 2 out of 3 can be guaranteed, if you did everything right. So, let me see the leaderboard. I still want to see the mistakes by someone in top 3. Because
See, it was fast.
yeah, hey! Now George is back on the 2nd place and Gaurav is on the 3rd. And Chetan is getting very close to them. So there are still chances to change the top 3 and jump in for a lot of the people on this leaderboard. So
Yeah, only a few points separating third and fourth there. Alex.
yes. So everyone have chances, especially if leaders will do mistakes. And that's a question number 8. So answer fast to get more points. Recommended way to reach immediate consistency is read-write 1-1, read-write 1-all, read-write quorum, or with a video chat. Well, I don't know. When I want to have consistency with my colleagues, I usually take a video chat option. It always works. If it works for me, maybe it works for Cassandra as well. And time is up, and most of you made it, but now the proportion is a little bit different. Take a look. Read-write quorum is the recommended way to do it. With read-write 1-all, technically it's also a way to reach immediate consistency. It will work. 1 plus all will higher than the replication factor, but it's not a recommended way. And finally, read-write 1-1 is a recommended way to reach inconsistency, but not immediate consistency. So 1-1 can be dangerous. Those are dangerous grounds. Our recommendation is to go quorum to reach immediate consistency. Okay, who made a mistake? Oh my god! GST! It was such a good ride. We just lost the leader. Oh my god, he went just to 8th place.
Wow, that was a big change.
Yes, that is a big change. Now George, with the fastest answer, gets to the 1st place. Gaurav is on the 2nd, and Chetan made it to the top 3 with NP staying very close to him.
Oh, into the last couple of rounds here, Alec, and it seems that 1st and 2nd places are very close.
Yeah. Do you think GST can try to make it back to the top 3?
I think he could. He could. He's got to get the next couple of answers right?
Yeah, he is giving answers very quickly, so maybe we will see him back again in top 3. And ladies and gentlemen, that is question number 9. Answer fast to get more points, but your answers have to be right. What is a key space? It's organized into rows and columns. It contains tables and defines replication. It defines it with partition key and contain rows. It's the place to store keys. Well. Okay. It was easy. Yes, it contains tables and defines replication. It's not organized into rows and columns. It would be the table. And it's not defined with a partition keys and doesn't contain rows, but tables. So let's see the leaderboard. Are there any mistakes? No. Top 3 looks... Oh my god, this MP made it to the top 3, overtaking Chetan, and George and Gaurav are keeping the first and second place consecutively. And GST with the fastest answer, by the way, notice his answer was the fastest, is on the 8th place. Well done. So, question number 10. Answer fast to get more points.
3 more questions left.
What is required in a Cassandra table? Data columns, clustering columns, partition keys. Nothing is required, everything is allowed.
Everything being allowed would be awesome, right?
Yeah, that would be good. But it's a little bit different. So time is up and most of you made it. Partition keys are required. That is right. So let's take a look. Who was the fastest this time? GST is fastest again, getting to the 7th place. Okay, but time is running and we have less and less questions left. George, Gaurav and MP holding their positions in top 3, and Chetan and Nevi still can try to get in, especially if some of the leaders will make a mistake. And now it already feel a bit nervous, right?
Yeah.
Question 11. Answer fast to get more points. Cassandra tables contain multiple partitions, only rows and columns, replication factors, endless seas of dreams and fears. What Cassandra tables contain? And that's, you made it. Good. Multiple partitions, and that's the right answer. I see some people answer it only rows and columns, and I do want to warn you, if you will work with Cassandra thinking of it as like rows and columns thing, you will get into troubles very soon. Never forget about the partitions, or the partitions will take their revenge, and you may run into troubles in your production. Partitions are very important. So, multiple partitions, that is the right answer. And who made a mistake, who was slow, and who was... Oh, MP, that's where... GST made a mistake again. He was too much in a rush, I believe. Oh, yes, that's...
George was the fastest.
Yeah, 2 mistakes is too much. I am afraid he lost his chance to get to the top 3. And MP, I also not really sure if it will work, but George with the fastest answer, Gaurav and Chetan now making the top 3, with Rajiv holding very close with 300 points difference. Oh, like I'm getting
like
nervous.
A bit of a battle for first and second place there, Alex.
Mm-hmm. Yes. So, we are getting close to the end. That's question number 12. And answer fast to get more points. How Cassandra executes joins? Joins require dedicated join table. Like in SQL, it doesn't. It does, but kinda lazy. How Cassandra executes joins? Huh? Sorry?
I was going to say, mate, I don't think she's lazy, though. You think she's lazy?
Okay. So it does not, Cassandra does not execute joins. There are no joins. It's a NoSQL database. Not like in SQL, not like with any kind of a joint table. They just don't exist. The right answer, Cassandra does not execute joins. And how do you work with the data then if there are no joins? Next workshop, Stefano will answer this question. So, how it goes on the leaderboard? Rajiv made a mistake. It will give him no chance to jump to the top 10. Difference will be too big. GST is fastest again, with on the 8th place, which is a great result, but not good enough to get to the top 3 for sure. And now Denny Risky is going to fight in the last question for the 3rd place, I believe. I already feel this energy in the air. Everyone is ready for the last question. I don't want to make you wait for too long.
Who's going to win though? Let's see.
Yeah, it's the last question. Now we will have a winners. And ladies and gentlemen, that's the last question of our game. Question number 13, my lucky number. Let's start. Answer fast to get more points. You know what to do. Single data center cluster of 8 servers. How many servers we have to add to double performance? 4, 8, 12. It's not possible to double the performance in a single data center. 4, 8, 12. It's not possible. And time is up.
See who answered the fastest.
Yeah, there are a lot of right answers. Before we proceed to the leaderboard, I have to say, there are again 6 people who answered what 4 servers will be enough. I bet those are the same 6 people who believe what it's possible to have CAP in case of failure scenarios simultaneously. Guys, I do need a ticket to your Wonderland, like for sure. No, sorry, it's not enough to add 4 servers to an 8 servers cluster. Of course not. It cannot double the performance. There are some laws of physics in the end. And 12 can be too much because if you want to double performance, if your data model done right, then double amount of servers must be enough because of famous linear Cassandra scaling. And yes, it is possible to double the performance in a single DC. And now I'm pushing the button and we will see the leaderboard. Cheetan makes a mistake. Oh man.
Oh. He was the fastest.
Yeah, Gaurav is the fastest. And then Niriski uses the mistake of Cheetan to get to the top 3. Very last moment, jumped to this train on the very last moment. And George makes the first place. 12,375 points. That's incredible. That was a real competition.
Super close right down to the wire, right?
Yes, and that's so dense, like point to point, they answered so close through the whole quiz. Now, what do we do? Winners, so top 3 placed, George, Gaurav, and Denny. Make a screenshot of your winner champion screen. You will have to send it to jack.fryer@datastax.com. I believe Stefano will give you the address on YouTube chat. Oh, okay, it's done already. Thank you, Stefano.
Oh, okay.
Now,
congratulations to the top 3 winners.
Yeah, I would say congratulations to the top 3 winners. Even if you are not in top 3, but still see yourself on the leaderboard, congratulations, because there were a few dozens of people and you made it to the top 3. That's definitely a great result. To the top 10, sorry. That's definitely a great result. And even if you are not on the leaderboard, you know what? Our prizes, let's admit it, it's not like Ferrari or villas. So first, better luck next time. On this channel, we run workshops usually 2 times per week. So hit the like, hit the subscribe button and participate in our next game. So you will have more chances But that's what matters the most. It's not this game and those prizes, but your knowledge. You earn it today, and you will earn even more with the next workshop, which Stefano will start in a moment. Congratulations to all the winners. Federico, thank you for joining. Thank you for everyone who likes that. I see 51 concurrent viewer at this moment, but only 19 likes. Ladies and gentlemen, please fix it right now. We deserve more likes, and you know it. And if you don't give us more likes, we won't proceed with the next workshop. No, just kidding. We will start next workshop in a minute, of course. But thank you so much for your support, and we will happy to have you again. Niraj, how do you feel? Do you think we did a good job with the first workshop, judging by the answers?
I think we did. I think we did a pretty good job. But there's a couple of people who still believe in unicorns and some amazing fairy tale lands that I think will benefit from the next workshops. So hopefully everybody enjoys what's coming up. There's some great workshops that have been held by the team.
Right. Thank you. So thank you, Niraj. We will meet you again at our Ask Me Anything session, right?
That's right.
Great. So see you again in a couple of hours. And now we proceed with how to design an efficient data model for an application working with Apache Cassandra. So that's going to be very interesting. Stay with us, and I will get back to you in a moment. Hey, looks like we are back.
Hello, everyone. Welcome back. So, you know, Alex, that I'm not seeing the YouTube live. So tell me, is it all right? Are attendees looking at my slides?
Yes, all good.
Okay, and we are both on screen. So welcome back.
Welcome back.
Let's start. Okay. So I hope you've been having fun with the quiz. I was watching you, and there have been a few surprises during the quiz. And congratulations to the winners and to everyone for having anyway showed that you paid attention and you learned a lot, I think, during the first workshop. Now let's go more in detail into one of the topics, one of the most important topics, namely data modeling. So in a sense, this workshop will be, shattering the dreams of unicorns and rainbows a bit more, because this is somehow our goal today, unfortunately. No, I'm joking. We are not here to destroy your dreams of an ideal CAP world, and sublinear scaling world, but we are here to teach you how to squeeze the best performance out of Cassandra. No offense meant to unicorns. By the way, you have been meeting Jeremy and Niraj so far, who are from the Asia side of DataStax. So just by way of introduction, Alex and I are strictly organizers of the Cassandra Days. And so this is a bit of our thing. But obviously, for today's event, we have been joined by some of the best data architects in the Asia, Pacific, and Japan region. So you will soon meet Yoshi as well for the Ask Me Anything session, and they are fine, great guys who with a lot of knowledge. And in case you want to explore more on the topic of Cassandra, they might be good contact points for for setting up proof of concepts or stuff like that, or any kind of further interaction. So that being said, I would like Alex, if you please paste in the chat the link to the questions to the Ask Me Anything website. That would be great, because
sure.
I'm sure this presentation will make you come up with more questions. And if you think they are interesting, please paste them in that link so we can then discuss them at length in the Q&A session.
Right, and best questions get prizes.
Yes, and you can vote other people's question if you're interested in them as well, and they will be awarded the prize. Okay, so with that out of the way, let's go back to the topic, data modeling with Cassandra. That is building efficient applications. Or in other words, how not to shoot yourself in the foot with Apache Cassandra, because this is something we mentioned already in passing. If you just take your relational knowledge and apply it to Cassandra, you might probably run into problems later. Because it's a powerful database, but it's very different in terms of internal architecture. It's very different than relational databases. It's one of the many flavors of NoSQL database. And this means that some knowledge of how it works internally is needed to be able to exploit its wonderful performance and ability to scale. So before we start, something that I'd like to refresh to all of you. This whole day will be still available for watching later on YouTube at this very same link. Now, I just mentioned about questions, so you can ask them in the chat, which is, so they are only for the duration of today, so be worried, because best thing would be to ask questions in the Q&A website, so we can then discuss them later. We say just right now prizes, so please add your name to the questions so we can track them to the prize recipient. Another option is to contact us and maybe keep in contact, join us on Discord. The link, maybe Alex, you can paste the link now. So we can, on Discord, we have a thriving community, and we can bring the discussion forward. You can have other questions we can discuss for a long time. And there is a whole community of Cassandra experts there to help you setting up your whatever, your application, whatever. So this workshop about data modeling is a bit less than 2 hours, which is obviously not enough to cover everything with data model, but should give you a good start and maybe wake up your curiosity for more. In order to get the best from this workshop, you should have absorbed some of the notions that Alex presented earlier in the fundamentals. So at least you should know what a database is. And in case you know what a relational database is, that's good. But maybe that's also not so good, because this is a bit of knowledge that you have to somehow shed off to properly work with Cassandra. It will become clear in a while. Okay, last remark. When I say Cassandra here, I mean not only Apache Cassandra, the titular product, but also its commercial version, DataStax Enterprise, or it's in the cloud wrapping, so the product built on Apache Cassandra that you used earlier for the exercise, which is DataStax Astra. So this is a broad sense when I say Cassandra. Okay, so who am I? We met already. I'm Stefano. I'm a developer advocate at DataStax. I'm happy to connect the developers with the power of Apache Cassandra. This is how you might want to get in touch with me, so please do. I'm very happy to that. Yeah, I used to be a theoretical physicist, and now I work in the IT industry. And yeah, I like spiders as a personal note. I like spider biology, but that's not relevant. Alex, you met already, so let's move forward. Okay. So, what are the points of today's presentation? First, we will introduce a bit Cassandra as a refresh. We will touch on some of the points that have been seen this morning already. After that, we will see the role that denormalization plays in the basic design of Cassandra, and so how tables are structured and what is the goal of denormalization. With that in mind, we will have a closer look at partitioning and primary keys, a concept that you've seen already this morning. That will lead us to have a deep inspection of how to query data and how queries work, which is important and will lead to the main dish of this presentation, which is data modeling proper. So how you design your database when you want to have an application running on it. After that, if there is enough time, we will touch on other, say, side dishes, side topics that might be very useful to have in your tool belt when you start approaching modeling of your data with Cassandra. Okay, so let's start with the introduction. Alex, is that all right in the chat? And
yes, we are good.
Okay,
you
great.
can just start.
Okay, so first question, what is data modeling? Well, data modeling is the set of activities that make you able to design your database according to what your application needs. So you start with just an idea of what is the application you're going to build. Probably we are in 2021, so probably it will be a web application or whatever it is. You have an idea of your application, what it needs, and you do data modeling, this operation, and you end up with your database created there, ready to use. This is data modeling. So before starting looking at how data modeling works in itself, let's summarize some key features, some key aspects of Cassandra. You've seen them already this morning, but a quick refresh doesn't hurt. So what is Cassandra? Cassandra is a high-performance NoSQL database, and it is very powerful, but in order to use this power, you need some knowledge on how to use it. So high performance, size. Cassandra is able to deal with very big data, so what is called the web scale. You've seen briefly this morning in the introduction slide, in the 15-minute introductory presentation, that Cassandra is able to deal with databases of size hundreds of petabytes. So that is 1/10 of an exabyte. So there is such a thing as an exabyte, and Cassandra is able to deal with this scale of data, which is astonishing. All of these hosted on commodity hardware, so you don't have to necessarily buy expensive, dedicated, super powerful servers, but you can just have many ordinary machines. Speed, another thing about performance. Cassandra is optimized for writes. So writes are designed to be extremely fast. That's not to say that reads are not, but usually writes are the pain points for many systems. So Cassandra is fast. It can sustain tens of thousands of operations per second per node. Sometimes we say transactions, but this is a dangerous term in this context because, as you will see, there are no transactions in the relational sense. So let's say operation, writes and reads. And when I say operations per second per node, I say per node, which means that Cassandra is structured to be distributed, to be heavily distributed. So a typical Cassandra database is distributed over many nodes. Nodes might be virtual machines, physical machines, whatever, but they are servers and they collectively form your database. Indeed, a Cassandra database might also be spread over the world in different data centers, one in US, one in Singapore, one in Italy, and so on, and they still form a single database with all of the advantages of that and the internal complexity of making this work, but that's a problem for Cassandra, not for you. Okay, so what is a NoSQL database? Basically, it means that it's it goes beyond the relational database paradigm. In particular, it is not relational and it is not transactional. So very briefly, there are no joins in Cassandra, which might be puzzling to relational guys who are watching. We will look at this in more detail. No joins, no foreign keys, no transactions. So that already might suggest that when you are building your application and you are designing the database behind it, some different line of thinking is required, and you will see that. Okay, so you must learn how to use Cassandra to squeeze its high performance. Yes, because let's face it, it's easy to just naively approach Cassandra and make an underperforming application, make an underperforming data model. A good point is you have somehow to unlearn some of the relational knowledge that has been traditional for more than 50 years now. That's because if you get the data model wrong, your performance will suffer from that. So some of the knowledge of how Cassandra works internally is crucial to get this right. And let me tell you this. If you start with the wrong data model and you then go in production and then you have to change it, that's going to be something that you want to avoid. So you better spend some time in modeling your data properly, and then you jump in production with a bit more confidence of how it will perform. Okay. So that's by way of introduction, and let's touch on another point. So there is, in the world of databases, there is a big distinction, a big axis you can place databases on. So you can classify workloads according to this big distinction between OLTP and OLAP. So OLTP, online transaction processing, is the kind of workload where you just need to, every single operation is you go to one table, you change a single piece of data, and that's it. So very predictable, very simple kind of operations, like, I don't know, increasing a number, writing a new row, changing the status of an item from warehouse to shipped, something like that. And this is a very typical workload, and usually this requires almost real time. It has to be fast. Operations are going to be simple. So you see here, need answers now. So it has to be fast because this is usually what is right behind my application, right behind my client, my customers, and it has to work quickly. Usually the queries in this case are simple and they are unchanged. So they stay the same throughout the life of your application.
Yep. Usually,
on the other,
usually OLTP stays on the customer side of your application, because your customers will not wait. If you are slow, they will go to your competitors. So OLTP stands for fast answers, and that's what matters the most.
Yeah, exactly. Good. Thank you. Fast answers and luckily simple operations on the database, usually just on a single piece of data, and that's it. On the other end of the spectrum, there is OLAP. OLAP is the typical big, complex analytics workload. Something that might involve a lot of data that have to be coordinated, compared, mangled in various ways, shuffled, and then reprocessed, and a lot of things. Complex queries that involve comparison of different pieces of data. And that's probably something that is not directly facing your customers. It's more of an internal thing. You want to have every Friday night, you want to run your big monster analytics machine in order to optimize special offers for your website the week after that. And that might run for 3 hours and give you results. And then maybe you tweak it every week. You tweak a bit the analysis to change this and change that and so on. So typically OLAP workloads involve a lot of complex queries in one. They are probably evolving all the time. They are for internal use. So my analytics team in my company I want every week a report of how are things going, what I have to optimize, to change. And luckily, such complexity comes with a relaxed requirement on response time. So I can maybe wait the whole night for the analytics workload to work, no problem. But on the other hand, it's a complex thing. So these are somehow two extremes. You can have workloads everywhere in this spectrum. This is a continuous spectrum if you want. All of this introduction to tell you one thing. Relational databases somehow are a one-size-fits-all kind of thing. So back when there were not, when there were only relational databases, they were used for everything from OLTP to OLAP, right? And they were somehow satisfying all needs up to a given scale. Cassandra is specialized for OLTP. So Cassandra, now I don't want Cassandra to get angry at me, but in a sense is very stupid as a database. Now, this is a joke, but what I mean is that Cassandra is very good and very fast at doing simple operation. A lot of them all the time, simple operation. Go to one row, change it, write one row and stuff like that. It's very quick, very real time and so on. Alex, sorry, I'm hearing some echo. Maybe you
Let me
did
check.
something.
Can you say a word?
Maybe. Yeah, that should be gone. Yes, sorry. It was just not so loud, but yeah, thank you. Okay, so Cassandra, we were saying, is specialized in OLTP, and it's in itself not particularly optimized for OLAP workloads. That's not to say that you can't do that. Actually, there are many, so there are a few solutions that allow you to use Cassandra for the data storage and plug some OLAP specific tools such as Apache Spark on top of it. Okay, so another reminder, so pros and cons of Cassandra. Cassandra is ready for big data, as we have seen now. It is very highly available if properly configured. It doesn't have any single point of failures. Remember, no masters. Every node is created equal. Every data center is created equal. So it's really a distributed, democratic kind of structure. It is possible to have a database that is geographically distributed. So distribution involves all of the consideration about CAP theorem that you saw so far. It is optimized for very fast read and write performance. And a very important point is that it is vendor independent. Namely, it is an Apache project, which means that it is covered by the Apache license, which guarantees that it will be open source and ready for you to use. Now, let's look at the possible negative points about Cassandra and how we propose a solution to them. So Cassandra requires qualified engineers. So it's not the kind of database that you just install and learn to use like this. Yes, but that qualified engineer might be you, because there are certification programs, and as we mentioned already, if you become a Cassandra expert, on average your pay will be higher. And as of now, there is very high demand for Cassandra specialists in the market, so that's a good bet. Another point is that Cassandra is perceived by many as complex to manage. Yes, so it might require some expertise in the operation side, but nowadays there are managed solutions such as the Astra that you used this morning for the exercises. Another point, as we mentioned, is that Cassandra is specialized for OLTP workloads. You remember, very fast, simple queries that have to work in real time, not so much for big, complex joins and analytics. Yeah, okay, but as we mentioned, as I said, you can plug easily Spark or other solutions on top of it. So that's not really a big limitation. Another point is that Cassandra has limited capabilities when it comes to search, such as you want to do some full text search, fuzzy search, stuff like that. Yeah, Cassandra is not made for that. And as Alex likes to say, good work comes from teamwork. So yeah. Again, in this case, you can couple, and it's very easy to couple Cassandra to pair it with, for example, Lucene-based search engines, Elasticsearch or Solar. They go very well with Cassandra, and yeah, it's a good kind of teamwork that takes the best of both worlds. Okay, so that was just an overview, which I conclude with a first glance at the differences between modeling your data in a traditional relational database and in Cassandra. So Okay. In a traditional database, you have joins and indexes to pair and to connect pieces of data in your database, namely to connect tables basically with each other. In Cassandra, there is no such a thing, and you will work with denormalization, which becomes a first-class concept in designing your data pillar of it. You will see that. A relational database offers the comfort of referential integrity, so it's a sort of built-in safety in a relational database. Cassandra doesn't have such a thing, and that's, you know, some bad news that comes with the fact that you have to scale to very big data, very big sizes of your data set. So you just would not be able to keep performance high while enforcing referential integrity, which is one of the points that requires you to think different. In a relational database, the primary key of a table is there to ensure uniqueness, and that's it. While in Cassandra, it also contains information on how data is partitioned and how data will be accessed in your queries. You saw most of it already, and we will come to that later very in detail because it's important. Now, when you model data in a relational database, you start with the entities and then you build the queries for your application. In Cassandra, that's the other way around. You start with your application, and from the queries, you build the database. And you will see what I mean by that. It's fun. Okay, so that's it. And I think it's time to go to the topics. So denormalization, that's a very important concept. And in order to have a look at denormalization, I would like to start with normalization. Normalization is a very big idea that somehow marked the birth of relational databases back 51 years ago. The idea was invented by Edgar Code to make databases able to automatically guarantee data integrity. So a series of what are called normal forms was invented, and they made it possible to comply with the rule never duplicate information. So look at these three example tables. There is a table with recipes. There is a table on the right with ingredients, but you see that a recipe contains many ingredients. So we have pizza that contains mozzarella, champignons, and so on. And we will have a third table that just expresses the pairs, the couples of any ingredient with any recipe. You see that the name pizza occurs only once, and the name mozzarella occurs only once. The relations are just indices. So this is how you would solve this one-to-many relation in a relational database. So you see there is no duplicate information, and you can anticipate, if you have some experience with that, that you pay this formally elegant solution with, in general, complex queries. You have to do joins to find what are actually the answers to your questions. Indeed, let's stay with the pizza and the ingredients example. I anticipated already that this talk is full of pizza, and because I like pizza, and you will see a few pizza here and there in the slides, so be prepared. Luckily, you already had the lunch, so that's okay for you. It should not make you, drool. Okay, so normalization. You first design the tables, because the tables they describe the word. There is a table for ingredients, there is a table for recipes, and then you create more tables for the relations. And once you design the tables, actually, it's still up to you. You're still free to decide exactly what is your question. I might want, so, okay, here you just see the standard SQL syntax for creating and populating these tables in the example. You see there are relations between a field in a table corresponds to a foreign key in another table and so on. This is not news. This is not even the focus of today. But the point is that once I created the table, I can just invent any query. So if I need the ingredients for the pizza, there is this particular query that is a query that joins across 3 tables and gives me the answer. So pizza has mozzarella and champignons. And to get this answer, I'm actually already have to join 3 tables and do some complex things. But then I need the answer to a different question, and I just can use the same table. So really, there is no repetition of data, and I can get everything. So I can start with the tables, and then I can design my application, basically, my queries. That's good, but that's also not so good, because you see, this was a simple example, but in real life, in real applications, as time goes by, and I have more and more tables, more and more data, my queries start to get unavoidably slow because they have to join data to do complex things and so on. So my typical query will be a tower of joins, and performance is not happy. So this is something that was already happening as relational databases got bigger and bigger, and performance requirements were heavier, so higher and higher. Engineers started doing this. Okay, yeah, relational and whatnot, but let us just duplicate the data here and there so the reads are faster. That's a bit of a violation of the principles, but speed is important because my application has to be fast. Otherwise, my customers will turn to my competitor. So yeah, you see this table. This table violates the normal forms because I have pizza twice, I have cake twice. I want to express the fact that pizza contains 2 ingredients, and I duplicate the name pizza. Yeah, that's bad for the normal forms. That's bad for the relationals. But you know what? It's fast, because then when I have to query this table to get the ingredients for the pizza, I query a single table. And mind that, because of performance needs, that was happening already in relational databases by the end. So the idea is, well, let's take this idea and make it a first-class concept in designing your database. So it's not something frowned upon anymore, but it will become the main idea of how I design my database. And this is something that Cassandra embraces. So in Cassandra, you will have to take the denormalization, as this is called, as granted and work starting from this. Ta-da! This was a big point. So you will see application of this idea later, but let's just look at this point in detail. So denormalization means you can have redundant data, you can duplicate the data, and that's okay, with the goal that every query just has to look at one single table. I will never have to look at different tables and merge data and compare data to answer my one question. So every query goes straight to one table. That's good because it's fast. It's fast in reading because I just read a table, but it's also fast in writing in a sense, because while joins cannot be performed in parallel, joins have to be sequential, so reading would be slower in relational. I can arrange my writes in a way that they work in parallel. So yes, on one side, I'm moving the burden of connecting data from the reading phase to the writing phase. But I also have them running faster because I can parallelize them. So it's a double advantage. Double because usually I need my application to be fast, especially in reading, which happens much more often in most cases. So I move the slowness, if you want, away from the most used path of my application, reading. This idea plays very well with a system that is highly distributed, as Cassandra is, as a big data system has to be. There is another implication, though, that is if I have to handle denormalized data myself, so there is nothing in the database enforcing, constraints and data integrity, that means that my application will be responsible for that. Yes, that's the price to pay. So I will have to make sure that my application does, for example, multiple writes in a consistent way. Yes. But you know what? This is a small price to pay to have your application fast and able to deal with a lot of data, which is what nowadays applications are required to do. So yeah, the point is that Cassandra supports no joins, and this is a central point because it makes queries fast, but it also makes you, it forces you to think very differently about how you organize your data. You see, in this small sketch, you see on the left the relational world where every query had to query a lot of tables in general, while in Cassandra, the schema is very simple. One table, one query. In particular, every query has to be only on a single table. And this is the recipe. So the idea for denormalizing data properly is you put all columns that you need for a query in a single table because you will have no joins. And that makes for simple, fast queries. Because as we said, you need a query to be able to just go to a single table to get what you need. And this has a very important implication that is one of the main philosophies of data modeling with Cassandra. Identify the queries and then create the tables accordingly. We will see this more in detail. And this might sound scary and strange and foreign at first, but remember that redundancy, repeating data in many places, is okay, is your friend. Is your friend because, as we said, performance is important. So it's very much cheaper to have more disk space compared to having slow applications and losing customers. But you know what? In order to put this philosophy in action, you need to know something more about how Cassandra works. Okay, so Alex, how are we going with questions? Are there
all good? We
questions?
just discussing with Jeremy job market in Singapore. But other than that, looks like your explanations are perfectly clear, and we get a lot of questions on Slido, which is amazing. By the way,
great.
Don't forget not only to submit your questions on Slido, but also like questions of others, so we will know what you feel the most important and what do you want to know the most.
Yeah, definitely. Okay, so I can go on. Okay, so let's have a closer look at how keys and partitions work in Apache Cassandra. So how is data organized in a table? Yeah, because after all, data model is designing table, and designing a table is the structure of a table is what determines uniqueness of rows in the table. Not only that, but it also determines how the rows are grouped and distributed across the nodes in this big ring. It also determines which are the queries that I can run and which queries I can't. So that's very important. And also, depending on how the table is made, there are some pieces of data, some columns that I have to specify when I do writes. Okay, and this is important. This has to be known even to developers in a sense, at least to those who design the application, because that the two things, so table structure and application, are very tightly coupled. I would say much more than in a relational database. But first things first, let's start with a concept that is probably very well known even to relational database engineers. What is a table in Cassandra? You saw already this morning that Cassandra structures data in tables, so nothing strange so far. Tables are a bit like a spreadsheet, so it is rows times columns. So there is an example here. There is a table that I call reviews by recipe. Why? Because we started with pizza and ingredients, and now we have an application. Let's pretend we have an application where there are recipes and there are reviewers who write reviews of recipes. So look at the first line. Anita wrote a review about pizza on a particular day, giving it a rating of 8 with a comment, and so on. So this is the core of my application is reviewers writing reviews of recipes. Okay, and this is stored in this table here. Now, the point is that in general, if I design a table, I have to devise a primary key. What is the primary key? It is a set of columns that is used to define uniqueness of rows. That means that I cannot have two rows with the same values for the primary key. So the primary key identifies uniquely every row of my table. So look at this example, reviews by recipes, or anyway, this application of reviewers writing reviews of dishes. What would be a good choice for the primary key? Remember, I have to guarantee uniqueness. Let's see, if I just take the recipe name as primary key, that is really not good. Because you see, I have different people writing reviews on pizza, so pizza alone is not enough to guarantee uniqueness of the rows. So maybe I want to add reviewer. So I have Pizza Anita and Pizza Carl. That would be great. So that's okay. The third choice, I might be tempted to add rating itself. So recipe name, reviewer, and rating. Well, that's actually makes for unique rows, but I would say it doesn't really make sense because that would make it possible to have a review by the same person for the same recipe with different ratings, two different rows. That really, I don't think that rating belongs to the primary key. It's just an attribute of that review, so it doesn't make sense. No rating then. I might think of adding the date, which is also okay. And as you see, the choice of primary key is ultimately also a function of how I want my application to work. Because yeah, I might, this is up to me, up to how the application is designed. Shall I allow the same person to leave two different reviews to pizza on different days or not? Depending on the answer, I might want one or the other choice for the primary key. Okay, so can a reviewer vote multiple times? Yes or no? Then I choose the primary key accordingly. So there is a tightly coupling between table structure and my application needs. So for today, we will decide that Anita will be able to leave different reviews to pizza on different days, which means that we want to store the whole history of reviews by Anita on pizza. Why not? That's how my application has to work. Which means that we choose recipe name, date, and reviewer as the primary key. You see, I marked them in blue, and that's how the table is now structured. So uniqueness is guaranteed, and we can go on. I hope so far it's all clear. This is a relational database kind of concept and nothing so new. Now, uniqueness means that primary key identifies uniquely in every row in my table, every piece of data, which also has the implication that if I have to insert a single row or update, I have to provide all values for the primary key. So if I have to write a new row, at least those three fields have to be provided. And if I have to, let's say, edit the comment by Anita, I have to provide the three fields to identify the row I'm going to change. It doesn't really make sense to edit those values because that would be a different row, right? So it's more like if I have to change the reviewer, it's not an update of a row. It's more like deleting a row and creating a new one. So that's the role of primary key, uniqueness and defining which row I have to reach. Okay, now very briefly, somebody might ask, okay, but instead of using these three columns to identify the recipe and the review, or better, instead of using pizza to identify the recipe, I might have an ID which maps to a different tables that is sort of a relational table, basically, that maps a recipe ID to the name. Yes, that's not a problem. Why not? The choice between using organic or surrogate keys ultimately lies in well, I would say a matter of taste is, but more to the point, how exactly your application flow is. There might be cases where using surrogate keys is best. Other cases where using natural keys, organic keys is better. But this is really not something for today. We will stick to using the natural organic key pizza instead of using an ID and another table. But this is just to say that there might be traces of relationality in Cassandra, which, however, will have to be dealt with in your application and not by the database. As we said, there are no joins in Cassandra. You have to emulate them in your application. Okay, I would say so far so good for primary keys, and let's look at something more specific to Cassandra. Partitioning. This is something you saw already. Partitioning is related to the partition key. So we just saw, let's go back 1 second. We just saw that this table has 3 different columns that make the primary key: recipe name, date, and reviewer. Now, some of these columns, at least one, are also the partition key. The partition key is a set of the primary key columns, and it determines how rows are grouped together and how they are stored in the cluster, on which nodes they are stored. You saw that this morning, and we will see examples shortly. The point is that you have to know this to properly design your database to suit your application. So here there's an example of this recipe application. We choose recipe name to be the partition key. You see, I made it red to distinguish from the rest of the primary key. You see, recipe name is red, and it is the partition key. Now, this circle with the orange dots is my ring, my cluster, and each node is our orange blob. And you see that my one table is spread over the nodes. You probably don't see much because it's a mess, and I agree, but it is a mess because I used a replication factor of 3 because I'm in production. So every piece of data is on 3 different machines, which is good for production, but not so good for explanations. So let me do something not good for production, but very good today. I will bring the replication factor to 1 for clarity.
No.
Now. Yeah,
just kidding.
Yeah,
All
don't
good.
worry. We will have a replication factor of 3 when this application lands in production. Don't worry. But now it's clearer, right? So look at this table. This is a single table, and it has a lot of rows. But look, the rows are grouped by partition key. So all the rows with pizza are on one node. All the rows with pasta are on another node, and so on. And well, incidentally, there are a few nodes with more than one partition. That's okay. That's not a problem. And it will happen because usually you have many more partitions than nodes. That's absolutely not a problem. The important thing is that the opposite never happens. You will not have pizza split between nodes. Pizza is always all together on a machine, on a physical machine. And that's because we choose pizza as the partition key. Yeah, here's the summary of what we said. Each row belongs to a partition, depending on the value of the partition key. For example, here is recipe name. So all pizza are together. On which node? Well, it depends on the value in the partition key. There is a hashing algorithm that determines which node will host the partition. By the way, this is known to all nodes. So everyone is able to directly go to the right node when it's about a particular value of the partition key. So no need for communication, basically. And so the very important implication of this is that if you want your application to be fast, to be production level fast, and to scale to very big data, you have to write your tables so that every query always goes to a single partition. In this way, every query will go straight to one node, and even if you have 10,000 nodes, your query will be as fast as on a single node, basically, because there is no need to, so it will not scale in any way with the number of nodes and the amount of data, because it will always go straight to a single node. So this is the recipe for being able to scale to large volumes of data. Every query has to go to a single partition to avoid full cluster scans and performance penalties. And that's a very important point. Now, suppose for some reason I want to design my table differently. So it is the same table, the same data, but now I decide that the primary key is the same, but I partition by recipe name and reviewer. Look at what happens. The way data is distributed across the nodes is completely different. And in particular, if you look at the values of the partition key, which is now recipe name and reviewer, again, you will always see rows with the same values for the two columns grouped together. Look at the upper right. Salad Aldo, it's 2 rows, and they are always together. Now I have many more partitions. They are smaller, but still every partition is exactly on one node. It is just a matter of having chosen a different partition. By the way, once your table is made, is done, is created, you will not be able to change the partitioning because it's one of the foundational features of the table. Okay, so choose wisely, I have to say. Anyway, if you think of a different way of partitioning the table, the data will be very differently distributed. And if you remember this point, no query shall ever need to look at more than one partition, then you can imagine how first you look at your query and then you design the partitioning, because if you choose this different partitioning, you will be able to sustain different queries. Now, you've seen 2 different ways of grouping the data, so 2 different partitionings for basically the same table. And you might ask yourself, yes, but what is the right choice? And the answer is, it depends, because what is the query you want to run on the table? So you see the point. First, think of the query, and that will tell you what is the right way to partition data. Because the data is the same, so it's the reviews of recipes done by various people on different dates. But it depends on what I want to get from this table. If I want to be able to get all reviews of pizza by anybody, I will have to stick to the first way of partitioning. If I'm okay with getting just the reviews of pizza by Anita, so always in recipe and reviewer, and only that set of reviews, then maybe the second choice is okay. You see, there are pros and cons in choosing the partitions, and this question came up in the morning. So how to choose your right balance between basically larger partitions that allow for larger queries, so to speak, and smaller partitions, which probably make it possible to query smaller sets of data in a sense. The answer is in your application. So what kind of flow your application has, what kind of access pattern your data has to support. So on one side, you have giant partitions, which is a known problem. So large partitions, very large partitions are a danger for performance. On the other end of the spectrum, you have thin, small partitions, which is good system-wise, so performance-wise, but it might be too fine-grained to sustain your application flow. And finding the right middle ground for in this is, in a sense, the essence of data model. That's not the end of it, because you might just have a single application that needs to support different query patterns on the same data. So again, in our example, let's say my application has different workflow, has different flows, and there is both a screen that makes me look at all pizza reviews, and there is also another page in the UI that makes me able to see all reviews by Anita. So looking at what we just said on partitioning and queries, I think you can understand that a single table will not be able to make both queries possible, because either I partition by recipe or by reviewer in this case. No problem. Let's create two tables. Same data, duplicated, written in two different ways, two tables, and every query will have its own table. Now, attention, relational people out there. In Cassandra, that's absolutely fine, and that's actually one of the most suggested design patterns. I want to access my data in two different ways, two queries that somehow would not be possible in a single partitioning. I create two tables. No problem. Remember that disk space is not so expensive. What is expensive is slow access to data and losing customers. So no problem here. So what is the point? Table duplication. Goodbye relational, goodbye normal forms, goodbye relational patterns. Just embrace the normalization and have fast queries, right? Obviously, as we said, in this case, my application will be tasked with the duty of doing multiple writes. So what? It will do them, no problem. So you see, so in Cassandra, you have to make a query go to a single table. You have to. But as in this example, most likely you might want to have a single query per table as well. So that's one way is enforced, and the other is probably needed in most cases. And again, you have no joins, so this is how you go about it. Now, so much for partitioning. We just remind you of a few pitfalls that you might encounter when you create your table. You saw them this morning already, so no problem, but very quickly. You might have the case where everybody reviews pizza and nobody thinks of other dishes like I would do. I would just think of pizza all the time. And in that case, if my partition is recipe name, I might have the hot partition, because one single partition is constantly written, and maybe read. The others sit there idle, sleeping. So I might have a cluster of 1,000 nodes, but still it would be a single node responsible for all of the traffic. So I'm not using my database very well. And I have a clear bottleneck, the hot partition. So storage and load and CPU and everything is very much uneven. That's no good. So this is a point, and usually this makes me redesign the data model to accommodate a more even distribution of load and data and read-write workload. Another problem is that maybe my data model might be good for a little while, then time goes on. There is a bit of echo, Alex, sorry.
Sorry, are you sure? Let me check.
Okay, but not so big. So as years go by, my data model that was working starts to accumulate more and more rows in each partition. It's a bit like the IoT example with sensor this morning, right? So let's say a lot of people write reviews, and they are grouped just by recipe name and reviewer. So Carl, year after year, writes a lot of reviews of pizza. Eventually, the table will become, the partition will become too large, and it will not work anymore very well. Now, this is important. The point is not having a lot of data in the table. That's okay. That's what Cassandra is there for, a lot of data in the table. The point is not having growing partition beyond a given size. And the solution is bucketing, as we saw this morning. One of the solutions is bucketing. I can create a synthetic column, in this case, year month, built based on the date, just to group every month of reviews in a different partition. So I sort of limit the growth of partitions, because every month I will move to a new partition, and then I will avoid giant ever-growing partitions. And let me say you that probably my application will work the same, because I can hardly see a case where your application really needs to get all reviews by Carlo on Pizza forever from the very past. So that should be a good solution in this case. Okay, so partitioning. It's very important to know how it works and to know how your table will be partitioned, because otherwise your data model will probably fail somehow. The main lesson is that your query should always go straight to a single partition, which implies it will go to a single machine and then it will be fast. So the lesson is store together what you have to retrieve together. Easy. Then you should be paying attention to avoid the very big partitions, which means not too many cells, not too many rows, and not too many, megabytes in your partition. There are ways to estimate these sizes depending on your application needs and data model. And then you should avoid uneven loads. So you should be able to evenly distribute I/O and storage as much as possible. That's more or less it for partitioning. There is another point that is very important for completing this chapter, and it is the clustering, because so far we've been seeing the whole primary key. Part of it is the partition key. What about the other columns? Because in general, there might be columns that are in the primary key and they are not in the partition key. They are called clustering columns, and they define how rows are sorted within each partition. Think about it. If I have columns in the primary key which are not in the partition key, like the blue ones you see here, that implies that potentially my partition will have many rows, right? Because you might have different dates and different reviewers for pizza, and there will be more rows, several rows in the pizza partition. So the question is, how are those rows sorted? Well, they are sorted by clustering columns. You see, in this case, clustering columns are date and reviewer. So the leftover, if you forget about partition. And you can see that within the pizza partition, the rows are kept sorted by date. And if there were equal dates for two rows, then the sorting would be by reviewer, as is in the salad partition. So what is the point? Cassandra is very effective in keeping this data sorted. So everywhere within the belly of Cassandra, after insertion, data is already sorted, ready for you to be browsed in that particular order very efficiently. And the point is that one, because when you query a partition, you can query the whole partition, part of it, whatever, but data within the partition will be browsed in that particular order. So even choosing the right clustering within the partition is important, and it will be dictated by the needs of your application. Because if you have Cassandra scroll through contiguous rows in a partition, Cassandra is happy. If you start having Cassandra jump across different disconnected parts of your partition, that doesn't work. That's ineffective, and Cassandra actually does not let you do that in general. So even the clustering is important. And that's what I said. So how to choose clustering? You have to look at your queries. Again, because Cassandra is made to scroll in that order, no jumps. So again, depending on what are your queries, you have to choose a different clustering. So let's say your application shows pizza reviews. So reviews by a single recipe, which we already know means you partition by recipe. Very good. But then what do you want to do within the pizza reviews? Do you want to sort them by date? Do you want to sort them by reviewer? Yeah, those two cases require different clustering. You see here, if I want to sort them by date, I probably have to put date first in the clustering. If I want to list reviews by reviewer, if I want Cassandra to give me reviews for pizza by reviewer, I will have to put reviewer as the first clustering column in the primary key. Now, that being said, in a sense, so many queries will require different clustering, but don't forget that there are queries that are good maybe with any. In particular, if I need all reviews for pizza, I want to get the whole partition, so no big difference probably, but still. So my point is that clustering within the partition is important because even for clustering, depending on what your query does, I have to choose a different way of clustering. Now, I appreciate that so far I haven't shown you a single SQL statement, a single line of SQL. Now here we go. That's just, actually, it's not so different from what we saw this morning in the hands-on small practice session. This is how you create the table of the recipes in SQL. So here you see on the top of the slide you see the partitioning. So recipe name is the partitioning, which together with data and reviewer makes for the primary key. And I have two other fields. And this statement create table is how you do that in SQL, which is not so different from SQL, right? So create table name followed by column names and their type, data type. And then there is this important statement, primary key. Primary key is recipe name, date, reviewer. And in particular, recipe name is also enclosed in an additional set of parentheses, which is what denotes the partition key as part of the primary key. Then for the clustering columns, you see, I also want to specify the sorting, whether descending or ascending. And that's how we create a table. Easy. Okay, that was a very big section of today's presentation, and I want to summarize it with this one sketch. So my table has a primary key, which is connected to uniqueness of rows. And besides the primary key, there are the data columns, so rating, comment, whatever. And in turn, and this is very Cassandra specific, the primary key is split into partition key, which has to exist, and it will define partitioning. So any partition goes to a single node. Every query better goes to a single partition, otherwise performance is bad, which means that partitioning has to be chosen very wisely. The rest of the primary key, if there is any, determines the ordering within the partition. So how the rows are structured and kept within the partition, and how are they browsed when you query. And this also has constraints on what queries I can do. So it will be my queries, so my application will determine how I choose the clustering as well. Okay, I appreciate this was pretty mouthful of concepts, but it's very important. So I would like to stop 1 minute and maybe ask Alex, how are we doing in the chat?
So in the chat you have Jeremy and me, and that means what everything is answered.
Yeah.
There is just one very fresh new question from Narendra. What is the default ordering of clustering columns? Frankly speaking, I always prefer to define it explicitly, so I just really don't remember the default setting.
I think it's ascending.
I think it's ascending.
Not sure. Should be ascending, but usually, yeah, explicit is better than implicit because you might have to share. I mean, the statements that make your data model are a documentation for your data model. So it's good if they are self-explanatory, but
right.
Yeah, you can actually create a table and then do a describe table, and you will see the defaults play. But yeah, I don't remember either anyway.
And there is a great question by Rajiv. So you mean to say application requirement will drive the data modeling, more of a top-down approach? And my answer was yes, exactly.
Yes, you got it perfectly.
Yes.
And we will soon see how it works.
Yeah, soon we explain it in more details.
Yeah, it's nice. Okay, I'll save my comments on that for later. I mean, we will come to that in 15 minutes or so, because we are almost on time, so we should make it. Yeah, that's the most important part. So yeah, I would say every section here is the most important part. So pay attention, please. Okay, so let me continue, if that's okay. And we move to the section about how you query data and write data in Apache Cassandra. Because armed with this extensive knowledge on partitioning and keys and primary keys and everything, we are now able to look in detail at how queries are to be structured. Now, reading is more, let's say, important than writing, but let's say reading is more, has to be approached more carefully. So we will start with writing. Writing is not so difficult to understand in Cassandra. There is just a very big premise I want to make. Cassandra, as we said, is designed to be fast in writing, which means that, generally speaking, if you write in Cassandra, you just write. What do I mean by that? I mean that there will be no helpful Santa Claus in Cassandra that goes looking in your table when you want to write and checks if the row is there already and maybe issues an error. Nothing like that. So if you write a row in Cassandra, whether the row existed already or not, the last write wins. So if you happen to overwrite a previous value, it will just happen silently. That's very simple. That's because going to have a read before the write is executed will be terribly slow in general. And in most applications, in most cases, you can design your data model in a way that doesn't need to do this read before write. And actually, this is an anti-pattern in Cassandra. So be careful, because if you write, you might just happen to overwrite a previous value if there is any. Indeed, in Cassandra, insert and updates are basically the same. And there is a word called upsert that encompasses both. I say almost the same because there are corner cases connected with counters, but let's say that's a special topic. Let's forget about counters so far. So let's say insert and updates are the same. You just write. And that's important because in some relational applications, there is a pattern of trying to write and then catching an error if the row existed already, and maybe the application behaves in a way if the row existed already. That's not something you can do with Cassandra. But that's, again, for the sake of extreme speed in writing. You just write. Okay, that's a very important caveat because, yeah, this is how it works. In Cassandra, obviously, if you want to insert or update a single row, you have to provide the full primary key, because otherwise, how could you identify properly the row you want to write to? So this is how you do an insert in CQL. That's really similar to SQL. Sometimes also a deceiving similarity, because there is a very different underlying architecture, but still insert into table, and then you write a list of field names, column names, followed by values, and then a corresponding matching list of values. So this is how I insert a new review, or maybe a pre-existing review, which is overwritten, into my table. That's it. That's how you write. Okay, so writing is basically out of our way. Let's focus on reading. And there is a bit more to say about reading, because, as I said, the apparent similarity, so the superficial similarity of SQL to CQL might be deceiving, because there are, in the belly of Cassandra, there are big differences compared to typical relational databases. You should know many of them by now. So this is how you do a reading. And that's nothing fancy, I guess. Select columns from table where column equal value. That's it. So this is how I want all reviews about pizza from the table. And look at the results. It's perfect, no? Reviewer, rating, comment, and I get everything I need. My point is that behind this statement, there is a lot of fine print, all coming from the many subtleties with clustering and partitioning that we saw earlier. This translates into some very strong constraints on what I can put in the where part of this select. Let's look at them, because you remember, I want my query to reach a single partition. That's one point. Second point, reads within the partition have to be sequential in clustering. So what are the implications of that? Well, first point, I want to reach a single partition. That means that in my where, I better specify the whole partition key with equal sign. So as Alex remarked earlier, I cannot use greater or lesser in the partition key columns, because that again would imply having to look at potentially a lot of partitions. And that's not efficient. That's not going, so that would not limit my query to a single node. So I have to specify the whole partition key with equal signs. First point. Second point, I might want the whole partition, yes, or I might want to get part of it, maybe just a single row. Anyway, if I specify some or even all of the clustering columns, I have to do that in a particular way, because if I use a clustering column, I have to specify also all the columns to the left. So the more significant columns, if I may say so. Think about how rows are sorted and kept ordered within the partition. So if I want to specify a particular clustering column, I have to put an equal sign to all previous clustering columns. That's because Cassandra does not like to jump within the partition. It has to go contiguously through it. So yeah, only the last clustering column can have an inequality. So the last one I specify can have an inequality. The previous ones have to be there with equal signs. But again, nothing prevents me from just not writing anything about clustering, and I will get the whole partition. That's fine. That's a pattern, no problem. It will go to one node, all good. And third point, my where condition just can't reference any other column that is not in the primary key at all. So you see, there are pretty strong constraints compared to the freedom you have in a relational database. But they are, in a sense, the price for performance, for speed, for scale, for distribution of data. Now, there are various remarks here in order. One is about indices. So you can define indexes, and I will have some words on them by the end, but let me just say this. Yes, there are indices, but the bulk of your data model should not rely on them. It should be more like designing the right tables, vanilla tables in this sense. The second point is that there are ways to overcome these limitations, which basically tell Cassandra, yeah, I know I am doing a full cluster scan. Please let me do that. And this will work, but this is something you don't want to bring over to production. This is something more for testing or for very small tables, very small databases, not something that will scale to production. So the very famous clause allow filtering, I will pretend it doesn't exist today.
Yep, as we usually say, everything what you need to know about allow filtering, do not use allow filtering.
Yeah. Unless you know very well what you're doing, which will come later in your journey into Cassandra, I would say. Okay, so let's look at a few examples based on our good old recipes table. So recipe name is the partition key, and date and reviewer in that order are the clustering columns. So with this table, these 5 different where clauses are all allowed. Let's have a quick look at them. So the first one, recipe name equal pizza. That's good. That's a whole single big partition, but that's one single partition, so that works. This is a query that works. The second one, recipe name equal pizza and date equal something. Again, that's good. that specify a portion of a partition. But if you think about clustering within the pizza partition, that specify a contiguous chunk of data within the pizza. So that's good. Even recipe name equal pizza and the date greater than something is good, because within the partition, inequalities are okay. And this is still a contiguous block of rows. The same goes for the fourth example, where I specify recipe name equals salad. So I go to a single partition. That's good. Date equals something and reviewer greater than. That's good again, because the first clustering column is an equal. And within that part of that, within the portion of the partition of that date, I will get a chunk, a contiguous chunk in reviewer greater than, and that's fine because it's contiguous rows. All good, all nice. The last example also is good because nothing prevents me from specifying date greater and date lesser than. This is still, again, a contiguous block of rows within the salad partition. So these are all valid where clauses. So if I'm designing my table, this is important to keep in mind. There is pretty some freedom once I design a table of queries that I can do. But still, there are queries that are just wrong, that will not work. Look at those. Rating equal 9. That's not even a primary key column. That's sure not working. No. Second case, I specify a partition, pizza, and rating equal 9. No way. Still, rating is not in the partition, in the primary key. I just cannot use it in queries. No. Third example, recipe name greater than pizza. While I appreciate the idea of using the partition key, there's an inequality. So again, behind the scenes, that would require a cluster scan. I would have to contact a lot of nodes potentially, and that's not good. So no. Fourth example, recipe name equals salad. Good so far. And reviewer equal Carl. Wait a minute. I'm skipping date. Date is the most significant clustering column within the partition, and I'm skipping it. And that means I want to get leapfrog rows within the partition salad. So that's not good either. And the last example is just wrong, because even if I specify a date like this with an inequality, that would be good so far. So recipe name and date lesser than would be good. But then when I say reviewer equal Carl, again, I would like to have a leapfrog access within the partition, and that's just not good. So all of these queries are forbidden, verboten. No. Yeah. Okay, just for completeness, this is the full formal syntax for the select statement, and this is just something you can look up in the documentation. And just I put it here just to make you aware that there are a lot of constraints on what I can put in various parts of this statement, depending on the shape of the table. So there are some pretty strong constraints. And again, this is somehow the result that Cassandra chooses for the compromise between, speed, performance, and flexibility. This is just its philosophy. So, okay, so reading and writing in a slide. So let's not forget that when you write, first, insert and update is the same operation. And when you write, you have to specify the whole primary key to tell Cassandra what is the row you want to touch, basically. The important thing is when you read, you have very many constraints as a consequence of how the table is structured and how partitioning works. So you have to put equal signs to all columns in the partition key when you read. And when you specify clustering columns, you have to keep in mind that Cassandra wants to access contiguous chunks of data. So think of what you have to specify in the clustering requirements. And you can't use any other column in the where clause. So you see, there are a lot of constraints on the reading. So that's why you have to first think carefully of your queries, of the queries for your application, and then you create the tables. So I think now this is making more and more sense to you. Okay, so how are we doing with questions? I think you're keeping pace with anything there.
You know what? Yeah, in general, yes, but CK Wong managed to ask a question what got us unprepared, both Jeremy, Yoshi, and me. How Cassandra handles situation when we change value of partition key, like update something.
You can't do that.
No, not alter, but the update.
You can't do that. I think you get an error in CQL. You have to delete and then reinsert explicitly. I think it's.
I hope some of ours will make a little experiment because it's easy to check, especially with
I think you will get a very big red error in. Wait, maybe. No, that would take us too much time, maybe, but.
Okay.
Okay, so
that's answering live.
Set video ID equal.
Video ID is without underscore.
Sorry. Oh yeah. So update comments by video. Set video ID equal. Let's just do something where video ID equal no big deal, but paste and user ID.
You don't have to put user ID, I believe, here.
Oh, sorry, comment ID.
Yeah, I mean, yeah.
No, because I still have the big fonts, so.
Yeah.
Sorry. you find my little clip about the secrets. This is. Okay, let's see. Yeah. Primary key video ID found in set part. So yes, that's. I mean, the structure of the table makes it impossible. So yeah, you get a big red error, and if you really want to do that, that even conceptually means that you have to. You are not updating a row. You're just deleting a row and creating a new, uniquely different one. So it makes sense that you get this error.
That was a great answer, Stefano. Just perfect.
Okay, so you see, live answers are always proof of truth. Unfortunately, I think we are starting to run out of time, so I better go to the data modeling proper, because that's the core of today of this presentation. And let's look at how you really practically build your data model starting from your application. Okay, so this is the basic, let's say, flow chart on how you build your model with Cassandra. Let's say there is a big, there is a science to it. There is a whole formal procedure. You start with this and follow these steps, and then it's almost like an algorithm that will bring you to having your final data model all nice and ready. But there are also some choices that are left to you, to your sensibility in a sense, to your preferences. So it's a mixture of art and science. But all in all, the methodology to create a data model is a mature practice now, and I will just describe it step after step. The main point, as we said already, is that you start with your application. You identify what your application does and what are the objects it works on, which are the two first blocks, so entity relationship diagram and application workflow. You map one onto the other, which will make it evident what are the queries in your application. Now you know the queries, and we are at the logical data model step, and we can build a table for each query. The table will still be somehow an abstract kind of thing, so a logical thing. we will express it in a specific notation that is friendly for Cassandra tables. With the optimization step, we will do last checks and define a few small things and check everything and optimize and make it concrete, ending up with a physical data model, which is basically equivalent to having our create table statements written. So that's more or less the flow from left to right. You start with a general abstract idea and you end up with create table statements, one per query in general. Okay, so let's start. Entity relationship diagram. Well, that is the same as in a relational database. You just take a piece of paper, so to speak, you speak around with product managers, UX experts, whatever, and you end up with the abstract idea of what items and relations are in the game and what are their attributes. So speaking of the pizza and the recipe application, we have recipes, we have reviewers, and they are related by a relation, as you see here. So nothing new for relational experts. Both entities and relations in turn have attributes. So recipe has a name, maybe a preparation time. Reviewer might have a profile picture, URL, I don't know, stuff like that. Reviews also might have features, attributes, such as date, rating, we saw. And this is just an abstract schema. So you see, this is relations first. It is indeed the same as you would do in a relational data modeling process. At the same time, and in a sort of a mutually influencing fashion, oh yeah, so this is also a step where you start thinking of whether to use natural or surrogate keys. You remember recipe name or recipe ID with another table, stuff like that, but still. Okay, at the same time, you think of your application already before any table is laid out. So I can imagine an application where you see there is a proper workflow, a flow of the application. So what are the various steps, the various interactions of the user? So the user is at the center, and so the user experience is at the center in this process. So I think my landing page would be something where I can click on pizza and look at all recipes, so all reviews for pizza. So this is the first box. I want to be able to select all reviews for a recipe sorted by date. Okay, so let's imagine there will be a table behind that. Then two things might happen. The user clicks on Anita because there is the name Anita in this page, and they want to see all reviews by Anita, regardless of the recipe maybe. So there is a second block that is reachable from the first one in our application flow, which is I want to be able to see all reviews by Anita sorted by date. So pizza, salad, pasta, spaghetti, falafel, whatever. Probably there is a different table. I think we saw already this case, and there will be a different table, definitely. Now, they might also want to see some more details about Anita, and maybe this third page is reachable in various ways. Anyway, I want to see some info about Carl, age, email, profile picture, I don't know. So I should be able to select all details of a reviewer by name, for example. And that probably calls for a third table. So you see, this is a very important step. I need to have clear in my mind what how the application works, what is the workflow of the application. And usually every one of these steps will be a table and will be a query at least. Okay, so now it's time to combine the entity relation diagram with this flow. And to do that, the mapping step requires me to start thinking in terms of queries. So I can tentatively translate these three queries that were expressed in English into SQL. So look at what I did. Look at the first one. Select reviewer rating comment from the table where recipe name equal pizza and date greater than something. So these are the fields that I probably need. from the table I am about to invent, and look at the where clause. Let me go back. Look at Q1. Select all reviews for a recipe name sorted recent first. And this is the where clause of this first query. Recipe name equals something and date greater than. Now, I write date greater than because I know that this will basically induce my sorting within the partition. We can already say that. And also because in my realistic application, I want to put a lower limit in how far I go in the past. No, that makes much sense. Nobody wants to see a billion rows in my web page, maybe at the cost of 2 seconds loading time or whatever. Okay, now I'm almost ready to do the mapping, and this is it. So how do I get to the logical data model? You see, this is the step where I start from my query and I write the first draft, the logical form of the table. Now, the logical form of the table is expressed in this blue diagram, which is called Chibotko diagram, after the name of the researcher who invented it. And it is especially suited for Cassandra kind of tables. You see there are column names and symbols that tell you if it's a partitioning key or a clustering column with its order or other data column. Now, this is still a logical data model, a logical diagram. You see there are not yet data types and stuff, but the point is that from the query and keeping an eye on the entity relational diagram, I should be able to programmatically build this table because I start with what are the attributes, the fields I want to get back. You look at the select, reviewer, rating, comment, and so these fields have to be in the table. Okay, then you look at the equal signs in the where clause, recipe name. So that will become a partition key. Then you look at the inequality. Inequality means clustering columns. So I put date as a clustering column. Then I make sure I put the right arrow, so in ascending, descending, and so on. The ordering within clustering columns, if there is any. That would be it, except I also have to make sure that uniqueness is properly handled in the table. So reviewer, even though this query does not need reviewer to be necessarily a clustering column, but still I have to obey the uniqueness requirements. So I have to promote reviewer to part of the primary key. Indeed, I have to. We saw that already. And that's it. So by applying these steps, I end up with tables. At least, let's say I end up with a good draft of the table because I still have to do some practical things, so to speak. Yeah. Okay. So I have this draft. It's a good time to start thinking of whether I can anticipate hot partitions that are too large, ever-growing partitions. So whether everything makes sense in the light of the practical pitfalls we highlighted earlier. Let's say it's a good point to carefully review every problem that might arise. And now it's time to make this model into an explicit create table statement with everything, which involves in particular, I have to add data types to columns. Now, there are a lot of things to do here, to be said here. Cassandra offers very many data types, so I have to carefully choose the right one. You see, I have text, dates, integers, UUID. You also saw some ID type data types this morning. That's not the end of it, because I have very many solutions to handle denormalization in creative ways. There are user-defined types, which might be just, I can have a column of type user because I defined a data type called user, which is a structured thing. I can have collections and so on. And this is my small intermezzo about data types very quickly, because I mean, that's just something you can look up in the documentation. So I have text, integer, binary blobs, date, times, you name it. I will not mention counters much more than that because they have a special behavior and you can maybe learn how to use them later with all their limitations and powers. Important thing is that I can define a column of type list, set, tuple. So there are collection types, and you can also nest them. I can have a column of type map of maps, for example, which is a way to handle one-to-many, denormalizations. So I have some freedom. That's where the art part, the fantasy, the creativity part enters. User-defined types, you see I can define a type reviewer, ID, name, photo URL, whatever, and I can just define a column of type reviewer. Okay, so back to here. My only optimization here, just to keep it simple, is that I noticed that rating is an integer, yes, but it's always between 0 and 10. So why waste bytes when I can have the small integer data type? So that's it. I pick rating to be a small integer, and other than that, my table is ready. So my physical Chibotko diagram is ready, and it has become, as you see here on the left, a full-fledged working create table statement. Ta-da! Yeah, so this is the end of the process. So that's how data model works. And you notice, and I hope you appreciate, that in order to successfully walk through this process, you need some knowledge of partitioning, querying, and everything we saw before that. Okay, so this is the end of the data model section. And basically, the main gist is that you start with the needs of your application, and you end up with physical tables being created. Yeah. More to the point, you start from queries, and you end up with tables. In particular, partition key is dictated by what groups of rows I have to get at once for my query. Clustering columns are related to arrangement within the partition, so sorting and ordering. And basically, clustering columns, maybe, and for sure are the other columns, are what are the actual data my query needs for my application to work. Then you finish the work with the performance considerations, estimates, and physical details such as data types and such. And my main recommendation is spend a good deal of time on data modeling, because as we said already, changing it afterward, maybe when your application is working, is scaling up, is starting to show its limitation, and you have to maintain uptime and migrate to a different schema, different data model. That might be a taxing endeavor. So yeah, okay. So we reached the end of the most important part of this presentation, the core of it. Let me stop 1 second and ask Alex, how is it going in the chat?
All good.
All good. I hope there are no too many puzzled faces after this long ride.
No. It was a long ride, but
indeed.
It was a long ride, but very important, and it's mostly done. And I can say what there is nearly 0 drop rate, so you did great.
It's good to see so much interest, and yeah. So let's finish this presentation with just a quick mention of other tools for your belt. But let's not forget that what you just saw is the core. So the main pillar you should base your data model on is already something that is already what you saw so far. What I am about to mention, and I will mention it briefly because we have not much time left and because it's secondary, let me say, is just side things, collateral things. So first, you might be a bit annoyed by when I said that inserts and updates are the same. So there is no way to check if the row was already there or not.
I'm sorry, you will be even more annoyed when you will learn what insert, update, and delete are basically much the same.
Right. Yeah, because we didn't mention Tombstone at all, but okay. Anyway, yes, any change will never go looking at what was before in the table. That's the point. But I appreciate that there are special cases where you have to. So I want to create a user in my user table, but I don't want to overwrite a user that is being created at the same time with the same email, because then it's a mess. Or I want to update the status from in-store to shipped only once. I want to update the quantity of an item only in a consistent way. So there might be some small cases where I want to avoid concurrency and I want to be aware of what was in the table before the change. Yes. So if I do that at application level, that's bad, because I might run into race conditions. You can imagine two different APIs simultaneously reading, incrementing by one, and writing, and I might end up losing the count, for example. So what do you do? Now, there is something called lightweight transaction. So you can actually, by adding this special if not exist statement to the insert, you can condition the execution of the statement of this insert condition, and it will be executed successfully only if the row was not there before. So either fails if the row existed already or not. In the same fashion, you also can add if condition to an update, so that the update succeed only if, for example, rating was equal to 2 before doing that. So I will get an outcome that is either yes, I succeeded, or no, I couldn't because rating was 5. Very good and nice. So this is how you implement these special cases. Again, updating the price, updating your account because you made a purchase, creating a user row only if the email was not there, or changing the password only if whatever. Yes, so you can do that. And those are called compare and set transactions, or lightweight transactions, LWT. But there is a lot of attention here, because a very important thing is that you should not build your whole data model on top of this concept, because it's heavier than the usual Cassandra, the usual way Cassandra works. And if you are mainly based on this mechanism, then you are getting you have something wrong in your data model. You are you're damaging your performance a lot, because this is a mini transaction. It requires nodes to communicate, which is what Cassandra goes to great lengths to avoid. And do not be fooled by the word lightweight, because yes, it's lightweight in terms of it offers light guarantees, but not performance is light. Okay, so there is no global database lock. It's not a transaction. It's something a bit more localized, and yeah, so use it only really sparingly. So yeah, that's it. I will leave it at that, because I want to quickly go through the rest. Another quick point is batches. So you can, there is a way to send a bunch of commands, inserts, updates, and so on to Cassandra at once, and have Cassandra execute them in bulk, so to speak. And it is an atomic kind of thing, but it's not a transaction in the relational sense. So there is no rollback. And then it's not isolated. So writes are still executed one after the other, and you might happen to read halfway through its execution and get partially updated results and partially not. So this is very different. Okay, so this is a good use case. I want to insert the same data on two rows, on two tables that you remember that they just arranged the same data differently, but the partitioning might be the same. I just had different clustering. It's very legal and fair to do a batch, because it will go to a single node and it will be lightweight to execute. It's just a way to reduce network communication overhead in this case, because I'm inserting basically the same row into different forms. It will hit one node and so on. Another case, similar case, is I want to insert different rows on the same partition in the same table. So again, I'm going to a single node, so I might as well pack those inserts into a single batch and I send it. Super nice. The problem starts when I want to use batches for different things. So batches are not like bulk inserts. I cannot just pack everything together and send it to Cassandra, who will then take care of it. So this is absolutely anti-performance. There are other limitations, and in particular, if you use batches for something that requires more than one partition to be involved, then prepare for a performance degradation. Now, sometimes you might want to do that, but you should know very well what you're doing. So again, as for the lightweight transactions, yes, be aware that they are there. They might be useful, but use them with knowledge after careful checking, and do not base your whole data model on it, please. Okay, so we have a few minutes left, so I will just mention that this was also mentioned this morning by Alex, speaking about the problem of ever-growing partitions. A way to keep that under control and maybe also achieve other goals is to Cassandra offers the possibility of attaching a time to live to data, in particular to cells. So you can do an insert or an update specifying a time to live, after which the data will just disappear. But be careful, because this is per cell. So even if you insert a whole row with a time to live, and then maybe you update it, and you update the time to live just to a few columns, then those columns will disappear, the other will remain, and you will end up having basically a partial row, which maybe is something you want, but just know. But all in all, time to live is very useful to implement various mechanisms, especially if you want your data to just disappear when it's no longer needed. You can have Cassandra deal with that.
I would I would add one more point on that. Notice what using TTL, for example, for purposes of keeping disk space consumption on some reasonable level, TTLs do not lead to the immediate data deletion from disk. So data will be hidden, and you won't get that result in your select queries. But data will stay for some time on disk and physically will be deleted with the next compaction, which we didn't discuss today because it's more for developers and compactions are more for Cassandra operations. We have a special course on Cassandra operations on the Academy. So if you are not so much of a developer, but more of a DevOps or someone who maintains databases and let them fly, then you may want to take, well, I believe you should take our Cassandra operations course at the academy.datastax.com.
Yeah, that's a very good point. And so the point is that regardless, we didn't speak about compaction. The point is that time to live is obeyed by Cassandra exactly when you query, but when exactly disk will be freed depends on internal asynchronous cleanup mechanisms in Cassandra, and you don't have visibility over that from a developer perspective. So just keep that in mind. Nothing.
Now with virtual tables you do have, but yeah, I know what you mean.
Yeah, exactly right. So, right, Cassandra 4. Yeah, because we didn't mention that's incidentally after a few years of a very big effort in towards stability and testing coverage. A few months ago, Cassandra 4 came out, and it's by far the most stable release ever. Very strong and stable, and it offers a bunch of new features. So it's never been as good as now a moment to try and start with Cassandra, by the way. Okay, so something that I will just mention because we might consider it advanced or collateral topic. So far, we've been describing data modeling in the standard way, but actually Cassandra supports indices. Yes, you can build an index on an existing table, which will make it possible to query the table in new ways. But there is a lot of fine print. There are some caveats, and I suggest you to go and look it up carefully before starting using them, because indices will have data distributed according to the original table in general, and there are some limitations on what fields are good candidates to build indices on, and again, in many cases, you are better off by just designing another table and keeping it aligned in your application. But know that indices are there. And I think with that, I can conclude. So closing words. It's been, I appreciate it's been a very dense 2 hours. And you know what? Data modeling is very much more than 2 hours. So there is a lot more, especially you start learning how it works only after practice. And luckily we have you covered, because on this website that maybe Alex might drop in the chat, if you please.
Yep, I will.
You find very nice exercises, which are, again, done interactively in the browser with a real Cassandra installation running for you in the cloud. There is some theory, some explanations intermixed with exercises that you will do in these interactive scenarios, and they will end up with you having learned some things. And just as I mentioned, these scenarios were devised by Artem Chibotko, the very same researcher who basically formalized data modeling in Cassandra.
Yep.
So
I would say a word: if you are going to take an exam and to get the certificate for developer, I do recommend to visit this link I sent in the chat. datastax.com/learn/data modeling by example. There will be questions on exam based on those examples.
Yeah, so be aware of that. So every one of these scenario will end up teaching you something, and at the end of the scenario, you will see a nice congratulations screen saying, oh yeah, you made it, you finished it. And you know what? If you're interested in getting a completion badge, you finish any one of those scenarios, you take a screenshot, and you find that you send that to us. You see here the way to contact us on LinkedIn, the stx.io/Alex or Stefano, which is the two of us, and you will be awarded a nice completion badge. Which again is not the same as I can do the exam, but still it's a nice start. And this is how the congratulations screen looks like. So yeah, I think with that, I can finish here. It's been 2 long hours, I'm sure, for you, and I hope the concepts were clear. And yeah, really, this is just the beginning, because yeah, data model is a science and an art in itself. And I strongly encourage you, to go to the academy and enroll in the developer certification course, because that will teach you a lot. And it's also fun and full of very nice, well-done material, and it will strengthen your skills in data modeling a lot. So that being said, it's what, 15:29 for you in Singapore. So perfectly on time, Alex. Huh? What do you think?
That was amazing.
Okay.
And very, very useful.
So I hope you have written a few new questions in the Ask Me Anything, because that's going to start, I think, in a couple of minutes to give us time to collect our participants, and we will be back here, right?
Yep, so we will be back in a couple of minutes with Ask Me Anything.
Thank you.
Yep. Hey, hello everyone. We are back with Ask Me Anything session as a part of a Cassandra Day Singapore. And today with me, Stefano Lattini, right from the data modeling session. I bet you know him already. Jeremy and Yoshi, and I guess Yoshi is in new phase. So could you please introduce yourself?
Yeah, I'm a data architect covering the APAC region. I reside in Tokyo, Japan. And I've been to Singapore several times. Before the COVID time, it was mostly like every month. So I love Singapore. And I surely enjoy the food there as well. So yeah, I really want to be back there.
Yeah. Okay, so far we have Cassandra Days in online mode, but I hope when sooner than later we will have them also on site like it was before. That would be great. Okay, gentlemen, so we have 37 questions asked and we have not so much time, and I suggest us to start getting like from the very top of the questions. And as we have first question defined with first question defined as a winner, obviously, with 16 likes, like very much supported by Fred. Hey Fred, in YouTube chat you have links to contact me and Stefano, so please contact us to get your well-deserved prize. We have a great question that people ask us just all the time. What is the difference between Cassandra versus Mongo? That's one of the most popular questions, I can admit, on many other events. I will start with the answer, and then I hope team will support me. First of all, those are different databases with different approaches and many differences. The discussion may take an hour or more easily, and we have a lot of more other questions, so I will focus on two biggest differences between two of them. Cassandra follows strict schema, and MongoDB is so-called schemaless, or better to say flexible schema. Schema is just exists, it's just hidden it's just hidden from the developers. So if you never know what kind of data you are going to store and throw within a collection, MongoDB as a document-based database can be a good choice, and then you understand what you are going to store. Cassandra can be a good choice. Big difference for me is scaling for writes, because if Mongo scales very good for reads, for read operation like select or like retrieving some information from the database, then you speak about the writing data to the database. Cassandra beats Mongo quite a lot because Cassandra scales for writes very well because of a decentralized model, and Mongo in this case scales for writes much worse. Those are two main differences I would mention, and maybe gentlemen want to add something.
Well, yes. Sorry. Yeah, mainly the schemaful distinction, the master architecture, and all in all, I would say honestly, Cassandra has more potential to scale to very large number of nodes, very large data sizes. That's more or less the main points.
Maybe one more change, maybe one more difference I would mention also. Mongo has traditional, let's say, master-slave architecture, and therefore it has single point of failure. If a primary node is down in Mongo, you cannot write to it anymore. And as Cassandra is decentralized, you can write to any nodes in the cluster.
Yeah, so that's a good point, because let's say in Mongo, as far as I know of Mongo, that let's say the master goes down, then not all is lost, because then an election process takes place, and in a little time a new master is dynamically selected. But still there is this delay, this small interval so there is an anarchy, there is no master, and that is a weak moment for Mongo. That being said, as we like to say, there is an application for everything. So there are sure applications where Mongo is well suited. For example, I can imagine a very early stage application whose precise shape is not yet determined. And as we just saw in the data model process, if you want to be able to tweak your application along the way, because let's say you're a very small scale startup, you're starting to define your future project and you don't know yet how to make it work, then maybe Mongo is a good starting point, because it's really something that you can still change along the way, in a sense, easier than Cassandra for the first part. The risk is that this freedom is too much freedom. So somebody said that the power of a programming language is the more things the programming language makes it impossible to do, the more powerful the language is. And in a sense, it's a bit the same. So having all the freedom with a schemaless database is a bit like having, untyped languages. So the risk is that you start putting any sort of document in your database, then when the application starts to become more mature, you will risk having a mess, because you will have documents without this field, document with that other field that is sometimes a string, sometimes an integer. So it's a risky situation. And I've been through that, and I guess everybody saw the risk of this in a way or the other. So it's very important to be honest and realize when it's time to switch to a more structured kind of database, even without taking scaling considerations into account, in my opinion. That's being fair to the various databases that are out there, in my opinion. So yeah.
Jeremy, Yoshe, would you add something? You are muted, I believe.
Sorry, I was trying to get the echo sorted. So I would just say that there's two different ways of looking at that, I think, too. So there's operationally for a database, and then there's from an application developer's perspective or interaction. So I think from an operational standpoint, there are some differences in the choices that have been made from the CAP theorem perspective, like we talked about earlier, and that has already been mentioned. I think one other significant thing is that while Cassandra does sharding for you, you don't have to worry about that as an application developer at all. It serializes shards for you within the system. It's just naturally distributed. I believe under Mongo, if you do want to do sharding, you have to kind of explicitly define that and do some work around that. And so it's like Stefano says, it's depends on what you want to do with it, and then there is some overhead to that and some complexity around that. So the other thing I would say is from an application developer's perspective, there's the schemaless versus schema. And I don't know, Stefano, are we going to go into, as an application developer, talking about the document model of
No, not today.
Okay.
But that's why you better mention it now, because that's something that I've forgotten. It was very important.
Yeah, me too. It really worth to mention Stargate, which can help. Yep.
Yeah, so we have something called Stargate that can sit on top of Cassandra that gives you different interface points, API interface points into Cassandra. So you can speak CQL from Stargate, or you can speak a REST API or a GraphQL API, and it goes directly down to the database, or you can speak a document API. And the document API through Stargate is something that allows you to have a schemaless design. You persist JSON, a nested JSON, and it will effectively store that into Cassandra. It'll create a table for you and store it in Cassandra. You can even try it with, if you look under Connect in Astra, in your Astra database, you can store that and all the fields are indexed and all of that. So it sounds like we have a lot of echo, though. So perhaps whenever anyone starts to speak, we should the others should mute their microphones.
Okay, sorry, it's I'm very sorry. Found out it was on my side. It's fixed by now.
Okay. So that's another alternative. Is I think that we're through Astra and then through Stargate. There's an open source project called Stargate that can run on Apache Cassandra without any additional software, or through Cassandra, which is a Kubernetes way of deploying Cassandra along with different components such as Stargate. That allows you to persist the data in a document form. So from an application developer's perspective, obviously through the discussions that Stefano just had, there are very specific ways to model your data and you can index your data, or through Stargate, you can use it as a schemaless document API. So that's something that kind of brings those two worlds together a little bit more from an application developer standpoint.
Right. Okay, so I guess we answered this question in all the possible ways, maybe even too detailed. And I like this one. This is kind of my favorite. Cassandra is using eventual consistency or strong consistency. My very short answer, exactly as I said during the first workshop, Cassandra is using configurable consistency, and depending on your needs, playing with consistency level, you can reach different ways of a consistency from eventual to strong. But my recommendation is to stick to immediate consistency. Gentlemen, I'm done. Anyone wants to add something?
I think that's most of it. That's most of it. Just let me observe that in the cup triangle, it really doesn't make much sense to say goodbye to the P. So that's the choices between CA and sorry, to CP and AP. So yeah, that's all there is to say. Yeah.
Okay, one down. I love this one. Thank you for asking. Will there be Cassandra Day USA? At this moment, it's not scheduled. Currently, we have upcoming Cassandra Day Australia and New Zealand. And we are working to schedule Cassandra Day Brazil. But there is not yet Cassandra Day USA planned. But that may be a mistake, so we have to fix it. Yeah. We will discuss it for sure.
So, okay, I have to add something here as well, because that question was also on Discord, and I answered exactly how you said. So we are trying to cover the whole world in Cassandra Days, because that's a project we believe in a lot. And our goal is to build local communities. So obviously we give priority to places where the community has still to be somehow brought to the light. So since in the US, Cassandra is already a strong presence, so it will probably not be priorities. At least there are some other countries that we consider more prioritized to help building a local Cassandra community. But again, we will have a global tour of the world in 2022. So who are we to say we will not cover US as well? So yeah.
Yep. Okay. How Cassandra distribute the workload equally across the nodes? I guess, Stefano, let us give Jeremy and Yoshi to answer this one. How Cassandra distribute the workload equally across the nodes?
Would you like to take this one, Yoshi, or either one?
Sure. I think, I hope you can hear me.
Yeah. Yes, all good, all good.
Yeah, sure. Basically, so when we talked about the architecture and how the partitions are distributed among the nodes, that's basically the way that the workload will be distributed among the nodes as well. So the thing is that you would think of, well, if it's not a hot partition, like you're just bombarding one partition key. Otherwise, you would spanning all those workloads to the nodes in the cluster. So I did just mention about partitions, which is basically saying that I'm just going to talk with this partition key. In that case, you're going to bombard the nodes that have the replica. So in that case, you wouldn't think of it as distributed in a way. So that's some part that you might want to have in mind when thinking of workloads as well. Hope that makes sense.
Yes, definitely.
Yeah.
I would. Oh, sorry, Jeremy. You wanted to add something?
Yeah. I think just from a load balancing perspective, typically you don't put a load balancer in front of Cassandra. What you do is the driver, if you're using CQL, the driver itself has awareness of where all the data is stored in the cluster. And by default, it will, and you can specify different load balancing policies. It will round robin among the replicas. So if you're going to read from a particular set of data, it will round robin among the replicas of that data. So there's some intelligence built into the driver to make it so that it works well with load balancing.
Yeah, so you cover both the client side and internal within Cassandra also. Work is pretty well spread. Yeah.
That was exactly the point I wanted to add, and that's something.
We might have lost the signal.
No, we recovered it already. Something happened with Skype. It somehow switched the connection on its own. But okay, we are good now.
Yeah.
Okay, so this one is answered. Boom. That's again question what people ask us on basically each and every Cassandra event or conference. When shall we use Cassandra? What is the minimum data volume for Cassandra to be used? First point I would like to mention. Although Cassandra is indeed designed for to handle big data pressure, that's not always about exactly the data volume. So you have maybe not so high data volume, but you have clients across the world and you require very fast response time, perfect fit for Cassandra. Or you do need like highest possible availability on the market. You are not satisfied with 99.99999. You want to have something like 100% of time. With Cassandra properly done, you can have it, and to have it as a real disaster tolerant solution. That's not going to be simple and cheap, but it will work. So it's not always exactly about the data volume. The general idea thinking of the data volume, like should I already consider Cassandra or not, for me is quite simple. If you're using a relational database already and you start to think of sharding, then mostly probably you have to consider Cassandra. Then your data doesn't fit single server, you mostly probably have to consider Cassandra. Notice I'm not saying you have to use, because it's for you to decide in your situation. But to consider, that's for sure. That would be my answer, gentlemen.
Yeah, I agree completely. Especially in light of the stargate layer that we mentioned. It's even somehow easier than it was than it used to be to use Cassandra, even if you're used to different kind of workloads like a document DB. So you get the benefits of an underlying Cassandra without having necessarily to rethink your data model if this is what you prefer to do. So yeah, I second completely.
Yeah, and I do think that there's the scalability factor that you could start small, thinking of growing bigger business, maybe start from local and then grow your company into a global business. Then you're like covering all over the world and you have that kind of scalability. But you can start small, or you can use it for like development purposes, very small. Some CICDs type of things might happen as well. The scalability is there for you. So that's one thing you also have to want to have in mind as well.
Yes. Oh, sorry, Jeremy, do you want to add something?
Well, just that it's interesting. If you're looking for a use case, I think that oftentimes you can pick something that has strong requirements for Cassandra, so like availability or having multi-data center support or things like that, and then get familiar with it from an operational perspective, and then that way you get comfortable and confident with it so that you can expand its use where it makes sense. I don't think any of us would like you to use Cassandra where it would be a bad fit. And so if you can start with something that is maybe like greenfield or provides value, then you can get familiar and confident with it.
Yes, and that's a very important point. Thank you, Jeremy, for mentioning that, because I completely forgot. Take a look. There are no silver bullet in software architecture and databases. If someone tells you what this database is the best, just the best, abstractly, don't trust this person, because he is mostly probably going to sell you something. That is not one size fits all, and you shouldn't blindly go and put Cassandra on your production just because it's great. Yes, it is great, but it doesn't matter what your use case fits Cassandra. And there are other great databases what can be in your particular scenario a better fit. Some developers sometimes, like fashionistas, they see what Google uses microservices and they run and put microservices in place without real understanding if it will help them or create more troubles for them. So don't blindly follow the fashion, but really realize what you have and what you need. That's a very important point. And yeah, in some cases, Astra may be a better choice if you want to stay in Cassandra world, but don't want to maintain it manually. Also can be a good idea. So we have to move on. Okay.
Yeah.
I have worked on RTD relational database, I guess, like SQL Server, Oracle. How big database like Cassandra has benefits over SQL Server? I guess the main point is, what are the biggest benefits over relational databases?
Yeah. So, well, sorry. You want to take it, Jeremy?
Oh, I could start maybe.
Yeah, sure.
I was at a conference back in like 2011 or 2010, and somebody, I had a Cassandra t-shirt on, and somebody talked to me and said, "Hey, so you know about this or this or this?" And it turned out he worked for the Apple gift card redemption team, and they were looking at, Apple had a big contract with Oracle back then, and probably still do, and they were redeeming gift cards after Christmas, and they did a year-over-year forecast of how bursty the traffic would be to redeem gift cards, and they found that no matter how much they paid Oracle, in the next 1 or 2 years, that system would just fall over. It wouldn't be able to keep up, and so in that scenario, for the throughput of data, for write throughput, they needed something else. And so they chose Cassandra for that. And I believe they're still using it today, 10 years later, to do gift card redemption. So I think that it can complement existing relational database systems. And so for example, also like in banking systems or for telcos and other things, like I remember in the US, Verizon, for like iPhone launches, they migrated to Cassandra for phone activations, for instance, because the relational database wasn't able to keep up, and they would have slowdowns on those days. Somebody else have thoughts on that?
Yeah, that's more or less the main point, because there is, relational database is far from being imperfect. Actually, it's the most formally well-formulated way of managing data. The problem is that it has some constraints that makes it very difficult to scale at the absurd scale of data today. So you have to somehow make compromises. And yeah, most of what we were discussing today is about the kind of compromises that Cassandra chooses to do compared to relational databases. to be able to scale so much. So basically, when you have a very high scale need, you have to say goodbye to the comfort of relational world, because some concepts are very well formulated, but they just do not support scaling indefinitely high. That's a bit of the bottom line.
Yes. Okay, so next one. Yeah, this is quite interesting one. Does a higher replication factor value impact performance from read-write perspective?
Okay.
Let's say it very much depends on your consistency level. So, for example, doesn't really matter what's your replication factor. I mean, 3, 5, 40. Not recommended. But let's imagine if you have a read with consistency level 1, for example, or write, doesn't matter, the fastest answer will count, and therefore it will be fine. But you see the point, consistency level 1 is not widely used so, because it can be potentially dangerous from consistency points of view. Much more often, you use a consistency level quorum, for example. And with consistency level quorum, you have to wait for the majority of the servers. If you have consistency level consistency level quorum replication factor 3, you will wait for 2 answers, for 2 fastest answers. And there is a probability to run into slow response from 2 servers. So as a result, delay will present, but it's not usually an often use case. So normally a P99 is very, very good. P95 especially. And when you have a consistency level quorum and God bless your replication factor 40, that means what you will have to wait for 21 server response, and the chance to run into the some delays from my point of view will be significantly higher. So our recommendation is to stick to normally replication factor 3 per data center. In some cases you may want to have more, and in some cases for analytical use cases, then that's not a real data center what customers are working, but a data center dedicated for another kind of OLAP workloads with Spark, for example. So that's isolation of the different workload types, isolate customers from OLAP. Then in this case, you may have even sometimes 1 if you can afford losing this data center for some time. But that's not a general use case, that's a specific use case.
Yeah.
Gentlemen?
So yeah, if I may add, in practice, it will hardly be convenient to go higher than replication factor 3, so there is a diminishing return kind of thing. So if usually you stick to 3, so that means that you usually have quorum is 2, and that's it. On the other hand, yeah, as Alex said, what happens synchronously, it depends on the consistency level. So even if you have quorum, so even if you have a high replication factor, maybe many of the communication happen asynchronously, so it would have not terrible impact on performance, on IO performance, but a bit, yes, and that's the price to pay to have availability of data, so resilience. But yeah.
Okay, so I'm about to close this one, if you don't mind. Okay, looks like we are good. Good. Does Cassandra has cloud-only option available? Can I have Cassandra set up in my company-owned data center, not on public cloud? So, you have to distinct Cassandra and AstraDB. Cassandra is an Apache open source project you can deploy everywhere. You can deploy on Arduino if you want. It's not recommended for production workloads, but it will work. You can deploy on your own data center. Of course, you can deploy on your laptop. Then you use Astra managed Cassandra as a service delivered by DataStax. You have to choose between one of 3 cloud vendors, and that's a big difference. AstroDB is not exactly Cassandra, and Cassandra is not exactly AstroDB. Astro is managed solution. Like with Cassandra, you define yourself where you want to install it, and of course, it's available for your own data center. Gentlemen, I'm going to close this question because I believe I've answered this one.
And the same goes for the next question, I think, because short answer, if I may just say so, is Cassandra is free because it's open source software. You can install it and do whatever you want with it, according to the Apache license.
Yep. And so for Cassandra, there is no pricing, and for Cassandra as a service in the cloud. So DataStax AstroDB, that's a different story, and you better actually just check on the Astra website. But for educational purposes, for low amount of requests, it will be free.
Yeah, and if I may add a small point on the Astra offering, it's serverless, which means that in general, compared to many other managed database solutions, it's cheaper indeed, because it doesn't. Usually in the basic case, no dedicated servers are provisioned, so the prices are. It's very different from the typical $10, $15, $20 per month typical thing of any database offering in the cloud.
Mm-hmm.
But this is something that, you should go to the website and check the pricing. It's not specific to Cassandra.
Yes. Okay. How we have answered many questions. In the beginning, amount was 37. Now it's 35. Looks like we managed to answer only 2. Okay.
They keep coming. Good.
Yeah. That's great.
And we have
Thank
9
you for
minutes
asking.
left.
How will Cassandra handle inconsistencies in replicas in case replicas don't come back and timeout happens in hinted handoffs? Very good question. So hinted handoffs is a kind of graceful period of time when database will recover with self-healing. If node recovers within hinted handoff time, it will be self-healed. If a node don't come back within this period, then it has to be fixed with repairs, or maybe I've also made a recommendation quite often what in some cases, if a node was down for a day or 2, it's better to take it down completely, decommission it from cluster, and bring it back as a new. This way it may be like more reliable way to bring it back, but maybe Yoshi or Jeremy will give you another recommendations.
Yeah, so as Alex said, so by default, the hinted handoff time window is like 3 hours, but that's configurable. But you don't want to make it too much long because you're going to retain that amount of data on the coordinator node. So usually you don't want to span that. So if it goes over that, you would have to resynchronize that upcoming node with the other nodes, which is using a command called repair. There's some automated ways of doing the repair itself. It's a command line, but there's some tools as well, open source tools as well, called Reaper. And but as Alex said, if it's like quite a long time, for example, my machine has just got burned up and I need to provision another machine from somewhere, and it's going to take a week to get that. And nowadays, I think it takes quite a long time to get the new machine. So in that case, it may be better to decommission it so that the data will if it's off there, then you just remove that from the cluster and then add it back on and bootstrap it with the data that is remaining on the other nodes. So probably that's the better way, I'd say.
Right.
And just to add on to that really quick, I think to try to just summarize, I think Cassandra, because it's a distributed system and because it was built from the ground up to say, we know we're going to have a lot of replication throughout the cluster, and we're going to do our best to keep that in sync despite any one of a number of circumstances. There's multiple levels of defense against getting things out of sync. So hinted handoff is one of the first ways. You have read repair that happens in the background. So if you read something at quorum and one of those replicas doesn't match, in the background, it'll fix that after that read. So the next time it reads it, the one that was out of sync will get resynced up. And then like Yoshi said, there's repair in the background that you can have running continuously. There's all sorts of ways that Cassandra keeps things in sync. And then as an application developer, the thing that you protect yourself with is if the business rules require it, develop your code to just have immediate consistency the way it's been described today. But in the background, the database is working all the time to keep data in sync.
Yep. Okay, looks like we have answered this one. And next one I will take very quickly to save us some time. Where can we find checklist or best practices for client-side programming and Cassandra administration? So there are two answers. First answer is, of course, always academy.datastax.com. There are free courses for development and administration. And second link I'm putting in the chat right now. Those are recommendations of our data architects and field teams on how do you handle your Cassandra cluster and what are the recommended settings, best practices, and so on. I'm going to close this one. Do you have to add anything?
Well, there will be a small presentation on how to write applications for Cassandra after this AMA, and this is just scratching the surface, but yeah. There is also documentation on the drivers, which also guides you through the best practice and how to use the drivers, which is a good first point to start from.
Mm-hmm. Yeah. Okay, done. Does Cassandra support dynamic columns where columns do not need to be defined beforehand and all rows need not have same columns? Cassandra per se, no, but with the help of Stargate, mentioned it many times already, stargate.io, then you can use document API to work it, to use it as a document DB with no need to take care of a schema. Can we take snapshot or backup of Cassandra DB? That is a good one. So point is, you can, so with Cassandra reliability, usually you don't need a real backup in case of emergency and some loss of data, especially if you have multi-DC deployments. But still there are mistakes may happen and some developer can occasionally delete something. And so things happen and backup is still required. With Cassandra, it's very easy to organize thanks to SS tables. Immutable files, what you can just basically copy or make a link on that file if you or
you can put them to S3 object storage if you want.
Yes. So snapshotting or backupping Cassandra is very easy because of the append only approach and because of SS table of immutable SS table files. Yeah. It's really easy. Gentlemen, only one thing, before doing backup, don't forget to flush memory, flush data from memory to disk, and then files already. Gentlemen?
Yeah, I think that's it. The point is immutable files make it very easy to take snapshots, and they are actually smooth to do.
I was just going to say also in the Cassandra, so there's commercial tools that allow you to do this, and then there's also, so DataStax Enterprise has something that allows you to do that, and then in the open source, Cassandra has something, and even outside of Kubernetes, there's something called Medusa inside and outside of Kubernetes that allows you to do regular snapshots as well into S3 or another S3 compatible data store.
Right. Okay, does Cassandra support secure communication and data encryption? In short, of course, yes, that's an enterprise level solution which supports all kind of encryption, and security you may expect from the database used by banks and financial institutions. So I don't think they need any clarifications. I would close this one.
Yeah, so there is support. Indeed.
Yeah. How Cassandra is different from other NoSQL databases like DynamoDB or RAYAC? Speaking exactly of DynamoDB, DynamoDB is a AWS database. It's a proprietary database available for you only on AWS. Cassandra is an open source project you can use basically everywhere on Google Cloud or on your own data center, which you cannot reach with DynamoDB. In general, there is a lot of common between them. So there are some principles in DynamoDB and Cassandra that are very much the same, basically partitioning, for example. But in general, question how Cassandra is different from other NoSQL databases. Guys, for real, there are hundreds of NoSQL databases. Yeah. And differences may be huge and very different from one to another. So it's really hard to answer a question. We have, how much time do we have left?
Zero. Unfortunately.
Okay. Yeah. Let's quickly run through a couple of more questions.
Yeah. So just we have a dedicated workshops about introduction to NoSQL databases, where a bit of taxonomy of NoSQL databases is also done along with hands-on practice. So you might want to go in that direction. Reach us for more details if you want.
Yes, and we can discuss more questions in Discord.
Yeah. So maybe you want to reach us in Discord, and there is Alex, here I am there, and many other are there. We can help you with more specific questions.
Okay, and maybe the last question I want to answer. Even though I understand Cassandra is distributed for safety, but isn't it an overhead to keep same dataset in multiple nodes, which takes more space in total? My answer is very simple. Disk space is cheap, reputation is priceless.
Yeah, if you lose data, you have saved money for nothing.
Yeah,
basically. I mean, nodes fail. That's a law of nature. You have to plan for failure. That's the main point.
Yep. This one is also great. NoSQL database use cases are often coupled with NLP search engine requirements, Elasticsearch, Solr. Can Cassandra act as NoSQL database and NLP search engine both? Yes, basically you can couple it with Elasticsearch or Solr or Apache Spark or other solutions, and they perfectly work together. So yes, answer is yes.
There are even specific projects such as Cassandra, right? That's aimed at making the integration very smooth. Yeah, but still it's a matter of plugging this layer on top of Cassandra, which acts as a storage layer, basically. Yeah.
Okay, and I'm afraid our time is over. Thank you very much for questions. Will the stream be available for replay after today? Yes, always.
Yes, at this link. Just easily, you go to this link and you will see the recording.
Yes. Okay, so I think we are done. I'm very sorry.
It's hard to stop.
Yeah, it's hard to stop, but we have a next workshop or next talk coming in.
But seriously, please join us on Discord. So there, as we said at the beginning this morning, there the discussion can continue. So if you're curious, we are very much happy, and please let's meet on Discord, and we will answer all your questions.
Okay, so thank you so much. At this moment, we have like 1 minute break, and we get back to you after this little pause, and we will proceed to the last workshop of today, application development with Apache Cassandra, speaking of drivers, and how do exactly you work with Cassandra in the application.
Yeah.
So thank you, Yoshi. Thank you, Jeremy. And most of all, thank you all our dear attendees. It was a great time together. Next time we will try to allocate more time to answer your questions. But questions were great. Thank you so much.
Thank you, Yoshi and Jeremy. Thank you, everyone. And see you in a second.
See you in a second.
Thanks. Okay, so let's see. Okay, I'm live. So hi, everyone. Alex? Yes, I need my screen to be. Oh, I'm not sharing. Sorry, that's my fault. I will. Sorry, guys. We are almost there. We just had to fix this little technical thing, and there we go. We should be seeing my screen in a second. Very good. There we go. Okay. So hi, everyone. So this is now. This is the last talk of today. I hope you can. So okay, I'm sorry, I will have to jump back and forth. So please tell me if you're seeing me loud and clear, if you're hearing me and everything. Okay, great. So let me start. Application development with Node. So in particular with Node. Actually, this lesson, so this workshop, or better, this presentation is about how you write. How you use the driver for Node.js to connect to Cassandra, and we will see a bit of basic operations with it. Luckily, most of what you will see is valid for the drivers for other languages too. So these are actually more the best practice to connect with Cassandra and use it in writing your application. Okay, so let me jump to. You will see a bit of the nuts and bolts of this presentation because I have to jump back and forth to drop a bit of links. Let me immediately give you a link to a repository. This is the repository that comes with this presentation, and it will contain code snippets and a few other instructions. So as many of our readmes, sorry for the mise en abîme effect. Most of what you will see is sorry, here we go. Okay, so this repository has a nice README. I will show it to you later. So which makes it possible to be used as a self-service kind of exercise. It will just be a bit of snippets of code for easy illustration of the concepts. And let's go back to the presentation. Okay, so let's start from the start. You want to write an application. We just saw in the data modeling how you plan for its backing database, and all is right and nice, and the engineers came up with a nice data model, and you have the database here ready to be used, and you have your application. You need something in between, right? You need a layer to communicate between the application and the database. Usually, you need a driver. So your API or maybe your serverless functions, whatever your architecture, will communicate to the database using a driver. Nice and good. And that's the standard answer. As we happen to mention a few times today, this is not the only choice because there is this layer called Stargate. That is an open source tool, and it provides a data layer and multiple paradigm API that makes it possible to interface to your Cassandra database with plain old simple HTTP requests, and also offers, as we mentioned, document API, data API, so you can GraphQL, you can access your database in various ways, and that makes for, say, offers many options to communicate and connect to your database. But today we will see the traditional approach, if you want, the drivers one. Now, drivers for accessing Cassandra. Good news is there are Cassandra drivers for most popular languages. So C, C#, Ruby, Node.js, Python, Java, and they more or less offer the same set of advanced features. So they have asynchronous API, object mapper API. They can maintain reconnection, retry policies, health checks, load balancing. So they are all pretty advanced. And that being said, today we concentrate on Node.js. That's just an example. It's very similar to the other drivers, obviously with obvious differences, and the features are more or less the same. Now, here is where you find the documentation. And as I okay, here there is the link to today's examples. Now, this is not a hands-on practice because we have a limited time, and there would be no time to actually have to go all of us to do the exercises. So this will be left for you as an exercise if you want to get more in detail. And by the way, in the repository, you find also the slides, so you can go and look at them at your own leisure. Oh, I did something. Yes, I clicked the link. Sorry. Okay, so I don't know what happened. Let me go back to presentation mode. So maybe. Okay, let's go like this. Maybe it's better. Sorry. Yeah. Okay. Maybe I can do something better now. So let me go this, and here we go. Okay. So this is it. Very good. Okay. Sorry for. Okay. So let me jump to the repository here and show you. So this is the repository that I just gave you the link to, and it's pretty well documented, so you can just follow along and later do the exercise by yourself. Obviously, we do not assume you have installed Cassandra, you have your own installation of Cassandra to do the exercise, and by the way, they differ in how they are installed. So in this repository, I will not assume anything, and if you follow the instructions, there will be instructions to connect to any kind of Cassandra database, including AstraDB. Now, in particular for AstraDB, this is what I'm going to live demo today. So I will have my own AstraDB database. As you saw this morning, there is one called Node Practice that I created already, and you might want to follow the instruction to do the same if you want to play with AstraDB as an example. And in the repository, there are instructions to do the setup. The setup, okay, since these are just a bunch of snippets of code that exemplify various aspects and various ways to access the Cassandra database, there is some preparation needed. Namely, you have to prepare a workspace, a key space, sorry, and you have to to create a table and populate data and set up a bit of things for connecting. Luckily for you, this is all ready on my machine, and so there is some setup, connection to your database, creating your AstraDB or your local Cassandra if you want. You should create a database name and a key space name with a particular name just to make the examples work smoothly. Then you should check that you are able to connect. That involves creating an authentication token and similar things. It's all documented, so I will not spend time on it now. Then you should check that you can connect with AstraDB, and you should create a table and populate it. So there is quite some preparation, which would not fit in the time we have today. And this is why I have done everything already. Just every step in this repository is well explained, and there is also some inline help with animations that show you how to do everything. So I will start the practice later from step 4, when everything is set up and ready to just run the code. So back to us and back to the slides. Let's get to the point. So let's speak about Node.js. First remark is that the same drivers are good for connecting to any kind of Cassandra in the wide sense. So not only open source Apache Cassandra, but also DataStax Enterprise, which is the commercial version, or AstraDB as well. Indeed, today I will exemplify a few commands with AstraDB. So how do you install it? We are speaking NPM, we are speaking Node.js. So you just do an NPM install, which in dependencies translates to this snippet. So nothing fancy here. This is just how you add the dependency. All nice, all good. And let's get to the first important parts. How do you connect to your database from your application? Now, you remember Cassandra is a distributed database. The nice thing is that the drivers are very smart. So you can, when you connect to the Cassandra data center, to the ring, to the cluster, you just give the drivers on your application side, you just give the drivers the address of at least one contact point. What is a contact point? Any node. You give the IP address of 1, 2, maybe better 3 nodes, just in case one is down. And from these contact points, the driver will ask them, hey, who are your peers? And this contact point will answer with the whole cluster topology. Because, you know, within Cassandra clusters, nodes speak constantly to each other using something called the gossip protocol. And they are always very much up to date with the status of the cluster. So this is an operational remark, but if you add a node to a Cassandra cluster, you don't have to change much in the configurations, because basically the node will learn of this new node dynamically. So this purple contact point will reply, yes, this is the whole cluster, and the driver will then keep that in mind for later communications with the database. So that's cool, and that's all automatically handled by the drivers. Okay. So that being said, how do you practically connect to a database? Well, this is how you import in your Node application. This is how you import the package. Then what you do, you instantiate a client object, a Cassandra client object, with giving it various properties, various parameters, configuration, in particular, these contact points addresses. And from this point, then you specify a data center and the key space. Now, these examples of today work on a key space that I called chemistry, and you will see them. They contain basically the periodic table of elements in a Cassandra table and other things that you will see. Okay, so back to how you do it. You create this instance of client, and then you call connect, you do your things, and then you call shutdown. That's it. And that's how you connect to a general Cassandra database. Now, in the case of Astra, the situation is slightly different, and the only difference is actually in the config part. So Astra is in the cloud, so it's not much based on a list of IP addresses, but there is a file that you can download from the Astra UI. It's a zip file containing a bunch of certificates and IP addresses and similar configurations. You just pass it to this client. It will be able to process it. And if you pass this connect bundle, so-called this zip file containing certificates and stuff, and also credentials that you went to the Astra UI to create, you're able to connect all the same. And from this point on, usage of this driver is very much identical. So I say that because all examples in the repo are able to run in both cases. And today my little practice will be run on with the Astra case. So let me go to the Astra console here. And first I will show you that this is something that I've set up already, as is described in the README. So I already have my database called Node Practice. Let me open it. You see there is already a key space called chemistry. And since I cheated and I had this ready for you, let me quickly go to the CQL console just to show you what is in this key space. So if I use chemistry, which you remember means I just take the CQL console and I tell it, please let me work within the chemistry key space. So are there tables already there? I hope so. There is a table called elements. Let's see how it is made. Select splat from elements. Let's say limit 10. Oh, nice. This is a table with columns symbol, atomic mass, atomic number, and name. And as you see, it is just chemical elements, not much fantasy here. So symbol is the partition key and also the primary key. So you see carbon, etc., etc. This is just a test table that is made to work with the examples, by the way, nothing more, nothing fancy. Okay. So back to the slides. This is how you connect to Astra. And this is the first. So I have a lot of very small snippets of code that are made to run as a standalone script in the repository. Now, to better illustrate them in this presentation, I will try to run them in a repo, in an interactive Node.js console, just to keep the connection open throughout the examples. Except for this one. This will run as a standalone thing, and this is a full-fledged small script that, let's look at what it does. It creates the client, instantiating it to connect to a database. You see, client equal new client, as we saw before. And in the main function, I connect. And this is how I run my first query using the drivers. You see, I just take the same query I would run in the SQL console as a string, and I called client point execute. Then I do something with the result, because client.execute, query is the argument, will return a promise on which I can work, reading the rows, iterating over the rows, and printing something. So you see here I select symbol and name from the chemical elements table, and for each one of the rows that are returned, I print something. So very simple, and then at the end, I will close the connection. So let's see if I manage to run this example. I should have a console here. Let me make it a bit bigger. Maybe that might be too much, but should be, at least you should be able to see it. Node code 01 setup, sorry, node code 02, connect connection Astra. Let's see. Okay, I think. Oh, that's a, sorry. Yes. Yes, I forgot one very important thing. In connecting, you see, okay, this is, sorry. Yeah, you see, this is what you see on screen is the example to connect to a generic vanilla Cassandra installation, but actually I'm connecting to Astra. And if you look at the code here, what it actually does is it reads environment variables for secrets, as it's standard practice. And I just didn't source the file that contained these environment variables. So yeah, sorry for that. So that should now work. It will, oh, look, everything worked. So that was what the code does. It reads the table, it gets a bunch of rows, and looping over them, it prints what you see. So a very simple example just to check that everything works. So this is how your minimal example to connect to Astra or to Cassandra in general would work. Very good, very nice. Now, I think I can now, that was something I run as a standalone code. Again, all of the details, how to run these things are in the repository. So now let me just open a REPL node, interactive console, and instantiate my client for later usage. Don't worry, I'm just repeating the connect part to keep the connection open easily. Okay, so back to the slides. This was just the first example how you run a generic query. You take a string and you call client.execute. Now, before executing more queries, let me get this out of the way. Actually, when you pass the configuration to the client, you can give more, you can specify more stuff to how the client will communicate to the server. You can set a specific load balancing policy, as Jeremy just mentioned in the Q&A session. You can specify parameters on how to reconnect in case connection is lost. You can specify a retry policy when a statement would ever fail, and so on. Okay, so with that being said, let's look closer at how queries are executed. As we just saw, you have a string containing a SQL statement, and you just client.execute it. Don't forget that this statement returns, in general, a promise. So I'm here awaiting it, just because I want to block until this finishes and then resume my execution. And if you look at this statement, for JavaScript, it's just a simple string. But for SQL, this creates a table, because I'm not happy with having just a table for chemical elements. I want to create a special table for metals. Why not? And it will have 3 columns that are kind, name, and density. In particular, I will have kind as partition key and kind name as primary key, so uniqueness. Don't mind much this kind. It will be clear, I hope, later. So let me just, so I want to create a table, but for kicks and fun, I want to create it within Node. Why not? So here it is. So maybe I have to make this just a bit smaller. This is exactly the same creation command you saw in the slide. Let me just paste it here. So this is a schema operation. It will take a couple of seconds more to execute because it's a huge thing as compared to just a very quick insertion and everything. And apparently it worked. How do I check if I created this table for real? Well, I can go to my Astra SQL console and I can try, you remember this command, maybe describe tables. Let's see. And sure enough, I see my metals table. So this is a simple execution of a statement that I sent to the database for execution by SQL through the Node drivers. So it seems to work. Back to the slides. Okay, so these drivers are generally based on asynchronous execution because there is a lot to gain in this kind of IO-bound statements in any programming language that supports them. So this in JavaScript takes the shape of promise-based execution, or I will show you later, callback-based also. But this is not so different in other languages. So there are the equivalent asynchronous ways to use these statements. Okay, so let's have a look at a few write statements, because you might say, okay, if I have to write data to a table, I know how to do. I take a string and I client.execute it. Yes. So look at this one. I'm inserting into the metals table a regular metal named copper of density. Actually, this is very much wrong from copper. Copper is much heavier, but let's not mind this. Okay, so this is a very simple one-line insertion, and by now you know how it works. So let me take this copper insertion and run it into my REPL. It seems it has worked, and I can select from metals. There you go. Copper is there. So I know that my Node drivers are indeed working because I can see the results in my SQL console in Astra. And it wouldn't be different if I had a regular Cassandra installation. So that's all good and nice. And back to the slides. This is one of the many ways I can insert and can write data to Cassandra. Indeed, it's not the best because you see, it has various problems. So this is a very much discouraged way of running insertions because I have to, everything is just a big string. So I have problems with serializing because this is a waste. So this is a number and I'm using 4 bytes for it. So this is a waste of bandwidth. I have to escape, say there is a quote in a string, I have to escape it by hand. That's terrible. And I am also prone to, injections. Say this is an API behind a web application that's very much insecure because in general, script kiddies might find a way to, inject their own statements somehow. So what is the best practice? You separate the statement from the values. And look at what I'm doing here. This is a very similar insertion. I'm inserting the regular metal called palladium with that given density. But look, now client.execute has an argument, which is a template for insertion with placeholders here. Insert into blah, 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 columns. Values are placeholders. And the second argument is a matching array of values. Look, they are a string, and a number. Very good. But then I need a third argument that contains type hints. That's because earlier we saw that Cassandra has very many fine data types. So there it has floats, integers, doubles, binary blobs, a lot of data types. And they do not map one-to-one with JavaScript types. So we have to provide the driver knowledge of the type of the fields, of the columns in the table. So I have to say text, float, matching this list. And this way, the query will work. And let's see. Now so now I'm running this query to insert Palladium, and you will see it worked. Now, you will soon get tired of having to check on Astra, but there you go. Let me go back to the statements, and let me just show you what happens. And I anticipate a serialization error if I just forget about the type hints. There's an error, and this error boils down to a serialization mismatch. See, it was expecting one thing and it was getting another thing. That's because there is no way for the drivers to guess the proper data type here. How do you make this easier to use? There is another best practice here, that is using prepared statements. That's very important, because usually your application will use the same statement over and over, the same insertion over and over. Let's say I have to insert a lot of metals. What you do is you pass this third argument, prepared true, to all execution. So you see, now I'm inserting zinc, no type hints anymore, but just prepared true. And later I'm inserting mercury, another metal, prepared true again. What means preparing a statement? It means that between the driver and Cassandra, a communication happens, and the nodes on the cluster maintain memory of this template, this blueprint for insertion statements. They know the typing. There is no need for type hints anymore. And as a bonus, the statement is quick and ready to be reused. So I save. So the handshake needed to get knowledge of the data types is done only the first time, and then insertions are fast. So statements wait there to be reused again and again on the client, on the server. Let me show how it works. This is how you do. You just pass prepared true. So this is what I'm doing also here in the console. I have a string that is my statement string. And I do my first execute to insert zinc. It worked. No type hints, no, just preparing. And I promise you that if you run this second insertion of mercury, it will just work again, and it will. And the statement now has already been prepared and is there for me waiting for on the server. So I save a bit of milliseconds again. Okay, so that's now the customary check on the table. But you see, mercury and zinc are there. All right. So let me see. Okay. So apparently I'm doing all insertions all right. And that's not the end of it. I just want to illustrate how you, so far I've been lazily awaiting all statements because that was not what I wanted to showcase. But now let's go a bit more in detail with the promised asynchronous way of handling executions in these drivers. So we say that execute in general returns a promise. Indeed, I can chain this execute method with a then and a catch, as you usually do in JavaScript. So client execute some insertion, then I print something, and catch, I print something like an error message. So this is the standard way of handling promises. Just for you to know, I'm trying to insert, so somebody hijacked my metal table and they want to insert a metal band. So instead of inserting, copper, palladium, platinum, whatever, they insert AC/DC. And the kind is not regular metal, but it's band. Okay, that's just for fun. But this is how you would work, right? So client execute, then you get a promise, and you chain with the standard way of handling promises. So let me show you how this works. I just paste the same snippet of code you saw in the slide. And maybe I'll still do yet another check on Astra console. And there you go with our new metal band. So all nice and good. And let me go further. So this is not the only way of handling asynchronicity in these drivers, because there is a nice thing. If you don't want to deal with promises, but you like callbacks, you just have to pass a fourth argument to the execute statement. So the very same execute statement, arguments, so parameters and prepare, the fourth argument can be a callback. See, if I pass a fourth argument, which is a callback of a function of 2 arguments, this will be invoked when the insertion finishes. And this execution will not return a promise anymore. So asynchronicity is handled as a callback in the callback framework. So you see, in this case, if there is no error, I assume there is a result, and otherwise there is an error. So this is just all contained in the callback. So now let me insert this metal band, Iron Maiden. Let me go and get this callback code snippet, which is just working as expected. So the insertion succeeded, and the code within the callback was run, the successful branch, and so I get my insertion. If you look at the code in the repository, they are a bit slightly different than what you see in my notebook here, because there are the connection is, they are all standalone scripts, so the connection is closed within the branch, but that's the only difference, so no big deal. Okay, so that was it for writing. Let's look at reading, because how do you get results back from Cassandra in your client application? Again, the execute method is there to help. So again, this is the typical way you would read data. So client execute, what? Again, first argument is the template of a statement to execute, where I have my placeholder. Second argument is the parameter. So now I want to read all metals of where kind equal band, which is a partition, incidentally. I prepare this statement, why not? And again, execute has 3 arguments. It will return a promise. So in the then branch, I will read. So the then branch needs a function of result, which is the promise content. I will read rows of result, and I can iterate over these rows. And for each one, I will be able to access named fields named after the column. So this is how I loop over the bands, and I will print them after running the query against the Cassandra nodes. So I expect to be able to read AC/DC and Iron Maiden. Let's check. So this is the promise-based reading. And there you go. So this is my result. Everything worked. Maybe I'll just skip the. Okay, so callback is very similar. Again, let me skip this because I want to get to the final part of this presentation. But this is not different. So I would have a callback, and so the same thing that we saw for reading apply here to this case. So no big deal. Now there are various other ways to read results from Cassandra, because the client object that we instantiate also offers a native each row method that is there for me ready to use. So not so different. It has a slightly different syntax. Again, statement, parameters, prepare, and then it gets 2 different callbacks. The first is executed at every row that comes back to me. You see now I'm printing it, just it. And the second is the second is both for errors and end of results. So okay, you will see this 5th argument is a function of error, but if error is null, that means I just reached the end of the results. Otherwise, there has been an actual error. Okay, so this is now I'm reading the regular metals, so I expect to be seeing copper, zinc, etc. And I will print the density as usual. So this is the each row based way of running. So each row reading, let me run it. Again, let me clean the screen a bit. There you go. Indeed, everything works. So this is how you do the each row method. So this will just get all rows and make them available one by one in a callback-based way. Okay. Now, you saw batches already. I will skip this demo for reasons of time, if it's okay for you. Let me just say that there's no big difference. You just prepare your statements, more than one, in an array. And then you pass this array as first argument to something that is the client batch method, which again will return a promise and so on and so on, or a callback, the usual convention apply. So this is it for batches. Okay, so let me see. You know that I have to have a look at the chat, at the YouTube stream now and then. Sorry. Okay. So let me go to another topic, which is maybe more important for serious applications, because real-life applications might have different workloads. So within a single application, I might need some reading to be done at a different consistency level. Some reading to be done with a different timeout, why not? Some others might have a different retry policy. They might want to reach a separate data center and so on. All of this can be done in a very clever way with a single client. So usually what you do is you define execution profiles. As you see here, I'm defining several execution profiles, which contain some subset of settings, and they have a name. And when you instantiate your client, you pass them in an array. And then, if you want, every time you run a single statement with client execute, in the options, you can pass execution profile this one, execution profile this other one, and those settings will be applied for that one query. And this is how you achieve mixed workload kind of situations, which comes very handy because real life applications might have different needs. So let's say there is a table where I can tolerate missing a bit now and then, and there is another table where I want to make sure the reading is consistent, so I can have to change the consistency level between queries, and that's how you get to it. Okay, actually, while we speak of options to the query, again, there is more to it, because you might also want to just set consistency. For example, on the fly, when you run this one query, you can set timeout, you can set policies and so on, just live when you run a single query. In particular, look at this fetch size parameter, because that's interesting. I will show that a bit more later. Because, so far we've been running queries that just go to a partition and get everything of that partition, which is good usually, but sometimes the partition is too big for that, and it's better to, get results a bit at a time to avoid, having network packets that are too large. And this is when paginations come in. But so far, we just say with this fetch size, we just say, this query will be treating results in blocks of 2. So I will just get 2 rows back in this case. By the way, the default is 5,000 because we assume rows to be usually very small. So 5,000 is not that big. Remember, they are supposed to come only from a single partition if I did my data model in the right way. So that's not a problem with latencies, right? But okay, so this is it. Now, no demo is good without a complete working example of a mini API. This is what I always say. And that is the reason why I have a mini API ready for you to show. So let me show you this mini API. What you see here is the whole code of an Express-based API that makes it possible in a REST-inspired way to get the list of metals, get a single metal, and insert a new metal in the table. And as you see, there is nothing new here. It's just a few pieces glued together. So there is some infrastructure as Express.js requires me to do. And then I just attach to various routes, various operations. So I have a shared client instance here, and I do different kind of client execute, returning the rows in the case of getting all metals, preparing the specific query, reading query parameters for the query to Cassandra if I want to get if in the endpoint that gets the single metal, and preparing some insertion in the right way if I want to run in the endpoint that makes it possible to insert a new metal. So nothing particularly new, just putting together stuff. So I encourage you to have a look at the repository for the code, but let me run it if I, in very simple way, node code 04 API, API.js. That should be it. So the API is ready. And as you see here, the API can be, so to test it, it's so simple that I want to test it just with a couple of curl messages, curl commands. So here, let me try the endpoint to get all metals back. And there we go. So I just, you see, curl localhost port / metal, and this is what I get back. So the reading is working. Let me get a single metal. You see now I'm querying the endpoint metal / silver. Seems that I did something very stupid somewhere. Okay, so that's funny. Sorry, don't know why. I know why. Maybe not found. I see. Maybe silver. I didn't. Oh yes, I know why. Sorry, because I was afraid to go out of time. So I think I didn't insert silver indeed. So let's query for mercury, right? So do you like mercury? Let's see. Mercury. Yes, and there you go. So this is how you get back your own metal. And if you look, I just create an execute with one of the parameters taken from the request parameters. So I just take this silver from the request name, I put it here, and this is part of my client execute. So this is how you just transport the name silver all the way to using the driver. Now we do something funnier and we insert a new metal called harmonium, which I don't think exists. So just for fun, insert it through, and this is something that I want to check here in the SQL console, and indeed harmonium is inserted into the metals. So everything seems to work. Very good, very nice. Okay, so this is my mini API. Now I want to spend a few words on pagination, but I notice it's a bit late on time, so I will leave running this example as a homework for you to get acquainted with it, the drivers. Just very simply, I already mentioned that all the read queries we saw so far are made to return just the first page of results. So fetch size defaults to 5,000, whatever the value of fetch size, this is the maximum number of rows that the query will return. If I want to get more with a pagination mechanism between the driver and the server, I can just use, there are various ways. One is using the asynchronous iterator. So basically this construct for await, etc., will make it possible to automatically handle pagination in the driver, because the driver offers this asynchronous iterator that handles, getting the next page. That's one way. Sorry, but I have to skip the live demo now. Another way is to pass auto page through to the each row method. That's absolutely behind the scenes. I don't even notice basically that pagination is in place. I can just trust the driver to handle everything behind the scenes, and that's also good and nice. But there are cases where I have to handle pagination manually, because I might have a web application with 10 results and then a button next. So I have to let the user decide when I want to go to the next page, for example. That's why so the driver also exposes explicitly a string that is page state, and I can just use the string coming from the previous call, the previous batch of results. I can pass it here to the next execute invocation, and that will make the server return me the second block of results. So I can go on and manually handle this page bookmark, and consume the whole set of results. Please remember you will be able to run these examples by yourself. There are other ways, so you can also use method next page explicitly within the each row looping construct, and this will also trigger execution, trigger arrival of the next page. And there are particular workloads where it's best to use this client stream method, because this is really on demand. So if you have a CPU or time-intensive computations to do on items as they arrive, and you want to avoid, filling up your local buffer, you should use stream that is, stream-based. So there is no, it handles back pressure in a sense. Okay, something else that I want just to mention is that so far you have been seeing SQL statements basically, but that's not the end of the story, because the Node drivers as well as other drivers offer also an object mapper that makes it possible to treat basically a model around the table, which is automatically created. So you can create, look at this new element here. I can create an object with fields as in the column names of the table. And then this mapper can insert, get, remove, and so on. So you can work with, and by the way, the mapping of data types and everything is handled behind the scenes for you. So that's pretty good. And that's not the best thing, because in my opinion, the best thing is that when you create the mapper here, look at this first yellow part. When you create the mapper, you can give more than one table name to this model. And according to the name of the columns in the various tables, this one single insert statement might trigger multiple insertions on various tables, exactly as the denormalization dictates. So that's very friend with the denormalization data modeling way Cassandra is based on. So this might be very useful. Okay, so far for the driver features. Remember that these are also basically the same in the other languages. So drivers share the same set of advanced features we've been showcasing in Node now. I'll come back very quickly to Stargate. We happen to mention it a few times already today because that's cool. And this provides a good alternative to drivers, because you might want to use a different paradigm to access your data other than SQL. Why not? So you might want to use a document-based, schema-less kind of thing. You want to use GraphQL, which is all the rage now. And to do that, you can just plug this Stargate open source API data gateway on top of your Cassandra, and then all communications between your client or your API, whatever, and the database will be done by HTTP requests. Actually, there are also SDKs to make this easier, but the concept is that you could also do that also with plain old requests if you want. Yeah, so as I said, Stargate is HTTP request, and it offers various interfaces for the same data, basically. So, okay, these are just example. This is a small set of commands that you can run in Node. So you see, I can basically, this is a document-based API. You can get documents, sub-documents, variable schema, schemaless, whatever you want to call it. You look at this fine syntax. So it offers something very similar to Mongo. We were mentioning Mongo a few times. But all of these, as you see here, if you don't want to rely on SDK on a particular language, you can also do plain old HTTP requests, and they are the same. That's not the end of it, because as I mentioned, you can also do GraphQL kind of queries. As you see here, this is a big string, but it's actually a GraphQL kind of a mutation, or maybe not. This is a query, sorry, but that's the point. And you can embed them in your code, and Stargate layer will be taking care of making it into so making it possible to interface your data from outside with variable kind of communication API specifications. Okay, so this brings me to the conclusion. I gave already the link to the repo. Please go there, and if you are interested, just have a look at the code snippets. They should be able to run out of the box after setting up your database, whether Astra or Cassandra, no problem. If you find problems, just reach me anyway, for example, on Discord, and we will, or if you're curious, just let's keep in contact. This is the link to Astra if you want to have a quick database to experiment with, and this is about Stargate. And speaking of Stargate, if you're interested in this other way to communicate to your database from your code, I spent most of today speaking about drivers. And when it comes to Stargate, you are invited to visit our workshops, because we run many workshops, several per week. And those about writing applications are usually using Stargate. So there you find a lot of coverage over the various use cases, GraphQL, Document API, you name it. And again, there are a lot of repositories which are, again, self-contained. You can just go to the repositories, explore them, and running them locally or actually on Gitpod, so nothing to install usually. And you will learn a lot, and you will see much more detail than what we saw today about using Stargate. With that, these links I think you already saw. So Academy for learning and getting certifications. Community, if you have questions, it's a bit of a Stack Overflow about Cassandra. Let's keep in contact again, and in particular, reach us on Discord. And I think that you can now start writing your wonderful Cassandra applications.
Great job, thank you.
I thank you.
Thank you, and that's incredible job. I'm very happy what you made it with us, and that was incredible. Would you like to run the closing words, or I will?
Yeah. Let me find them.
Okay.
Here, it's really a few slides.
Yeah, not too much.
So I think it's been a long day.
That's for sure.
For all of you, and maybe for us as well. So we've been looking at a few. So many of you probably started this morning without a very good idea what Cassandra is, because otherwise you wouldn't have attended. Now, we consider ourselves successful today if some of you developed an interest, and if we were able to give you some, let's say, to wake up your curiosity and to give you some starting points to begin your journey, because Cassandra is a big thing, and that's only the beginning. I just hope that you have been having fun today, and that we were able to give you as much information as was possible.
I'm afraid there may be some heads exploded during the workshops.
Okay, it will take time to digest all of it, but luckily everything is recorded. You can watch and rewatch and rewatch. You can reach us for questions. You can look at the GitHub repository, the material, and study and get prepared and get your certification. And we are all happy because, in a sense, our mission here is to bring the power of Apache Cassandra to as many developers as possible and make them know this very powerful technology and maybe ensure you are using it the right way. So to make its power, to use its power. So I think this is the wrong one, sorry. I forgot to change this and I apologize for that. But the important thing is that we would really like to get some feedback on how this Cassandra Day was for you. And because, this is a series of events that started and it's growing and it will become better and better, especially thanks to your feedback. So this is why we ask you to give us some feedback. And actually, there is a link here. Maybe, Alex, you can paste it in the chat. There is a link, DTSX.io, CD Singapore voucher. And that's a feedback link that we use to collect a bit of suggestions for the next events, because that's not the last Cassandra Day, and probably it's not even the last Cassandra Day Singapore, who knows? And the important thing is that by filling out this form, you will also be able to receive your free voucher, which might be valid either for some credits, some additional credits on Astra, besides the one that you will get monthly for free. And in particular, this will be a voucher valid to get to take the certification for Apache Cassandra certified, either developer or administrator, for free. And this is something that would cost $100 and something, and this is sponsored by us, again, because it is in our interest as DataStax that as many people, as many developers as possible are using Cassandra in the right way. So
yeah, because a lot of people misuse that, but you are not like them, you are much better.
Yeah,
and there are one point, voucher gives you 2 attempts, so if you are successful with developer certification, you can also pass administrator path and take administrator exam, so you can get 2 certificates out of 1 voucher of overall value of almost $300. Yeah, and those certifications are really can change your career and your life in the end. That is quite cool.
Yeah, so the certification can give you a competitive edge for real in the job market. So yeah, how to start with preparing for the certification? Yeah, academy.datastax.com is a very good starting point. Then there are the interactive scenarios. We gave you the link already. And if you want to see how the exam works in practice and with some sample questions, we used to run a workshop about the certification exam with sample questions and discussions. And if you watch, there are some recorded workshops on that in our video section on YouTube. So if you look for certifications there, you will find examples, and you will be able to run sample questions there for yourself. So you can have an idea how the exam would look like.
You spent so many time with us, and that's incredible. Now you maybe feel tired, and that's well deserved, I guess. It was indeed very a lot. But you know what? It was not time. It was invested time, and this investment may grow into something great and beautiful in the end. Now we ask you, go and build something great. So first take some rest. You deserve it. But afterwards,
enjoy your weekend, what is left of it.
Yes, but afterwards, go and build something great. Build a better engineer out of yourself. Build a new great project or upgrade your existing one. That also counts. And we're always happy to hear your feedback and success stories. Maybe sometimes not so success stories, so we can help.
Yeah, both ways. So success stories, welcome. And if you have trouble, if you run into trouble on your curious, just reach us, and there is Alex, there is myself. There are a lot of very valid engineers and data architects ready to answer you and help you on the chat, on Academy, or on community, on the Discord channel, and we are also happy. We are always happy to help. And you know what? That's very important. If you have some stories about your usage of Cassandra, next time you might be the one speaking at the next Cassandra Days.
Absolutely.
And we are always happy to collect stories, real stories in the field. And maybe you find out some specific interesting advanced topic because you're studying, and we will be happy to hear that, and for the benefit of the community. That's exactly how the community is built. So please reach us also, and in particular, if you will in the future have something very interesting to tell the world about.
Yes. So I believe we are done.
Yeah, that should be it.
Thank you for warm feedback.
Enjoy your weekend, and it was a pleasure to be here today. And yeah, See you next time.
See you next time. See you next week, and a little bit of music in the end to relax.
Oh, yeah.
You do deserve that, and we do.
Database music, you mean, right?
Schemaless. Yep, sure.
Oh, very good. Very good.
Thank you, Lim.
Thank you,
Jia Sheng. Thank you, Narendra Anda. Thank you, Ricardo Campo, and all the others who stayed with us for such a long time. For all the others who was not able to stay for such a long time. It was incredible Saturday. Enjoy your weekend. Thank you.
Bye. Thank you.